Hello everyone, welcome to this session on AWS full course. Today in this session, we will be teaching you AWS from scratch, and this is especially for people who do not know anything about AWS. So if you do not know anything about AWS and you have the time to follow our video today, you have come to the right place. You will learn everything about AWS in detail today. Alright guys, if you're interested in the course material, the code that we will be using in this lecture today, please put down your email and we will be sending it across. Also subscribe to the Intellipaat channel so you never miss out on updates on any of our upcoming videos. So let me go ahead and tell you about the agenda that we are going to cover for this video. What is AWS exactly? And then talk about the various service domains which are there in AWS. Once you're done with that, we'll move on and talk about a very important concept in AWS, which is AWS VPC, which are the networking concepts in AWS, and then move on to do a hands-on, which will basically not only implement the networking concepts that you will learn, but all the service knowledge that we have given to you. Now guys, once you have thoroughly learned all the AWS concepts, we will introduce you to what DevOps is and then talk about the AWS DevOps services which are there in the AWS Management Console. Finally, to sum everything up guys, we will basically talk about how to build an end-to-end website like Netflix on AWS. And once we're done with that, we'll move on and then talk about the job prospects as to once you have the knowledge of AWS, how you can start applying for job or how you can actually become a cloud engineer. And finally, we will also be talking about some of the most asked interview questions that can be asked to you in your next AWS interview. So guys, this is the agenda for this video. We hope it is clear to you. Now let's move on and start off with our lecture with the first topic, which is Introduction to Cloud Computing. So guys, cloud computing is nothing but the use of remote servers on the internet to do a particular task, right? Now you would ask like, why do we need to connect to remote computers when I can do everything on my personal computer? Now imagine if you have an application which requires a lot of processing, right? So what will you do? Will you buy a server which has a lot of processing power, put your application over there and then see how your application is functioning? Or if I give you one more option that you can rent a server from a cloud provider and basically do a RDP or an SSH into that, put your application over there and see the working of that application, how it runs. And I'll also tell you that the moment you are done with the server, you can just give it back to me and I'll charge you only for the time that you used it. On top of that, what if I tell you that it's as cheap as $0.0005 per hour? Isn't that amazing? And that is exactly what cloud computing is all about, guys. So cloud computing for a beginner, it's nothing but the use of remote servers for a personal needs, right? And rather than using our own computers or rather than buying servers of our own, I just want to rent a server on a cloud and I will pay them accordingly to the time that I have used, and the prices are as low as the figure that I just told you, right? So this is what cloud computing is, guys. Now you would wonder how it actually came into the picture, right? So let's go ahead and understand that. Alright guys, so let's take an example to understand this. Imagine you're a developer and you created your first app, which you think is going to be a hit, right? So how do you make this app available to the world, right? Or how do you make this app or website available to the world? So what do? You buy some servers and you put that application over there, right? And just putting your application on the servers would not do it. You'll have to connect it to the internet. And once you connect it to the internet, that is when people start to come on your application, come on your website and start to use it. All right. So this is how typically work used to be done. Now I want to take your focus onto certain things that I just said when I was explaining you this example. First of all, I will have to buy these servers. Right? And guys, servers are not cheap. They're very expensive, and buying a stack of servers will already cost you a lot of money. And you're not even sure whether your app will be a hit or not, right? You've just created your app and you want to try it out and you put it on some servers, and because you want to make it production grade, obviously you'll have to buy a stack of servers, which is going to cost you a lot, right?
Second thing is you will have to configure everything manually. If these servers have to be connected to the internet, you will have to do the connections, to this servers manually. You'll have to set up a static IP address. So you'll have to contact your ISP and say that, I need a static IP address for my servers so that people can just go to one particular address and they can visit it. After that, you again have to buy a domain. Let's say if you go to Intellipaat.com, you see the website, right? So what is happening? Intellipaat.com in the backend, the domain is getting converted into an IP address by a DNS server. And then that IP address is basically pointing to the servers, right? So you will have to buy a domain, you will have to point that domain to these servers, and that's how it used to work, right? And obviously, if you have these servers, you'll have to hire a team also who's gonna manage these servers in case the number of users increase. You'll have to increase the number of servers, etc., etc. There are a lot of things that you'll have to do. And because of these things, there were some problems. And because we wanted to overcome these problems, we use cloud computing. Right now, like I said, you were using this kind of an architecture before. Now let's see if we don't use this kind of an architecture and I just use cloud computing, what is going to be the difference? The difference will be that I created my application. Next thing is I'll go to AWS, I'll launch a stack of servers, I'll put my application over there. AWS automatically gives me a static IP address. It has a service to basically give me a domain name as well. I would just configure my domain name to connect to this IP address and I'm done, right? It's so much ease that I don't have to hire a team to manage my servers because AWS says whatever servers you want to launch, I'm going to handle it for you. Not AWS, it's in fact any cloud provider for that matter. All the servers are managed by them. All the hardware upgradations are managed by them. Everything is managed by the cloud provider. And that is why cloud computing model itself is such a big hit, right? So what are the advantages? The first thing is that there is little or no investment. So I don't have to buy a stack of servers to get my application up and ready. I can just rent them, right? And the cost is minimal for launching the stack of servers and basically getting them up and ready, right? I don't have to invest much. Even though I'm starting fresh, I've just launched my application. I don't need seed money for setting up an infrastructure, which is going to be huge for the whole world to see. Right? The whole world can access your application, but you don't have to worry about it because AWS is backing you up, right? So there is little or no investment. Second thing is more focus on app development. So you can focus more on app development than worrying about whether my infrastructure is fine or not. How is the traffic coming onto my app? Is my infrastructure scalable enough that it can handle all the traffic which is coming onto it? Everything is managed by AWS once you configure it correctly, right? Third thing is it requires less workforce. So like I said, if you are buying your own servers, you obviously have to have a team which is going to manage your servers for you, right? Any hardware upgradations, any security patch that you have to do, all of that is done by a team. Correct. But if you are launching your infrastructure or if you're creating your infrastructure on any cloud provider, the cloud provider's headache is to manage the servers. It's their headache to do the security patches. It's their headache to improve or upgrade the hardware once, the processors become slow. So all of that is managed by your cloud provider, and all you will do is focus on your app, focus on your business goals, and then succeed towards the goal that you have, right? So this is an advantage that you get when you use cloud computing, and that is why most of the companies today, so I guess only the companies who started out earlier, that is before cloud computing came into the picture, are still working on their own servers, hosting their own applications. But companies who are very young, who have just started out, for example, startups particularly, they prefer cloud computing or they prefer their servers to be on the cloud, because obviously when you are starting off with a new company, you have very limited amount of money that you can invest on things, right? So it's always a good idea to invest on the things which are required, and rest, if it works in a certain way that they are not costing you much, it works that way, right? So for startups especially, cloud computing is a huge thing. It's a huge bonus, and that is why you can see a lot of new business ideas are coming in. A lot of new people are trying out their own app or their own websites to provide a particular service. Reason being, the major part of starting up a business was setting up the infrastructure that is handled by cloud computing these days, right? And that is why you can see more and more young companies are coming up and they are trying out an app. If they fail, there was little investment investment involved in it, so it doesn't matter. And that is what is encouraging the entrepreneurs of this age. So guys, these are the advantages of cloud computing. Moving forward now, because cloud computing is so huge, there are a lot of products which are available on cloud these days, right? And you won't even know whether they exist in cloud or not. For example, Netflix is the biggest example that everyone is probably using every day in their life. The popular service Netflix, which is a movie streaming service, its entire infrastructure is on AWS. Everything from A to Z, the scaling part, the content delivery network, the networking part, the security part, everything is handled by AWS. Now, don't worry guys, if you don't understand the jargons that are just used, like content delivery network, security, everything I'll explain in this video. For now, I just want to tell you guys that because of the advantages that cloud computing has to offer, and because of the kind of services that you get from cloud, companies such as Netflix, Airbnb, Amazon itself are relying on the infrastructure of the cloud providers so that they never go down. Now, how did it come to these companies' minds to, switch to cloud? So I'll give you a very small example. Netflix suffered a huge blackout on the internet, I think in somewhere around 2008 or 2009, wherein all the services were down. Why? Because the more number of users came up to use the service, and that's when the service crashed, right? The whole application went down, and it caused a huge loss to the Netflix company itself, right? And that is when they decided, dude, I cannot manage all my servers. I can either do the app development or I can manage the servers. There's only one thing that I can do. So then Netflix started to migrate itself on the AWS infrastructure, which is highly scalable, which is highly available, right? And now seldom do you see that, Netflix service is down. In my experience, I've never seen Netflix down since I've been using it from the past 2-3 years. I've never seen Netflix down, or I've never seen an error that, the server is out or there's a problem with the infrastructure. I've never seen that, right? And that is because of the high availability that is provided by the cloud providers these days. Netflix is just one example. Other businesses that we are all aware of is the Amazon e-commerce website, right? The Amazon e-commerce website is also hosted on the AWS infrastructure, right? Now, a company, an e-commerce website whose bread and butter comes from a website, from being online, right? Imagine they are relying on the AWS infrastructure that all of you guys also have, access to, right? So imagine yourself, you're sharing the same infrastructure which the biggest e-commerce company in the world is using. So you can be rest assured that your application is in safe hands, right? Another great example of cloud computing is Google Drive. So Google Drive is a cloud product. The Google Documents, the Google Drive where you can upload all your files and folders, they're all hosted on the Google Cloud, right? And that is again a fantastic cloud product. Then we have Airbnb, which is actually a website which is hosted on AWS, and it's fully hosted on AWS for all its functionalities, scalabilities, and availability. Prime Video, which is video streaming service for Amazon, that is also hosted on AWS. And the funny thing is Netflix, which is its biggest competitor, is also hosted on the same infrastructure as Amazon Prime Video, right? Awesome, isn't it? So these were all the products that you see in your day-to-day life that are actually cloud products, and you won't even know whether they were on cloud or not. So now you know. Moving further, guys, now let's talk about the cloud computing models. What are the different kind of models that are in cloud that are there in cloud computing, and what are models exactly? So guys, cloud computing is basically divided into two kind of models. The first model is the deployment model, and the second model is the service model. So how do we get these two categories? The way you can deploy on cloud has 3 ways to it, and the way you can access services on cloud has again 3 ways to it. Right? So one is about putting your application out there. So if you're putting your application out there, you have 3 options, either to use public cloud, private cloud, or hybrid cloud. If you're using a service from cloud, you again have 3 options, which is infrastructure as a service, platform as a service, and software as a service. Let's understand all these things one by one. Don't get carried away with all the big words used here. We'll understand each and everything one by one, and then as you move along, if you have any questions, you can put it, right? So far, guys, I've not got any questions. I guess everything is crystal clear to everyone. So moving forward in the next slide, I'm going to start with the deployment model. So if you have any questions, now is the time, guys. You can ask me all out and I'll be happy to answer it for you. All right. So Shambhavi has a question and she says that Netflix is using AWS. So that means all the videos that we see are also hosted on AWS. Yes, Shambhavi, all the videos that you see, the software itself, the website exists on AWS. Okay, so she has one more question. But when I install the Netflix app, it's available on my mobile. How is that on cloud? Okay, so Shambhavi, there are two sides to it. Netflix application, it's basically a client application. The videos that you get, they don't exist on your phone. They're actually streamed from the internet, right? So your Netflix application is just a client application, but it interacts with the AWS servers on which the Netflix servers have been deployed. All the videos that you see, there's a service called Amazon S3. All those videos, they exist over there. They're stored over there and they are basically provided to you using a content delivery network, which is basically nothing but a caching system. That is, I'll give you a very simple example that if you are residing, let's say in India, and you are watching, let's say, a US television show. So obviously that US television show is would be existing on the servers of the Netflix US, right? But if you are viewing in India, it doesn't make sense to stream all the way from US your video, right? So the server has to be connected through the internet from the US to the Indian client app which is existing on your phone. That's a long way. Right, and that's when the concept of latency comes in, wherein how does an application respond to your queries also depends on how far is the server from your application, right? So there's a service called Content Delivery Network, which basically what it does is it caches all the videos that you have to see or you're watching onto an Indian server. If you are in India, right? And that's when, a server which is nearer to you has all the content which exists on the US server. And this is all on demand, right? So this is just very simple, a very small thing that Netflix does to improve its service using the AWS infrastructure. And this concept that I just told you is Content Delivery Network. Don't worry if you don't understand what I just told you. As we move along, I'm going to explain this in detail. All right. Any more questions, guys? All right, so everybody is giving me a go. All right, guys, so if everything is crystal clear, let's go ahead and discuss the models one by one. So the first model that we're going to discuss is the deployment model. So what are deployment models? So guys, deployment models are nothing but the various ways using which we can deploy our application. All right. Now there are various ways. Let's look at those ways one by one. This is the first way of deploying your application on the cloud infrastructure is called public cloud. Now, what is public cloud? Public cloud is are the servers which are offered by your cloud provider, in which each server can have multiple companies hosting their application. All right. It could be your Netflix and it could be that your, its competitor, that is Prime Video. If you have offered for public cloud, your application would share the same server as some other application. It could be Prime Video as well. Right. So, but why is there a segregation? Although there is no problem when there are multiple applications on the same server, but what happens is some companies are still skeptic. Some companies have data policies that they say that, we have confidential data and we cannot take any risk where, some other companies also on our server and there's a risk of our data being hacked into, right? So that's why, because of these data policies, there were different deployment models that were created. So like I said, public cloud is when, the data that you're providing to the cloud is not that sensitive, is not that confidential, and hence you are okay when AWS tells you, although there will be no problem when a separate application is also deployed on the same server, there will be no harm to your data, and they say like, okay, anyways, we don't have any data policies like that, right? So public cloud is when you are using or the cloud computings or the cloud providers servers and you allow them to host more applications on the same server, you're okay with that fact. All right, so that is public cloud. Next is private cloud. What is private cloud? Private cloud can be two things. The first thing is, like I said, if you want a separate server all for yourself, where you say no matter how much space is empty, no matter how much of the server is free, I don't want any other company's data on my server. I want my data to be isolated. I want it to be isolated on this particular server that you have in your infrastructure. So that becomes a private cloud. The second way of creating a private cloud is you buy your own servers and you create your own cloud in your data center, right? That is, you buy all the stack of servers required and you host your application as if you're hosting on a cloud provider. It's just that it's your own cloud that you have created, right? You have bought your own servers and you're putting your data on your own servers. So that is private cloud. Okay. So the third thing is hybrid cloud. Now, what is hybrid cloud, guys? When you want to have a kind of infrastructure wherein you are using some of the public cloud and some of the servers from the private cloud, in that case, it becomes a hybrid cloud. So let me give you an example. Let's say there is a research company. So that research company, the marketing website for that research company exists on the public cloud, but on that marketing website also people have the access to log in, and when they log in they can see their research materials that they're working on. Okay, but this research material, it does not exist on the server of the public cloud. It exists on some other server which is private cloud. So from a user's perspective, I will say that it seems that everything is on the same website, but actually the infrastructure is like this, that the private cloud is or your sensitive or your research files are basically on some other server, or let's say the private cloud, right? And the website that you're hosting, which doesn't have that much of confidential data, is actually hosted on the public cloud, right? So this is a fine example of how a hybrid kind of architecture is created. One more example that I can think on top of my head is that let's say there's a company wherein it's been there since the past 15 years, right? So they have some legacy systems that they don't want to touch, which they have bought and on which the application is working. But what they have decided now is that any of the servers that we are going to launch from now on, any of the new applications that we are going to launch from now on, we are going to launch it on a cloud provider server, right? So in that case, what happens is these servers which were there in your data center, they have to be on the same network as the cloud provider's servers, right? That is a public cloud, and hence that kind of a mixture or that kind of a arrangement again becomes a hybrid cloud. So guys, these are all the cases wherein you can, or these are all the ways you can deploy your application on cloud. So first we discussed public cloud, which was basically when the servers they can be shared between multiple clients of the cloud provider, right? And basically those servers are owned by the cloud provider. Second is private cloud, wherein there are two cases. The first case could be that you own or you ask your cloud provider to give you a separate server stack where no other data will be available, only your data will be available. That is one kind of private cloud. Second kind of private cloud is when you buy your own servers and you set up a data center and that becomes your own private cloud. That is also a way of creating a private cloud or using a private cloud. Third kind of deployment is a hybrid deployment, wherein you use some servers from the public cloud and you use some servers from the private cloud, and hence it's called hybrid. All right. So guys, any doubt in whatever we have discussed so far? If yes, please comment in the chat box or put your question in the chat box and I'll be happy to answer it for you. Any doubts, guys? If there are no doubts, we'll move forward. But if any doubts, now is the time that you can mention it and I'll clear it for you. Alright, so Shubham is saying, can you explain private cloud once more? Sure, Shubham. So private cloud is nothing but using a server which is not shared by anyone else, right? So how does AWS work, or how does any cloud provider work for that matter? They buy a very big machine or very big server with a lot of RAM and with a lot of processing power, right? And what they do is they launch multiple instances of virtual machines on it, right? So it could be that, you imagine your laptop, you can probably, if it's a i3 or it's a i5 with around 8 GB of RAM, you can launch around 3 operating systems on the same server at the same time using a virtual machine, right? You can do that. Now, similarly, what cloud providers do is they buy a stack of servers And what they do is they launch multiple virtual machines on that server, right? And those virtual machines are owned by people who basically launch it through the AWS console or the Azure console or the GCP console, right? They launch it from there. Now, when your application or when your instance is up and ready, it is actually a part, or it's actually a virtual machine which is a part of a server. But it could be that that same server is hosting 7 or 8 more virtual machines which are owned by other people who have created their Azure or GCP accounts. Correct? So if that is the case, then there are some companies like let's take the example of government agencies, government secret agencies, which or intelligence agencies like CIA or CIA in US, like Homeland Department in US. All of them, they have very confidential data which have to be accessed by their internal employees, irrespective of the fact where they are sitting and in what part of the world they are sitting. Right now, in those kind of cases, what happens is, although they can buy their own servers, they can set up everything by themselves also, but then, like I said, they'll have to hire a team also that will manage the servers. So what cloud providers do is they give you an option of having your own server stack which is isolated from the rest of the infrastructure of your cloud provider. Right, that server stack is exclusively for you. It'll be a little higher, the price will be a little higher, but it'll again be a pay as you go model. That is, you can say that for how much ever time you'll be using it, for that much time only you'll have to pay the cloud provider. So that is what private cloud is, that you get a separate isolated server for yourself on which you will be working. You will be putting your applications on it, right? And those applications will nowhere be connected to nowhere will be sharing the infrastructure which the other clients of that cloud provider are using. So that is private cloud. Other way of saying what a private cloud is, that you buy your own servers and you set up in a data center, right? So although in that case you're not getting the benefits of cloud computing, but yes, that also is called a private cloud because you buy the same kind of infrastructure, you buy the same kind of infrastructure at scale, at the same scale that a cloud provider does. You buy it at the same scale, right? When I say scale, in the same quantity, you set up a data center according to it and it becomes your own private mini cloud, right? That is also what a private cloud is. So, all right, I guess Shubham, now you're clear with the doubt. All right, thanks, Shubham. So others, if there is any doubt in whatever I've explained so far, please let me know. I'll clear it out. And if not, I will move forward to our next topic. All right, so everybody is giving me a go, guys. So great. Let's move on to a next topic, which are service models. So we have discussed deployment models. That is what are the various ways in which I can deploy my application on a cloud provider. Now let's discuss the various kind of services that I can get from a cloud provider. Okay, so let's discuss that. So what are service models? Now guys, there are 3 kind of service models that we get in cloud computing. The first one is infrastructure as a service. Now what is infrastructure as a service? Basically, the cloud provider will give you an access to the server. That is, you will get an access to the operating system of the server and you can install anything you want in that server, and that will become, it can either become a database server, it can become a website server, it can become anything. So basically, when we say infrastructure as a service, you're getting the whole infrastructure, you're getting the whole system, you're getting the whole virtual machine as a service delivered to you. Right? So that is infrastructure as a service. Second is platform as a service. So in contrary to what we got in infrastructure as a service, wherein I got a machine that I could use, in platform as a service, I do not get the access to the operating system. Okay, what I do get an access to is kind of like a dashboard, wherein in that dashboard, I can upload any files that I want, and those files would automatically be put on the server by AWS, and I can see those files hosted on the server. If it's confusing, let me give you an example. Let's say if I want to set up a website and what I get is infrastructure as a service, So in that case, what I'll have to do is I'll get a fresh operating system. On that operating system, I'll have to install a web hosting software like Apache or Tomcat or anything. Once I have installed it, I will have to do an FTP, or I will have to transfer my files from a local computer on that AWS server using FTP. Once I've done that, I have to put those files in a specific folder on that particular server, and only then I will be able to access it when I go to the IP address of that particular server. This is the case of infrastructure as a service, where I've done everything that I had to do, right? In case of platform as a service, what happens is that I will not get the access to the operating system. All the softwares, all the settings that are required to be done is done by AWS. What I do get an access to is a dashboard where I have a button called upload. I click on that upload button, and what it will do is it will upload my website automatically. It will directly upload it to the location where it has to be. It will give it the required permission so that my website is hosted. So as a user, I don't have to get into the nitty-gritties of what kind of software has to be installed, what version of software has to be there. Everything is managed by AWS. I just upload my website and my website gets up and ready on a particular IP address. Okay, so this is platform as a service. It's basically an automated version of infrastructure as a service, where you get specific access on the server that you can just upload your files. There is nothing else that you can control on that server. That is platform as a service. The third kind of service that you get is software as a service. Right? What happens in software as a service is that, in contrary to what you got in infrastructure as a service, wherein I did not get access to the server, or where I got access to the operating system of the server. I could install anything, I could make that server anything, right? Second thing was platform as a service, where I got a dashboard where I can still upload my files, and those files will be hosted for me. Rest everything else will be managed by AWS or the cloud provider on which I'm taking this service from. Third kind of service is software as a service. Now, what is software as a service? You do not get access to a dashboard where you can upload your files. You do not get access to the server where you can do whatever you want on the operating system. What you do get is a software which has already been hosted on the cloud, and that software you can use. The straightaway example for this would be Netflix. So Netflix is a software, correct? It doesn't matter which server it is on. It doesn't matter whether you can upload your files or not, but you can use the software which is hosted on the cloud. That is software as a service. Software has been provided to you by the cloud provider to use as a service, and that service is a pay-as-you-go service wherein you'll have to do a monthly subscription. Okay. Another example for this could be the Google Docs that you use. You use Google Excel, or you use Google Word, right? All of those are softwares which are hosted on the cloud provider, and you can use those softwares. It doesn't matter which server it exists on. It doesn't matter what kind of softwares are installed on that server. I just have one software that I can use, and it has been hosted on the cloud. So that is software as a service. All right. So this is all about the different cloud models which exist, which are offered to the customers, right? Moving forward, now let's talk about cloud providers. Now, whatever we have discussed so far is in general, or is generic to cloud computing, right? Now, these kind of models, or these business models that we just discussed, have been adopted by various companies which are out there. Right? So companies like AWS is there. This is the most prominent one. Second is Microsoft Azure, and then you have Google Cloud, and there are 100 plus more companies which give you the same kind of services. Like another famous cloud provider which comes on the top of my mind is DigitalOcean, which is there, right? Which offers the same services, just that the jargons that it uses for giving you that service is different. The terminologies would be different, but at the back end, it's doing exactly the same thing, right? So DigitalOcean is there, Joint is there, Telemark is there, IBM Cloud is there. There are a lot of cloud providers. But why have I just showed you these three cloud providers? Because these are the three top cloud providers in the industry right now which give the cloud services. Okay, I'll say 90% of the whole cloud paradigm is actually covered by just these three cloud providers. That is, people, if there are 100 people who are using the cloud computing in the world, out of them 90 people would be using a service among these three only. Okay, now today in this session we are talking just about AWS, but why are we only talking about AWS? Why are we not talking about the others? Let me walk you through the points. So guys, the number one reason for AWS being so popular is that it covers 35% of the market share that is using the cloud computing platform these days. That means that if there are 100 people who use cloud computing, or if there are 100 companies which use cloud computing, out of them, 35 companies would be using AWS, right? So that's what the 35% market share means. Second reason is that AWS was way back incepted in 2006, and since 2006 I think it's been 13 years. So since 13 years AWS has been running the cloud computing business, and when AWS launched its cloud computing business, I guess it was the first and foremost cloud provider which went into the cloud computing domain and thought, okay, I can run a business on it. I guess back then there was no company which was providing the cloud computing services except AWS, and that is the reason, AWS has such a huge market share, which is 35%. If you compare it with Azure and Google Cloud, Azure is at 13%, and Google Cloud is at 6.5%, right? So Azure is a number 2 cloud provider in the world, and Google Cloud is at number 3. So you can just judge by the distance between this 13% and 35% that how huge AWS is, right? And Microsoft Azure has to do a lot of catching up to basically beat AWS right now. And the point that I'm trying to make here is that the reason for that gap is because AWS was launched way back in 2006, and Azure was, I guess, launched in 2012, followed by Google Cloud in 2013, right? So that is the reason most of the companies were already on AWS when Google Cloud and Microsoft Azure came into the picture, all right? So Microsoft Azure has 13%, Google Cloud has 6.5%, AWS was launched in 2006, and that is the reason AWS has a more mature model of infrastructure. Now, why is that? Because any company or any product that you launch, it always so when the first time when it's launched, it always has a lot of bugs to it, and it's as and when the companies or your clients start to use it, you get to know, okay, so this is also a problem, this is a problem, this is a problem that you have to solve, right? And when you solve it, your product becomes more mature. It becomes more reliable. And since it's been 13 years now that Amazon has been in the game, it has matured a lot. And when we compare it with Google Cloud or Microsoft Azure, they still have a long way to go. Already, although they have launched pretty good products, but they still are no match to what AWS has in terms of reliability. And that is the first and foremost reasons companies also have, they stick to AWS as their first choice, because most of the companies that they see, like we discussed, there is Netflix, there is Airbnb, there is Amazon e-commerce company, then you have Prime Video. All of them are on AWS and they're doing well, right? None of them has experienced any downtime being on the AWS platform. So any company who is trying to launch their product into the market, they also stick to AWS, reason being it's so reliable. Third reason that why we are learning AWS today, why you guys are learning AWS today, is because of the job opportunities. So because it has a greater market share, because there are more companies who are using AWS, obviously the job opportunities for AWS are also more, right? When you compare it with its counterparts, that is Google Cloud and Microsoft Azure. So like I said, if there are 100 companies, and out of those 100 companies, if 35 companies are using AWS, that means 35 companies you can apply on to become a solutions architect, to become an AWS developer, to become an AWS administrator, cloud engineer, anything, right? So it's always better if you want to get into the cloud domain to first get to know the major player, right? And then obviously you can also learn Microsoft Azure. Once you have understood AWS, it's very easy to actually understand the other cloud platforms like Microsoft Azure and Google Cloud, because they're almost the same. All of them are basically giving the same services, just that the jargons or the terminologies that they use are a little different. All right. Having said that, guys, let's move on. And now that we know that, why AWS is so successful, we understand that why are we learning AWS today? Let me introduce you to what AWS is. So guys, AWS is basically a subsidiary of Amazon.com, which is basically the largest e-commerce company in the world, right? So the way AWS came up in the market was that Amazon, the largest e-commerce company, was building the infrastructure for its website, right? And they designed an infrastructure which was highly scalable, highly available. It can auto scale itself. It can, downscale itself. So all of these things were part of their architecture of the Amazon website. Now, when they created an infrastructure like this, they thought, why are we only using it for our website? Why don't we make it available to the general public? And they can use it as long as they want in a pay-as-you-go model. And that's how the cloud computing model or the cloud computing business came into the picture, right? So the same infrastructure that it was using for its website, it made it introduced to the world to say, like, I'm hosting my website, or I'm hosting my Amazon e-commerce website on this infrastructure. If you also want your application to be as successful, as reliable, as available as my website, you can use the same infrastructure. And you know what? You just have to pay for the time that you used it, and the cost is as low as $0.0005. Isn't that amazing? So that's how AWS came into the picture, right? And now today it offers services in compute, it offers services in storage, networking, management, security, and many more that we're going to discuss as we move along. All right, so this is the AWS story, guys. We understand now that what is cloud computing. We understand now that the different kind of models that cloud follows. All of those things are followed by all the cloud providers. AWS is one of those cloud providers, and I told you the backstory of it, how it was launched, how it was incepted, and since it's the first player which came in the market, it's very matured in terms of its services. I think they have covered all their edge cases as to how our application can actually not be of use to a particular company or can fail, and they have covered all that. So you can be rest assured that if you are deploying an application onto AWS, it is in safe hands. All right, moving forward, guys, now let's talk about the thing that we are here to learn for. Let's talk about the AWS services. Let's see what kind of domains does AWS gives its service into. So AWS provides its services in compute, it gives in storage, database, security, management, customer engagement, app integration, etc. So we're going to discuss each one of them one by one as we move along. So first up, the compute domain or the AWS domain is compute. Alright, so I think I have a question from Shubham. So Shubham is asking me, among these domains, what is the difference between storage and database? Alright, Shubham, so storage is basically used when you have a workload wherein you want to upload binary files. Like, what are binary files? Files which like video files or MP3 files or photo files. All these files are called binary files because they're not data. It's basically, it's content, and that content is basically binary in nature. All right, so all your videos, all your music, right, any kind of file which you execute, your games, all of those are binary files. When you compare it with database usually deals with data which is textual in nature and has a proper structure. It could be unstructured as well, but basically textual data that a human can read is included inside a database, right? But on the other hand, files that run on computer, for example, any program or any video file, any music file, or any other file in that case, these kind of things cannot or should be stored on a storage kind of platform. It should not be stored on a database. It can be, but it should not be, because it unnecessarily makes the database, the size of the database big, which actually causes a problem when you're querying through the data when you're using a database. Alright, so guys, this is the difference between storage and database. Shubham, is your doubt clear about the difference between storage and database? Alright, so I've got a yes from Shubham. Others, guys, if you have any doubts in these domains, you can ask me. Let me explain you all these domains one by one. So compute domain basically deals with servers. So if you need servers, or if there is a workload which needs processing, the compute domain will have services that you can launch and implement that workload. More on this we'll discuss as we move along. All right. Then we have the storage domain, which, like I said, deals with storing binary files on the remote servers. So for that, we have a dedicated services, and we're going to discuss those dedicated services in storage. Then we have a service called database, a domain called database. In the database domain, you have a lot of services. So if you have structured data, you have one kind of database for that, or you have one kind of database service for that. If you have unstructured data, you have another database service for that. but we'll discuss more on that as we move along. Then there is a domain called security. So all security related to the application that you have uploaded, to the servers that you're using, to the account that you're using, for all those kind of things would be included in security. So there are specific services for each kind of workload that I just mentioned. We're going to discuss that when we reach the security domain. Then we have the management domain, which would include monitoring, which would include deploying the whole architecture at once, right? All those kind of services comes in management. Don't worry if you don't understand it. I'll explain you more as we move along in that domain. Then we have customer engagement. So sending emails, sending notifications, all those kind of services comes under customer engagement. And in the end, we have app integration. So services like queues, like for example, if you have an application on which you have to give a lot of jobs, it's better to have a queue where you'll store all your jobs, and that queue is separate from the server which will be executing your jobs, right? So these kind of integrations are called app integrations, and we'll be discussing the services in that domain as we move along. All right. So guys, these were the domains, the main domains that are there in AWS. There are a lot of other domains as well, but we'll be focusing more on these domains since, this is what is actually going to be asked for in your solutions architect exam. And at the same time, these are what you will generally be using when you become an AWS engineer. All right. So moving forward, guys, now let's start with the compute domain and let's see what all services are there in the compute domain. Alright guys, so let's discuss the AWS services in the compute domain. So here are the set of services which are included in the compute domain of AWS. So this particular service is EC2, Elastic Beanstalk, Lambda, Auto Scaling, AWS Load Balancer, AWS ECR, and AWS ECS. Now for the sake of explaining you guys, I've taken the liberty of shifting some services from some other domains which I think should fit in this domain, right? But you don't have to worry, the explanation would be the same. It's just that you would find it somewhere else in the AWS Management Console. Like for example, auto scaling would not be under the compute domain. It would be under some other domain. I'll show you when we move on to the AWS Management Console as to where you can find each and every service. Intellipaat, basically the company that we work for, is an e-learning company, and we basically researched a lot of job descriptions, and what we came up with was this Cloud and DevOps Architect Masters course. Now in this, we have put down all the skills from all the job descriptions that we have got, for cloud related jobs. And also we are in touch with, since we are with a training company, all our instructors are basically working professionals. So we have got in touch with top cloud and DevOps professionals and asked them what are the relevant skills that you think are expected from a cloud engineer, person who is basically appearing for an interview. So based on what the feedback that we got from our instructors, based on the feedback we did from our research, we have come up with this course, and these are the things, these are the skills that we teach to a person when we take him basically on board with us in the Cloud and DevOps Architect Masters course. For now, guys, let's start with the first service, which is AWS EC2, and let's see what is it all about. So guys, Elastic Compute Cloud is nothing but a server. It's a raw server. It's just like a fresh computer that AWS gives to you. So what you basically do is you ask AWS for server, right? And that service is called EC2. So what you do is you specify the kind of processor that you want, you specify the kind of RAM that you want, and then you click on launch. And what happens after that is you get a server which is basically of that exact configuration. Now what you will have to connect to it remotely. So if it's a Linux machine, you will connect through SSH. If it's a Windows machine, you will connect through RDP, right? And once you connect to it, it'll give you the UI of how an operating system actually is. If you installed it on your local, it'll be exactly the same. It's just that now it has been basically launched on the infrastructure of AWS, and that can be accessed using various tools like the RDP tools or SSH tools. I'm going to discuss more about EC2. I'm going to basically launch an EC2 instance in a moment. But before that, let's discuss all the services which are there in compute, and then we'll do that EC2 demo as well, right? So guys, Elastic Cloud Compute, like I said, it's just like a raw server that is given to you. And on this raw server, you can install anything, you can make it anything, you can basically build it, make it a web server, you can make it a database server, it can be anything, right? That is what EC2 is all about. Now in the diagram, as you can see, you can launch either a single EC2 instance or you can launch multiple EC2 instances. You also have an option of launching, of creating a EC2 instance and then installing some softwares on it, and then you can launch multiple copies of that particular EC2 instance, so that you don't have to launch, or you don't have to specify, or you don't have to install all the softwares all over again. You can create multiple copies of the EC2 instance again, right? And at some point of time, if you feel you want to increase the configuration of your system, you can also do that, right? Let's say if my RAM was 8 GB over here and then I want to make it 16 GB, even that is possible in EC2. And that is why the name is Elastic Compute Cloud. Elastic means that you can increase the size of the instance or decrease the size of the instance configuration as and when required, right? So guys, this was about Elastic Compute Cloud, that is EC2, right? Our next service is Elastic Beanstalk. Now Elastic Beanstalk, guys, is an advanced version of EC2. How is it an advanced version of EC2? In EC2, what you could do was you could just launch a server, right? And then you can install softwares on it. You can make it a database server. You can make it a web server. You can make it anything, right? With Elastic Beanstalk, you get certain restrictions on EC2 and there is a certain amount of automation involved. So what is Elastic Beanstalk exactly? Elastic Beanstalk basically is a web application server, right? You cannot install any other software on it. It is a web application server on which you can upload your website, and you don't have to install any software. You don't have to do anything. Like I said, we talked about what is infrastructure as a service and what is platform as a service, right? So infrastructure as a service is EC2, okay, where you get the whole server, you get the access to the operating system, etc. Elastic Beanstalk is platform as a service. So in this, what you get is a dashboard. You don't get access to the operating system. You don't get access to the softwares that you have to install on that server, right? Everything is pre-configured. All you do is you say that I need a PHP server. It'll launch a PHP server and it'll give you a dashboard where you'll have a upload kind of a button. You click on that upload button and you'll have to put or upload your website over there. So once you have uploaded your website files, they automatically go into the path where they have to go. And all you have to now do is just go to that IP address or the domain name of that particular Elastic Beanstalk instance, and you will be able to access your website. If you compare it with if the same thing you had to do on EC2, you'll have to first install the softwares, then you'll have to upload the file using FTP because there's no dashboard to upload it. So you'll have to download an FTP client, connect to the instance, upload your files like that in that particular folder. And then if you go on to the IP address of the EC2, only then you'll be able to access the website. With Elastic Beanstalk, what they did was, like, if you have a use case where you have to deploy a web application, you don't have to do all that manual stuff of installing the software, of installing or putting your files on the server. All you have to do is you have to open Elastic Beanstalk, select the environment that you want to deploy, and upload your website over there. That's it, right? So it's an automated version of EC2 in which you have certain functionalities of putting a website over there, but there is a limitation that only it can be a web application server, right? It cannot be a backend server for you. Elastic Beanstalk is only used to deploy your websites. Guys, remember that. Because the next service of ours is a little different from Elastic Beanstalk, right? And it also has some limitations. Our next service is AWS Lambda. Now, AWS Lambda, again, guys, is an automated version of EC2. It's an advanced version of EC2, but with some restrictions. Now, what are those restrictions? It cannot deploy an application. You cannot upload your website on it, and it cannot host an application for you. What is AWS Lambda? AWS Lambda is basically just used for doing your backend processing. Now, what is backend processing, you might wonder. So let me give you an example. Let's say you have an image processing application. So what do? You have a UI or you have a website through which you can upload an image, and what that website does is it stores the image on its storage and then it reduces the size of the image, right? And then you can download it again. Now, you might be wondering, this is one website, so ideally everything should be happening on one server in this case. But that is not the case over here, guys. So what happens is your web application is on a separate server. The processing happens on a different server, right? And AWS Lambda specializes in processing. Now, why is AWS Lambda preferred for processing is because when you launch a server, guys, you have to select the configuration that you want, right? You have to select the processor, you have to select the RAM. With AWS Lambda, you don't have to specify any configuration. You don't have to choose what server size should be for my application to cater to the workloads that are coming in. AWS Lambda, what it does is it sees what kind of workload it is being given. It automatically scales up if it has to in terms of its configuration, and then executes all your workload and gives the result to the server, which is the web application server, where it has to give the result on the website. So basically only processing happens on AWS Lambda. Only website deployment happens on Elastic Beanstalk, right? And AWS gave us these two wonderful services so that we can create a distributed kind of an architecture wherein, there is no fault. If there's a fault in one server, it's not like my whole application will go down. I have certain redundancies in place. I have distributed my work among multiple computer nodes so that even if one gets faulty, it's not like my application will go down. We'll discuss more on this as we move along and we talk about auto scaling. But guys, remember this, AWS Lambda is only used to run your background code. AWS Elastic Beanstalk is only used to deploy a web application. EC2 can be used for anything. It's your own private computer. You can install any software, make it a backend server, make it a web application server, make it a database server for that matter. Do anything with it, right? That is what AWS EC2 is. Now, if you see the diagram over here, as you can see that, let's say there's an e-commerce application, right? And that e-commerce application, there's a trigger for basically buying something. Let's say you order a package, right? So when you order a package, what happens on Amazon? That entry is made into the database. So that entry is stored, let's say, in DynamoDB, which is a kind of database in AWS, right? Now what happens? Now, once the data is stored in DynamoDB, you want to do some processing on that data and then go ahead and store it somewhere else, right? So once the data has been stored in DynamoDB, I need the processing to be done. Now, the one way to do it is you do everything on the same server, where basically, let's say my package order confirmation happened on the web application, right? The web application server triggered this particular action that I have, my package order is confirmed. And that's when it issued a command to store the data in DynamoDB. That is all done by my web application server. Now I can also, this server itself can also do the processing for DynamoDB and then store it on Redshift warehouse. But the processing takes a lot of time. And that is the reason I differentiate my processing on a different server, or I make my processing happen on a different server so that there is no overhead on my website, so that my website is not becoming slow irrespective of the fact that what kind of workload is running in my backend. Because that workload is being managed by AWS Lambda, right? So my website can be up and running. It will always be available to all the users irrespective of the fact how huge of processing I have to do, right? So that happens by AWS Lambda. One more thing, guys, one more cool thing about AWS Lambda is that whatever job you give to AWS Lambda, it's not one server which does the job. AWS Lambda takes a job, executes it in one server. If it gets one more job in the meanwhile, what it does is it launches a second server on which that job will be executed. Similarly, if there's a third job which is coming, it will be executed on a third AWS Lambda server. So that's how it works, right? And once the processing is done, it can also give the communication back to the web application, and that's how you get the message that the operation is done. But what you don't understand is how many computers or how many servers are working in the backend, right? So now you know. So AWS Lambda, wrapping up, guys. So AWS Lambda is used for executing a backend code. AWS Elastic Beanstalk is used to deploy a web application. And AWS EC2 is a raw server which you can use to make that server anything, right? It could be a web application, it could be a backend server, it could be a database server, etc. Our next service, guys, is load balancing. Now, what is load balancing basically, and why do we need this kind of a service? Now, guys, I told you that whenever we create a production grade application, we basically deal with distributed computing, right? So when we talk about distributed computing, we also have to talk about redundancies so that my application is highly available. Now, what does that mean? Imagine these three servers are your web application servers. Now, if you just had one, imagine you just had one. In that case, what will happen? If there is any kind of fault in this particular server, my application will go down, right? So what I do, I launch 3 exact copies of that server, right? And what happens in that case is, if this server goes down, my user can view my website on this server. If both these servers goes down, my website can be viewed on this particular server, right? But now you might be wondering, how will the user know which server to go on, right? And that is exactly what Elastic Load Balancer is all about. So Elastic Load Balancer, what it gives you is, it will give you one domain to go on, or it will give you one IP address to hit on. You hit that IP address and Elastic Load Balancer will automatically analyze where to send the requests. So the Elastic Load Balancer constantly keeps a check on all the instances which are running in your cloud environment, and it sees which of them are healthy and which of them are unhealthy. If there is a server which becomes unhealthy, what your load balancer will do is, it will stop routing traffic to that particular server, right? And it'll start routing server to your traffic to other servers. And this is the main job of Elastic Load Balancer, which is to distribute traffic among all the healthy instances which are out there, right? Also, one more important thing over here is, guys, if all the 3 servers are functioning in the healthy state, in what will it do in that case? So it will distribute the data equally among all the servers. Now you might be wondering, how will that help? So let's say I just have one server over here with around 16 GB of RAM and let's say an i5 or an i7 processor, right? So it will be able to serve a limited amount of users. Let's say there are 10 people, right? So who are there on the website. Let's say the server will be able to serve 10 people. Now what happens if there are 20 people tomorrow? In that case, you always have to plan ahead and you have to keep more servers in your group, so that, or in your architecture, so that if there is more traffic, my requests can go on the other servers, so that the load is actually decreased on the first server, right? So what load balancer does is, it will never make one server max out on its performance. It will always distribute the traffic equally among all the servers, so that the processing or the overhead on any server does not go up and my application should not become slow, right? Now you might be wondering that how do I constantly keep a check on how much traffic is coming on my website and accordingly deploy servers? So that answer I will give you in my next service, which is AWS Auto Scaling. So what is AWS Auto Scaling? It automatically scales up the number of servers based on how much traffic is coming onto those servers. Now, how does it do that? You can set a certain threshold. Let's say there are 4 instances which are running on my architecture. So what I can teach auto scaling is that whenever the collective CPU usage goes beyond 80%, launch one more instance in the group. And the load balancer should now route the traffic to the new instance as well, right? So this is what auto scaling is. Similarly, when the CPU usage collectively goes below 40%, let's say, decrease the size of my fleet, decrease the size of my server fleet. So in that case, what I'll do is, at the moment the collective CPU usage goes below 40%, it will decrease the number of instances in your auto scaling group, right? And that's how it works, guys. And the auto scaling service cannot exist alone. It always has to work in conjunction with AWS Load Balancer. Why? Because if the size of the fleet is increasing, if the size of the fleet is decreasing, there should be an entity on top of it which will distribute the traffic equally among all the instances, right? So if you are making use of auto scaling, you will always make use of AWS Load Balancer. On the other hand, you can just make use of AWS Load Balancer, and you might not want to use auto scaling. That is fine. But if you're using auto scaling, you absolutely have to use a load balancer for your traffic routing. All right. So this is what auto scaling is, guys. Our next service is Elastic Container Registry. Now, what is Elastic Container Registry? For this, guys, you have to know what Docker is, right? So if I have to give you a brief about what Docker is basically a tool using which you can launch operating systems in the minimum size possible. So the minimum container size that I know of is 40 MB. So what you can do is, let's say we were talking about distributed computing, right? So in distributed computing, what happens is each of your server plays a different part in your application, right? So similarly, what we can do is we can launch containers. Now what containers do is they act as a virtual server, right? But they take the minimum resources possible. They take minimum space possible. Like I said, 40 MB is the size of a container which holds an operating system, right? So in those containers, you can deploy applications, okay? And these applications then run as if they were running on a separate server. They are isolated from the operating system on which the container is running. I'm sorry, guys, if I cannot go in depth of what Docker is right now because it's altogether a separate topic, but you can understand it like this, that it's basically a mini virtual computer that you can run in your system. And ECR service, basically what it does is it stores these containers in a repository. Like you have GitHub for storing code, you have ECR for storing your container images, right? For example, like I said, operating system 40 MB size, the image has to be stored somewhere, so it will be stored in ECR. Now, if you want to run those images, you have a service called ECS. So what ECS does is it runs any Docker image on the AWS infrastructure, right? And it orchestrates it in a way so that if there is anything wrong with that container service can again be launched. Now, don't get confused, guys, with what we do in EC2. Now, you might have a question that I can launch multiple EC2 instances. In spite of that, why don't I launch just multiple containers? Because in that case, what will happen is you're still the machine on which the containers are running. That becomes node point of failure. That means if there is anything wrong with that machine, any number of containers which are running on your particular system will go down, right? So this is also a redundancy that you can make in your architecture, that you can also run applications on containers which are running on an auto scaling infrastructure. That is a machine on which Docker is running. But if the processing or if the CPU gets an overhead, and the CPU processing increases, you can scale your machines and you can scale your containers as well, right? So if it's a little complex for you guys, you can just ignore this service, which is ECR and ECS. It's only for those guys who understand what Docker is. So guys, ECR is nothing but it's a repository on which you can store container images, and ECS is nothing but a service to run your Docker containers. If you don't know, guys, what Docker is, I'll just give you guys a link after this class. It's basically a video for introduction to Docker. It's a half an hour, 45 minutes video. You go through that, and then again you can go through this recording wherein you can find a description for what ECR and ECS is, and that'll make more sense to you in that case. All right. So guys, we have discussed ECR, we have discussed ECS. Alright guys, so moving forward now, let's go ahead and do some hands-on. I think it's enough of theory for compute. Let's go ahead and launch some compute instances in AWS. Alright, so what I'm going to do is, let me first show you how you can create your account on AWS first. So let me just jump on to my browser. Alright guys, so the first thing that you would be doing is heading on to aws.amazon.com. Okay, so once you are on this website, you will see a big orange button over here which says create an AWS account, right? Just click on that and that will take you to the next screen wherein you will have to fill out your details. So fill out all your details over here, right? And once you have done that, let us enter some sudo values. So let's say it's abc@intellipaat.com. Password, I can set anything over here. Similarly, I'll set anything over here. AWS account name, let's say it's Intellipaat-test, right? We'll click on continue. Then it'll ask you what is the account type? Is it a professional account or it is a personal account? So we'll select personal account because we are just trying out AWS, right? So we want to use it for ourselves. Give some number. Let's say I give boot 1 2 3 4 5 6 7 8 9. And the country or region, you can select any region that you are in. Your address, the city that you are in, postal code. So let's say the city is Bangalore. State, let's say it's Karnataka. And once everything seems fine to you, just click create account and continue. Once you do this, you will reach this screen where you'll have to enter your debit card number or credit card number, right? Enter everything over here and click on secure submit. Once you've done that, the next page will ask you what kind of account do you want to create. Is it a business account or a standalone account? What purpose will you use this account for? It's all logical. You just know what you have to answer. Just remember this, you are creating a personal account and it's nowhere related to a business. Select everything, click on finish, and you will have a new AWS account created for you. Now, one awesome thing about AWS, guys, is that it will give you free tier. That is, you can launch instances free for 1 year, right? And every account that you create on AWS, or when you sign up on AWS, you'll get a 1 year free tier account where you can launch a certain EC2 instance for free, and that too for 750 hours a month. So 750 hours is actually 30 days, and that too for 1 year, right? So 1 year of free instances you can launch. So I'll show you guys how you can launch instances as well, but this is how you can sign up for AWS. So once you have signed up for AWS, guys, next thing would be to basically log in, right? And for that, you'll have to, once you go to aws.amazon.com, just click on AWS Management Console and it'll take you to the sign-in page. Okay. So on the sign-in page, just enter the email address through which you want to connect. 1 second, guys. So this would be the email address that I want to enter, followed by the password, and this will make you sign in into AWS. So this is a step that you should reach once you have completed your sign up. Okay. And now what I want to do is I want to launch my first server on AWS. Now, how will I do that? So we have studied about the EC2 instance, right? So for launching the EC2 instance, here is the domain. So the domain that we went through was compute. Right? So in compute, you have these many services. You have EC2, ECR, ECS, then you have Lambda, Elastic Beanstalk. There are other services as well. We have not touched those services because they would go beyond the scope of what we intend to do in this session. This session is an overview for AWS, for an AWS solutions architect, right? So the services that we have picked up, they're all the basic services that you should know about. And once you understand all those services, understanding the rest of AWS would be a cakewalk for you, right? So there are so many services in AWS. You have Ground Station, Security Hub, Artifact. If you're into game development, then you have Amazon Game Lift. But all these services are basically confined to a certain kind of work that you want to do. Like, I am not going to develop a game, right? Or I'm not into gaming, or I'm not into game development. So this service is not for me. Similarly, there are IoT services that you have to know of, but IoT, not every company would use IoT, correct? Some companies would use IoT, and for you to learn the IoT service, it would be a waste of time for you, right? And that is why what we have done is we have picked up some services which are essential and which most of the organizations will use who are into IT and want their application up and ready. And we have just selected those applications, right? Or those services. Also, your AWS Solutions Architect exam would be confined to only these services that we are learning. All right. Now, what we wanted to do was we wanted to launch our first server. And for that, there is a service called EC2. So either you can find it under the domain compute, that is EC2 over here, or you also have an awesome option over here to search for any kind of service. Let's say I want to launch or I want to go to EC2. So I can just write EC2 in the search bar and I will get the respective result over here. Let's click on that. And now this link would basically open your EC2 dashboard. Right? So from here, you can launch your first EC2 instance. There are a lot of options on the left, guys. Do not worry about each of these options. These are options that we will be studying about when we purposefully just talk about EC2 service. And that will be in the further sessions that we're going to have. For now, just understand how to launch an EC2 instance. And for that, you just have to click on this blue button, which is here, which says launch instance. Just click on that. Once you've clicked on launch instance, you will get an option to select the operating system that you want to run in your server, right? So there are a lot of operating systems to choose from. You have the Amazon Linux AMI, which is a custom Linux that AWS has created. Then you have Red Hat OS that you can run. You have SUSE Linux, you have Ubuntu. There are a host of operating systems that you can run from. You have Windows as well, right? So you choose whichever you want, and always ensure you choose an operating system which says free tier eligible, which would mean that it will fall under the free tier and it will not be charged for you. Okay. So let's say I select the Ubuntu server. I'll click on select, and now it will ask me what is the size of the server that you want. How much of CPUs do you want? How much of memory do you want? So the only server, so there are a lot of options over here to choose from. Right, but the only server that is free for you would be T2.micro, okay, which has 1 CPU and 1 GB of RAM, which is enough for demo purposes when you want to try out AWS. Okay, so you would select T2.micro if you want to be under the free tier and not be charged. So just select T2.micro. Next, you will click on next, and then it will ask you for all the details that are over here. Do not worry about anything, just leave them blank. Click on next. Next step would ask you for the hard drive storage. How much of hard drive storage do you want? So by default it's 8 GB when you're launching a Linux instance, so we leave it at default. If you want, you can change this, right? Then click on next. You can add tags over here. What are tags? Tags are nothing but metadata to your instance, right? Like for example, I can say the name. I can add a tag that the name of the instance is something, then the department to which this instance belongs to is this. So all those values I can write over here, and those will serve as a metadata for the instance, so that when somebody is searching for all the EC2 instances for, let's say, the IT department, they just have to type in department equal to IT and it will list all the instances. So for those kind of searches, you have tags. Click on next, then it will give you the option of configuring your security group. What is a security group? It's nothing but a firewall. It's a very simple firewall, guys. In this, what you have to tell is, so basically all these rules that you can add over here, these are all inbound rules, right? So inbound means what kind of connections are allowed on this server. So there's a SSH connection which is allowed, right? So you can select the protocol that you want to allow on this server, right? So right now, what has been allowed is the SSH protocol, so that we can log into this server. SSH means that, right? If you select SSH, it will fill out all the details for protocol and port range by itself. Now, whom do you want the SSH protocol to be used by, right? If you want it to be accessed by anyone, you can just give anywhere. Why is this option helpful? This option is helpful when the IP address of your computer is not fixed. Let's say you can access this instance from office, but you also wanted to access it from home as well, right? So if you want to access it from home, then you have to select anywhere. If your IP address is not changing, you can select my IP, right? Let's say this is my IP address right now, and only I will be allowed to connect to this instance using the SSH protocol. But it's the generic use case that everyone deals with is that they want to log in from anywhere, right? So I'll select anywhere. It fills the data by itself. And now finally, I can just click on review and launch. So if you want to delete a rule, guys, since in this rule I did not define anything, I can just delete this from here. And now let me click on review and launch. Okay, so now I can review all the settings that I've done. Once I feel everything is correct, I'll just click on launch. And this is a very important step, guys. Now, to log into any server which is there on the remote system, imagine like if somebody gets your IP address, anybody can access that server and they can make any change that they want, right? But it's obviously not like there's a security layer that we add, or which AWS has added to the servers that it launches. It gives you a key pair, right? What is a key pair? A key pair is nothing but it will give you a key that you will have to use while you're connecting to the instance. Okay, so as you can see, there's no key pair right now. So what I can do is I can create a new key pair. Let's name this key pair as, let's say, test-Intellipaat. Let's say this is the name, correct? I will click on download key pair. So unless I don't create a new key pair, this launch instance button will not be active. So this will download a PEM file for you. This is a file which is of the PEM extension, right? So this will be used to connect to our instance. And finally, when everything is set, let's click on launch instance. So now you can see your instances are now being launched. This is a message that you're getting. So I can just go to the instance and see that, okay, so there's an instance being in launch. The instance state is pending, which means it's still in the launch process. I can give this instance a name. Let's call it test. Okay, and now it's in the running state. Great. So now once you have selected test, you can refer to all the details of test in the below panel. So here is the IP address which will be used to connect to it, right? The instance type, which is t2.micro, the state which is running, right? Then you have the security group. So view inbound rules, you can see there's a SSH rule that you have added over here, right? And then the next step would be that what is the key pair name for this instance? It's test Intellipaat, so on and so forth, right? Now that you have launched the instance, the next step is to connect to it. Now, when you want to connect to this instance, there's a software called Putty that you can download, right? So here's the software that I've already downloaded. If you want to download this, just search on Google for download Putty. You will get this link. Go to this link, right? Now guys, there are two things that you have to download. One is you have to download Putty, which you can use by clicking on this link. It'll take you on this page. Just select, if you're on Windows, just select Putty 64-bit. Just click on it and it'll basically download the Putty software for you. The other thing that you'll have to download is Putty Gen, right? This is also required. I'll tell you why it is required. So this is basically Putty Gen, and the other software that you need is Putty. Okay. So once you have both the softwares in place and you have installed both the softwares, next step would be to connect to our instance. So this software of mine is Putty Gen. Let me launch it for you. This is Putty Gen, guys. The PEM file that you get, guys, if you have to use it with Putty, the way you can use it is by converting this PEM file first to PPK, because that is what your Putty software would accept, right? So first I'll have to load this file on my Putty Gen. So let us do that. So I'll click on load and then I'll select the PEM file, which is this. It says successfully imported. Great. Now I want to save the private key. If I save the private key over here, it will ask you, are you sure you want to save this key without a passphrase? Yes, right? And let's name this private key something. Let's name it, let's say, test. So as you can see, the format now is being changed to PPK. Great. Let's save the file. The file has been saved. Next step is launch your Putty software. Right, this is my Putty software. The instance that I want to connect is this. This is the IP address that I want to connect to. I'll mention it over here. Then I'll go to SSH. Because I've mentioned the IP address in the session part, now I also have to put the key using which I will connect, right? So for putting the key, you have to go into SSH. Then you'll be clicking on auth. In auth, I have to select the PPK file which I created. So this is the file, test. Let's select that and let's click on open. So now it'll give you a message that this server host key is not cached in the repository. Just click on yes on this message. And now you will see the screen which says login as, right? So now since I was launching an Ubuntu instance, what I have to enter over here is Ubuntu. I'll hit enter and now it'll verify the key that I inserted and it'll be able to connect to the Putty, to the server that I created on AWS using the key that I put, right? And now I'm logged in on my server. Now I can do anything over here. I can install any software that I want. So this is how you can connect to an EC2 instance which has launched a Linux AMI or Linux OS. Okay, for connecting to Windows, guys, you do not get a PEM file. You do not get a PEM file. What you basically get is an RDP file along with the password. Okay. So you will be given the password, you will be given the username, you will be given a RDP file. So you select the RDP file and then it will ask you for the password. Just enter the password that was given to you by the AWS Management Console. You click on connect and then you will be able to launch a Windows instance. So there are only two types of OS that you can launch on AWS. One is Linux, second is Windows. So I told you how to connect to Linux instances. Let me also walk you through how to connect to a Windows machine. Alright guys, so now in order to launch a Windows instance, again we'll just click on launch instance. Let's select a Windows OS which is free tier eligible. Let's select this, right? T2.micro is the instance that we want to launch. Let's click on next. Let's leave everything at default. Let's click on next. Here you can see the default size is 30 GB because in Windows it takes a lot of space. So it's 30 GB over here. Let's click on next. Configure the security group. Here you can see that instead of SSH you have RDP, right? Because for Linux instance, because it's a command line, what you do is you collect through SSH. But because Windows is a GUI based OS, you have to connect through RDP. All right. So we'll click on review and launch. And now we'll select the same key pair which was there. And let's click on launch instances. So our instance is now launched, guys. We can just go here and we can see it's in the pending state. All right. So let's name this instance as Windows. All right. And now in order to connect to it, this is the IP address that you get. Now just click on actions. So select the machine that you have to connect with. Once it's launched, you'd be able to click on actions and you'd be able to click on connect. So in the connect, so when you click on connect, you will get all the options of how to basically connect to this particular server. So let's wait for this instance to be in the running state and then let's review. Okay, so the instance is now in the running state, guys. Now let's click on actions. Let's click on connect, and this is basically the way to connect to it. You can download the RDP file by clicking over here. So as you can see, I got the RDP file. The username is administrator, and if I click on get password, it says password not available yet. Please wait at least 4 minutes after launching an instance. Okay, so the password will be available once the instance is 4 minutes since launch, but this is the way you get the password. Okay, now if I click on the RDP file, it will directly give me this kind of a window where it will say, are you sure you want to connect to it? Let's click on connect. And now it is asking for the password. So all you have to do now is wait for the password to be available over here, right? And once the instance is ready, you'll get the password here. Once you have the password, just put the password over here, click on OK, and you should be able to connect to your Windows instance. So let's give it the time. Let's wait for this instance to get in the running or in the password state, and then we'll just enter the password here and click on OK, and let's see how it goes. Alright guys, so let's try now. So I'll just click on actions. I click on get Windows password. I get this page. Now what I have to do is I have to choose the key pair path. So in this PEM file will work. So I'll just enter the test intellipaat.pem. Remember, the PEM file will work and not the PPK. Let's click on open. And now let's click on decrypt password. So guys, this is the password for connecting to my instance. Let's copy it, go to our instance, let's paste it over here, and now let's click on OK. Now it says the identity of the remote computer cannot be verified. It's okay, just click on yes. And now you should be able to connect to your server. So here you go guys, here is a server launched on AWS for you. It's a fresh server. You can do anything that you want on this, right? You can install any kind of tool on this. You can make it a database server, make it a web server. You can make this server anything, okay? So guys, this is how you can connect to a Windows instance. I've showed you how you can connect to a Linux instance as well, right? This also, you can install any software on this server and it can become anything for you, right? Now, let's go ahead and come back to our slides. Alright guys, so I've showed you how you can connect to an EC2 instance. We got to know how to connect to a Linux instance. We got to know how to connect to a Windows instance, right? And let's talk about the other services as well. So let me come back to my dashboard. So like I told you guys, EC2 is an infrastructure as a service where you get access to the operating system, right? Now there is a service called Elastic Beanstalk and there's a service called Lambda. Let's look at Elastic Beanstalk. How is the dashboard look for Elastic Beanstalk, right? So as you can see, it says welcome to AWS Elastic Beanstalk, and it says just select a platform, upload an application and run it. That's it. You don't have to connect through SSH to that instance in order to install the software and get your application ready, right? So as you can see, when I said get started, it gives me create a web app, right? So you can only create a web application here. It will not act as your backend server, right? It can only host application. So let's give it an application name. Let's say it's test, okay? And then let's choose a platform. What do I want that software or that web app to run? So I can put my web app in .NET, I can put my web app in Go, I can put my web app in PHP. It's all my choice. So let's click on PHP, right? And the application code, let's have the sample application first. And now let's click on create application. So these are all the settings that you have to do, guys, nothing much, right? And now it will start to create your Elastic Beanstalk. It will not give you an access to the operating system. Remember this, guys, you will not get an access to the operating system. All you will get is a dashboard on which you can upload your website and it will be hosted for you. When I created the EC2 server, I could not do anything on it. I had to install the software, then I had to put my application on it, and only then I'll be able to access it. But in this case, everything is done automatically. I can just upload my code and that's it. All right. So let's wait for this to be ready and then we'll go forward. Alright guys, so as you can see, my Elastic Beanstalk is now ready. And now if I go to this particular URL, which Elastic Beanstalk has given me, you'll be able to see the web app, right? This is a sample application which has been deployed. I can click on upload and deploy, and just I have to choose a file, click on deploy, and that website will get deployed automatically over here. I will just go to this link, refresh it, and my website will be visible over there. So I guess now you know when I said that you just get an access to a dashboard, you're actually not getting an access to the whole operating system, right? You do not have a control on that. All right, let us look at Lambda as well. So let's see what happens if I click on Lambda. All right, so when I click on Lambda, guys, this is the dashboard that you get. And as you can see, it just says run. So if I run it, it says hello world, right? You just have to enter the code here. It will give you the output. That's all what Lambda is. It will not host your application. It can just give you textual outputs in the form of JSON or in the form of textual content. It can just give you that. Okay. Now, if I change something over here, let's make it hello world 123. If I run it, it says hello run world 123. So if you want to create a function, just click on create a function over here. Author from scratch, use a blueprint, browse serverless app repository. You can just see if there's any code that you want to take from what has been done before. You can do it from here, that browse serverless app repository, use a blueprint. Here you have a lot of blueprints which most of the companies use, right? So you don't have to write the whole code from scratch. You can just click the blueprint that you want. For example, it's a microservice HTTP endpoint. That is, you just have to hit on the API and it'll give you the result. If that is the kind of Lambda function you want, you can also do that, right? Then you have Kinesis, Firewalls, log to JSON. There are a lot of things over here. Don't get confused with all the jargons used over here, right? This you will be able to get once you have a hang of all the services in AWS, which we will teach you in the upcoming sessions, right? For now, you just understand what Lambda does, right? Lambda, you give the code, it will run the code. That is it. It will not host an application. Elastic Beanstalk, it will host the application for you. And EC2, you can do anything. You can also configure your EC2 server to basically become AWS Lambda, but you'll have to manually install all the softwares and then you'll be able to do that job. So I guess, hope guys that you are now clear with the basic services of the compute domain of AWS, that is EC2, Elastic Beanstalk, Lambda. Auto scaling and load balancing, we will do it as we move along in the sessions because that requires you to know a little bit more, right? So let's move on and come back to our PPTs and let's start with our next domain now. Intellipaat, basically the company that we work for, is an e-learning company, and we basically researched a lot of job descriptions, and what we came up with was this Cloud and DevOps Architect Masters course. Now in this, we have put down all the skills from all the job descriptions that we have got, for cloud related jobs. And also we are in touch with, since we are with a training company, all our instructors are basically working professionals. So we have got in touch with top cloud and DevOps professionals and asked them what are the relevant skills that you think are expected from a cloud engineer, person who is basically appearing for an interview. So based on what the feedback that we got from our instructors, based on the feedback we did from our research, we have come up with this course, and these are the things, these are the skills that we teach to a person when we take him basically on board with us in the Cloud and DevOps Architect Masters course. Alright guys, so our next domain is the storage domain in AWS, and let's see what all services do we have in the storage domain. So guys, these are the important services that we have in the storage domain of AWS. Our first service is Amazon S3, then we have Amazon Glacier, Amazon EFS, and AWS Storage Gateway. So let's look at these services one by one and understand what they do. So guys, S3 is an object storage service, which basically means that all the files which are uploaded on the S3, they are basically regarded as objects. Objects for us as layman users, they don't differ much. I mean, you won't see the difference in terms of when you're using the file or downloading the file that, it was a file before and now it's an object. Object basically is at the back end. That is how you store a file, is in the form of an object, right? So it's basically on the infrastructure side that it makes a difference, that each file in an S3 bucket acts as an object, right? Now, why do we use S3? Why do we need a storage service, right? Is because, like we have discussed previously, that we need distributed systems on an application. The more distributed it is, the more fault tolerant it becomes. When I say fault tolerant, basically it can tolerate faults in its nodes. Each node in the application, whether it be the storage node, the compute node, it could be the backend compute node, the database node, each of these nodes, if they fail, right, it can tolerate that failure in your application, can still be working. Okay, so Amazon S3 is a file storage system by AWS, which says that it will give you the availability of 99.99% times. That means only there's a 0.01% probability that your service is going to fail. Otherwise 99.99, it's actually not 99.99, it's 99.9999, 4 times 9, right? That is the kind of availability that AWS guarantees that your object will have. And obviously you can increase this SLA, this basically called a SLA, service level agreement, that what kind of service will AWS provide to you. You can further increase this SLA by providing redundancies, by using certain techniques wherein you can take a backup of your bucket at every 24 hours, so that if there is a data corruption, you can always get that data back, from the vaults and then store it back again in the bucket. But that is only when you have failure in the S3 service. And for that, I told you the probability is 0.0001%. Okay, that is the kind of service that AWS provides. So you can be rest assured that if you want to host files on AWS, if you host it on S3, your files will be available pretty much all the time, right? That is what you have S3 for. Now, what are the common use cases where you will be using AWS S3? You can imagine it like this, that if there is a website wherein the logo is there, if there are certain images on that website that have to be loaded at the time of a web page reload, all those images will be taken from S3 and will be presented over there, right? So rather than storing all these files on the server on which the website exists, you can store all these files, all these images on S3, and then you can just get it from there, right? S3 also provides you the facility of hosting static web files, right? So you can host a website also by using an S3 bucket, and all you have to do is enable static hosting on that bucket and you will be able to host static websites in that case. Alright, our next service, guys, is AWS Glacier. So AWS Glacier is an extended version of the S3 service, which is the Glacier does not give you a direct access to itself. It basically takes a backup of the S3 service. So let's say you created a folder in S3. So folders in S3 are basically called buckets, right? The root folder in S3 is called bucket. So if you have a bucket and you have a lot of files inside that bucket, and if you want to take a backup of all those files, you can take it using the Glacier service in AWS, right? And Glacier service, the reason we have two services over here, the reason for that is that S3, you can get the objects instantaneously. The moment you put the link of the object, you can download it, right? You can access it. But when we talk about Glacier, it takes time for the object to be retrieved. It takes times in hours, sometimes 2 or 3 hours to retrieve a file in Amazon, right? So that is the kind of service that Glacier is, and it's a backup service and it's also cheap. So the main difference between S3 and Glacier is that if you are taking a backup in Glacier, it'll be very, very cheap. I think it'll be 1/10 of the cost of the same size of files which exist on Amazon S3. The reason for that is Glacier is strictly a backup service, and because it is low priced, because of that, there are some compromises in its performance, wherein the time to retrieve the object, it takes time, right? It takes 2-3 hours to retrieve an object in Amazon Glacier. When you compare it with Amazon S3, it's instantaneously, and that is why even the price is higher on the S3 service. More about pricing we'll talk as we move along in the session, right? But right now it is very important to understand the functionalities of these services, right? So why do we use AWS S3? For hosting our files, and those files can then be retrieved on whatever application we want. It's basically anywhere on the internet. If you put that link, you will be able to download that file. So that is what AWS S3 is for you. If you want to take a backup of AWS S3, then you can use AWS S3 Glacier, which will help you to take backup of any buckets or files which are there in your S3 inside it, right? After Glacier, guys, the other service that we're going to discuss is EFS. So what is EFS? EFS service is again a storage service, but it's different from S3. How is it different from S3? That EFS service can be mounted on your operating system as a volume, right? Isn't that interesting? So you can mount Amazon EFS as a volume on any computer on the AWS network, right? So let's say you launch a server of Windows on AWS and you feel that, you need a network drive. If you guys have worked with network drives, then EFS is exactly a network drive. It mimics the usage of a network drive, right? And it's also scalable. That means the size increases as and when you need it, right? So that is scalable. It can be attached to multiple computers. That is, it can serve you as a shared drive. That is, there could be tens or hundreds of computers which have the same volume inside them, and that same volume would be EFS for you. So how does that help? That helps when you have a scalable architecture, where there are 7 or 8 systems, and whatever changes one system is doing, that has to be seen by the other system as well. So in those kind of cases, you use EFS, wherein they will have a common drive on which the data will change dynamically. No matter which server is changing it, all the changes will be available on the other servers as well. And that is what EFS is for you guys, right? So EFS can be mounted on Windows machine. It can also be mounted on Linux machines. And the way you use it is, I just told you, it acts as a shared drive. And where do you use it? You use it where you want shared data between multiple servers which are working in an architecture. All right. So that is what EFS is for you guys. Then our next service is AWS Storage Gateway. So it basically helps you to connect an on-premises system to the AWS cloud infrastructure. So if there is any storage application which is there on your on-premise systems and you want it to be connected to the AWS infrastructure, you will be using the AWS Storage Gateway service. All right. So guys, this was all about the storage domain in AWS. Let us quickly jump on to our AWS Management Console. So I'll show you a few of the services in AWS Database. So let me jump on to my Management Console. All right, guys. So here I am on my Management Console. The first service that we discussed was under storage, which was S3. So let's click on the S3 link, and that will give you UI which will look something like this. So I have some buckets already configured. You can create a new bucket. So like I said, bucket is nothing but the root folder where you put all your files, right? So let's say the bucket name is test-Intellipaat, right? This is the bucket name. Then the region that I want to put this is, let's say I want to put it in Oregon region, and that's it. Let's click on next and keep all versions of an object in the same bucket. Leave everything at default. Just click on next. Leave everything at default, and now let's just click on create bucket. All right, so my bucket is now created. I can go inside this bucket and I can upload files over here. Let's try to upload a file. Let's click on upload. Let's click on add files. Let's go to pictures, and then let's try to upload something. Let's go to documents. Let's say I want to upload a file, and let's say I upload this particular file. Okay, so this is the file that I want to upload. I'll just click on next. It will now upload it. Click on next again. Here are the so this is basically the types of classes that you can access, right? Do you want to access, put it in S3? You want to archive the data, put it in Glacier? All those you can do. Let's click on next and click on upload. So right now we have not changed any setting in S3, right? We are just uploading an object, and as you can see, my file is now uploaded over here. Right now, if I select this file, I can actually see the properties of this file via this link. Right, here's an object URL that you get. If I click on this object URL, it will say access denied. Why access denied? Because first I have to make that object as public. So for that, what I have to do is I'll be going into properties, right? And over here, I will go to permissions and then I will go into public access, right? So right now it says you can't grant public access because block public access settings are turned on. Let's go ahead and remove those things. So I'll just go to Amazon S3, click on the bucket, and then let us click on permissions. And in this permission, I want to edit block all public access. I've done that. Let's save this thing. And to confirm these settings, just type confirm, hit and confirm. And my settings are now done. Now let's go back to overview. This is my object, right? And if I refresh this, it says still there's access denied. Now what I'll do is I'll go to permissions and now I'll give public access. So I want to give read object to everyone. Let's click save. Now if I go to the website, hit refresh, I can see the image over here. Now this link, anybody who has access to this link will be able to see this image. So you can also embed this link in your website and you will be able to load that page on your website just like that, right? So this is what the link does. This is what the link is all about. So if you upload an object, guys, and you want to make it public, just go to the permissions of that particular object, make it as yes, and you're set. All right. So this is how you can read from S3. All right, guys. So now let's start off with EFS. So I'll just click on the EFS service on my AWS management console. I will reach this page where I will have an option to create a file system. Let's click on that. And now it will ask me for the VPC that I want my EFS to be created in. Now remember, guys, the VPC that you select here should be the same as the instances on which you want to mount the EFS volume. So right now it's VPC 4B58233. Let's click on next step, right? Leave everything at default, guys. Don't touch anything else. Let's create the file system now. Alright guys, so my file system is now being created. Now remember guys, the security groups that are attached to this particular EFS drive has to be the same as well for your EC2 instances. Okay, so how to check which security group is this EFS drive mounted on? You can check that you can check it over here in this table. So right now it is in creating state. So once it is available, you will have the security groups listed over here. Okay. Now, since my EFS is going to take some time to set up, let me show you the instances that I've launched. So I have two instances. One is Ubuntu and the other is Ubuntu 2. I'm going to mount the same EFS volume, which I've created over here to basically connect to these two instances. Right now, how to do that? First, I will click on, let's connect to our Ubuntu instance. Let's connect to this Ubuntu instance first. So this is the IP address, and I guess I've already connected to this IP address, 172.31.51.195. This is the private IP address for the Ubuntu instance, and this is the same, right? So even this is the same. So let's close the extra terminal from here, and now let's connect to our second Ubuntu instance as well. So this is the IP address, guys. Let's copy it. Let's launch a new putty console. Let's paste the IP address. Let's select the PPK and let's click on open. For clarity, let us change the colors of the terminal. Let's make it orange so that we can differentiate between the first instance and the second. So as you can see, the IP address for this is 172.31.51.17, and the IP address is same over here as well. So that means we have two Ubuntu servers that are now open on my putty terminal. And what we will be doing is we'll be connecting this EFS mount point to my Ubuntu instances. So this is a security group, guys, 7F087236. Now we'll have to ensure that both my instances have that security group associated with it, right? So if we have to check the security group for my Ubuntu instance, here it is, guys, the security group which you'll have to connect. So what you will be doing is you'll be going to networking. You'll go to actions, go to networking, and click on change security groups. So as you can see, it is only launch wizard 1 has been connected to it. My security group that I have to connect is 7F087. So this is the security group that I have to connect to my instance. So let's connect both of them, right? And now let's click on assign security groups. So my Ubuntu instance is now connected to the security group of my EFS. Let's do this to our second instance as well. Let's select the default security group that is there. Great. So now both my instances are connected to the security group of my EFS, right? Now what I'll be doing is I will be following a set of instructions that you will find on this console as well, right? So the first thing that you have to do is on an Ubuntu instance, you will have to install this package. Let's do that. So this is my first instance. Let me copy the command and it is already installed. Great. Let's do the same on our second instance as well. So let's first update the machine, sudo apt get update. All right. Once it's updated, the next step would be to run that command. Now let's run that command and my NFS common package will install over here. Right now what I can do is I can create a directory on my first instance. Let's the directory be EFS test. Okay, great. And let's create a directory here as well. Let's name it as EFS test 2. Okay. Now what I'll be doing is I'll be mounting my EFS volume. So for mounting it, just copy this command, go back to your server, paste the command and put the directory name. So in case of my first instance, the directory name is EFS test. Let's hit enter. Great. So EFS test directory is now connected to my EFS volume. We'll verify whether that is working or not, right? Let's similarly copy the command over here as well. And this would be EFS test 2. This is the directory name. Great. So even this instance is now connected to EFS. Let's go into EFS test 2. Great. Now, as you can see, if I do an ls over here, there's no file, right? Similarly, if I do an ls over here, there's no file. Let's create a 1.txt file. Let's put sudo. Great. If I do an ls, you can see there's a 1.txt file over here. If I do a ls over here, you can see there's a 1.txt file here as well. That means this is a shared volume, correct? If I create, let's say, one more file over here, if I do an ls over here, I can see the 2.txt is also available. Similarly, I can create a file from here as well. And if I do an ls over here, I can see that the 3.txt file is also present. So guys, this is how EFS works. It acts as a shared drive between multiple instances in AWS. All right. So let's come back to our slides, guys, now. So guys, we discussed what S3 is, we discussed what Glacier is, we discussed what EFS is, and we have discussed what storage gateway is. Our next set of services belong to the database domain. So let's go ahead and understand these services. So the first service, so guys, the database domain comprises of these many database services in AWS. The first AWS service that I have is Amazon RDS. Then we have Amazon DynamoDB, Amazon Redshift, and in the end, Elastic Cache. So let's understand these services one by one, starting off with Amazon RDS. So guys, Amazon RDS is nothing but a relational database service. Guys, it's not a database, it's a database service. What do you mean by that? Is that you will, under the RDS service of AWS, you can launch these many databases. You can launch the Microsoft SQL Server, you can launch the MySQL service, you can launch the Oracle SQL, PostgreSQL, MariaDB, Amazon Aurora. You can launch all these databases. But what is RDS for? RDS basically manages these databases. Now, how does it manage? It makes sure that it takes automated snapshots of all these databases, which will be corresponding to a particular time. It can also ensure that if there are any read replicas required or if there are any replication required in your database, that also can be taken care of RDS or by RDS. Third thing is it also takes care of any security patch which has to be applied on your database if you enable automatic updates, right? So this is how RDS works, guys. Now again, let me emphasize on the point that RDS is not a database. It's a relational database service in which you can launch all these relational databases. All right. So guys, I hope RDS is clear with you. Next service is Amazon DynamoDB. Now, what is Amazon DynamoDB? It's basically a NoSQL database by Amazon, right? And what is a NoSQL database? Whenever you have to store unstructured data, that is data which does not follow a particular format, you use unstructured database like DynamoDB. Now, alternatives to this, you might have seen or you might have heard about MongoDB or you might have heard about other NoSQL databases. This Amazon DynamoDB is a NoSQL database by Amazon, right? So there is no database that it supports, it itself is a database unlike RDS, and in this you can store unstructured data. Okay. Third service is, guys, Amazon Redshift. So Amazon Redshift is a data warehouse service, which basically what it does is under the data warehouse you will have multiple databases. So those databases can be queried by your warehouse, and it looks as if all the databases, they combine together to give one database where all the data exists, but it is actually not like that. Amazon Redshift comprises of multiple database engines which it can connect to and give the output as required. Next service is Amazon Elastic Cache. So Amazon Elastic Cache basically is a service which serves as a cache. So what is a cache? A cache is a layer between the client and the web server, or the server from which the information is being requested. What happens is, let's imagine you want to get the data for an employee whose salary is greater than 10,000, and you basically want to get all the current cities that the employees are staying in, right? Now let's say you do this query time and again. Now what happens, your server is again and again doing a query on the database using a particular query that this is the data that I want. Now what happens is, when again and again you're doing the same query, it does not make sense to run the same query again on the database, let it do the computing work and then get the results. So for these kind of data, what Elastic Cache does is, whenever it sees that there's a frequently accessed data, it stores that data on the cache, which means whenever a similar request will come, rather than querying the database, the same data will be going back to the customer from the cache layer itself. So it decreases the overhead on the database, and it also at the same time increases the performance of your application. All right. So that is what Elastic Cache is all about, guys. Alright guys, so our next domain is the security domain. So in security domain, these are the following services that we have in AWS. So we have the first service, which is AWS IAM, and the next service is AWS KMS. Let's check out both these services and understand what they do. So guys, IAM is basically used to authenticate users to your AWS account. Now, the account that you just created on AWS, it basically is the root account for that AWS account. Now what happens is, big companies or companies like Netflix, Airbnb, they own only one AWS account. And what they do in that AWS account is they create multiple users with restricted permissions. Okay. So each user can have their own user ID and password, but basically they will be logging into the same AWS account. And that is possible using AWS IAM, right? So you can create multiple users for a single AWS account with granular permissions, such as what actions can they do on the AWS Management Console. You can also restrict them to particular services that they can access. For example, the user can just access S3, or he can just access EC2, or he can just read EC2 and cannot stop and start an instance, or he can just start and stop an instance but cannot create a new instance, right? Or you can put also a restriction that nobody can terminate an instance whoever users you are adding, right? The account or the user that you signed up with, that is basically the root account. Now what is the root account? Root account always has all the privileges, right? It has all the privileges, can do anything. But if you have to put any restrictive access to a particular person, you'll have to create a user account in IAM. So that is one type of account that you can create in IAM. The second type of account that you can create in IAM is an application account. Now what is an application account? Let's say I have a website which can upload data to S3. Now how do I authenticate my website to upload data on S3? For that, we have the AWS IAM service, using which I can create application identification keys as well. So what you get in that case is you get access key and you get a secret access key. So that access key and secret access key has to be embedded in your program, and only then your program is authenticated to upload data onto the S3 service of your AWS account. Otherwise it cannot, right? So this is one of the reasons, or these are actually the reasons that you use IAM for, right? It can help you to put restrictive access on user accounts as well as application accounts. All right. Moving forward, guys, the next service is KMS. KMS means Key Management Service. So Key Management Service is basically used to create the key pairs that we saw. while we were creating EC2 instances, right? So those key pairs are actually created by the KMS service, right? So similarly, if you want more key pairs to be created, you just have to head on to the KMS service and you can create your key pairs over there and authenticate yourself accordingly to whatever service you want. All right. So guys, this was the security domain. Now let's move on to our next domain, AWS Services Management. Alright, so this is our next domain, guys. So let's see what all services are included in this domain. So guys, these are the domains that are included in this, these are the services that are included in this domain. So first service is AWS CloudFormation, then we have AWS OpsWorks, then we have AWS CloudTrail, and in the end we have CloudWatch. Now, what is AWS CloudFormation, guys? AWS CloudFormation is basically used to templatize an AWS infrastructure. Okay, so let's say I have launched two EC2 instances with a load balancer with in an auto scaling group which is connected to an RDS instance, which in turn is also connected to my EFS. So all these things I will have to launch, right? If I know what the architecture is, I will have to launch everything one by one, and then probably my architecture would be ready. But what I can do with CloudFormation is everything I can specify in a JSON file. So in a JSON file, I can specify all the resources that I want to launch, all the things that I want to configure in the network, everything I can specify in the JSON file, and just run it through CloudFormation. So what CloudFormation will do, it will create that whole architecture according to my JSON file. So I don't have to stress too much on, creating my architecture one by one using either through my management console or through my CLI, right? I can directly do that by just writing a JSON file and passing it through my CloudFormation. So this also helps us when we want to replicate our architecture across multiple regions, right? Let's say I have an architecture in one particular region, I want to replicate it across multiple regions. So in that case also CloudFormation helps us a lot. So it's an automation tool which can help us to launch AWS resources by specifying it in a JSON file. Our next service is AWS OpsWorks. Now it's a little similar to CloudFormation because this also deals in automation, but basically this is a configuration management tool. So if you guys are aware of DevOps, there's a configuration management tool called Chef, right? So Chef recipes are readily accepted by AWS OpsWorks, and what you can do is in AWS OpsWorks, what happens is there are multiple layers that you have to configure, and all these layers together they form to become a stack. Okay, so what I'll be doing is, let's say in the first layer I specify the EC2 instances that I want to automate on, right? The second layer could specify what all software that I want to be configured in that EC2 instance. So that is how OpsWorks is helpful, guys. So a configuration management tool is nothing but which can configure all the software requirements on a particular set of servers at the same time, right? That means if I have to install, let's say MySQL on, let's say 100 servers, how will I do that? It's a very daunting task. I'll have to go to each server, I'll have to install MySQL. So OpsWorks makes it easy for me, and it makes it easy in a very effective manner. That is, every server will have the same configuration that I specify in OpsWorks. Now don't get confused with CloudFormation and OpsWorks, guys. CloudFormation is used to deploy an architecture. OpsWorks is used to specify consistencies in that architecture with respect to the softwares that we are going to install in that. Okay, so and also it's not just a one-time deployment that you'll be doing through OpsWorks. Let's say tomorrow your database link and the password is changing, right? And you have some 200 servers in your fleet. How will you do that? So that is possible using OpsWorks. All you have to do is just go to that layer where you have specified the link and the password, just change that and update or deploy the OpsWorks architecture. And then in that case, it will update all the servers with that very small change that is specified in one of the layers, right? So for all these very small changes, which are very important and have to be same across all the servers, I use OpsWorks, right? Next service, guys, is AWS CloudTrail. So AWS CloudTrail is basically a monitoring service which logs everything which is happening in your architecture, right? So that logging is not enabled by default to some of the services. You can enable logging by specifying that, AWS CloudTrail should log each and every action which is happening. And it exactly does that. It basically would log each and every action or each and every event that is happening inside a particular AWS resource once you attach AWS CloudTrail to it. And then that log data basically you can use to do further monitoring by connecting it to probably a BI service which can visualize your log data, etc. Right? So that is what AWS CloudTrail is all about. Then our next service is AWS CloudWatch. Now, what is CloudWatch? CloudWatch is basically, again, it's a monitoring service, but it's a little different kind of monitoring service, right? So what you can do with CloudWatch is you can set up alarms. For example, if let's say I want an alarm whenever one of my servers goes in unhealthy state, right? No, so how would I do that? So one thing would be that I continuously hire my employees and they are constantly checking if my servers are in the healthy state or not. Or what I can do is I can configure will take very less time to just configure my CloudWatch to monitor all my resources, and whenever there is a resource which goes in the unhealthy state, it can trigger an alarm. Now, what kind of alarm can it trigger? It can either email you or it can basically trigger a next set of events. It can trigger to create an EC2 instance, or it can trigger an AWS Lambda function. It can trigger something else as well. So this is what CloudWatch is all about. It watches all your resources, and on basis of that, it can do a simple process that you define in CloudWatch. Okay. Moving forward, guys, our next domain is customer engagement domain. So in this domain, we have the following services. The first service is Amazon Connect, and then we have simple email service. So let's look at what these two services do so that they are so helpful in the AWS community. The first service being Amazon Connect, guys. So Amazon Connect is nothing but it's a full-blown customer contact center for your company. For example, you would have seen that whenever you purchase a product, there's always a customer helpline that you can call on, right? And then you get the IVR options in there where you choose, and then you get connected to human agent to talk your way out, right? Or you to put your grievances and you talk to your customer service agent, right? Now, if you want to set up something like that for your company, it is very simple to set up that using Amazon Connect. You can build a customer contact center in less than 5 minutes with Amazon Connect, right? All you have to do is go to Amazon Connect service, click on get started, and it will allot you a toll-free or a normal phone number based on what you choose. After that, you just have to fill in the agents that you want to be on the other side, so that whenever people will be calling that one particular toll-free or normal contact number, they should be routed to the agent screen, right? And this happens on the internet, so there is no need of purchasing carrier plans or something like that, right? So this is what Amazon Connect is all about, guys. Our next service is simple email service. Now, this is also plays a vital role in customer engagement. You would have seen that you get marketing emails from a lot of companies. For example, if there are food companies that you order for, or if you have went into a store, you gave your phone number over there in the contact list, they'll also message you. Pizza delivery stores or grocery stores, they all email or SMS you one way or the other, right? This service right here is when you want to have email interactivity with your customers, right? You can send bulk emails. You can also set up your simple email service to respond to particular reply emails, right? So that is what SES is all about. And this also can be configured to route emails. For example, if there is an email address that you set up for your company, for example, support@intellipaat.com is our email address, right? So if you email to that particular email address, it will get routed to our support agents who will help you out in solving your queries, right? So that all can be set in Amazon SES. Guys, so this is it for the customer engagement services. Our next domain talks about app integration, right? So in this domain, we'll basically have services which help you to integrate 2 or 3 services in AWS. Let's look at what services they have to offer. So there are 2 services services basically, guys, one service is called simple notification service and the other one is simple queuing service. Let's see what these services are. So the first service, which is Amazon simple notification service, basically helps you to send notifications to other AWS services in occurrence of an event, right? So it waits for a trigger to happen, and based on the trigger, it sends a notification to a corresponding AWS service which has to work next. For example, you can set up a website which can send you an email, and all you have to do is, let's say, whenever a customer purchases something from your website, you want to trigger an email to the customer with all the details. Now, if you have to do this on a distributed environment, what will you do is the moment there is a trigger that there is a cash payment received from a particular customer, your Lambda event will be triggered, right? Now, that can be triggered in numerous ways. One way is either your service can directly trigger the Lambda event, but that is only possible for some of the AWS services. The other way around is that you can send a notification to SNS, right? So SNS will detect the type of notification received and it will have a mapped out row as to which service it has to notify next. So in this case, it will receive the notification. It will see, okay, so this is the type of notification received. It will invoke the Lambda function, which will basically send out the email to your customer. All right. So this is how an SNS service basically works. As you can see in the diagram here as well, that you have a publisher. A publisher is a person who sends out the notification, right? The next thing that you do is the way of filtering out different kind of notifications in SNS is that you define topics. Okay. So based on the topics, the messages are filtered, and what you do is in the topics, you will define which service to basically trigger. And based on that, those services will be triggered, and the services to be triggered are basically called subscribers. Okay. So guys, this is how an SNS service actually works. Moving forward, now let's look at the simple queuing service. Now, what is a simple queue service? It's basically a queue it's basically a place where you can store all your jobs whenever you have a stateless kind of an architecture. What is stateless kind of an architecture? Let's say you have a system which doesn't have its own memory. The prime example for this would be AWS Lambda. So what AWS Lambda does is it does not know what is happening in your application. Okay. What it knows is just the job that it has to do. For example, let's say the job of the Lambda server is just to send an email, right? It will not know whether it has already sent an email to to a particular customer or not. It will not know whether it has already sent an email to a customer, right? What it will do is it will just pick up jobs from the queue that you have, and based on that, it will perform the job. And that is exactly why you have a simple queuing service, so that it can feed to Lambda what the next job is without Lambda having to remember what it has to do, right? So guys, this is what the SQS service is. Now guys, this was all about the different AWS services that we have and that you need to know in order to get started with AWS. So I think we have almost covered all the use cases that you can encounter in an organization, and basically your job would be to that based on the problem you would have to suggest an AWS service, and that AWS service implementation also details you will have to know, right? So based on the knowledge that I've just given you what each and every service does, you can now decide what an architecture should basically have in order to get a job done. All right, moving forward guys, now let's talk about a very important topic, which is AWS pricing. Now we know about all the services that we're going to use, right? But what will we do or how will we use these services totally depends on the pricing of these services, correct? So let's move forward and understand how the pricing model works in AWS, and if I'm using a set of services, how will I be charged? How much will I be charged? So guys, the AWS pricing options are among these three, right? The first option is pay as you go model, which means whatever amount of time you will be using an instance for, or whatever amount of time you will be using a server for, that amount of time will be billed to you and will be given back to you. So whenever you will be launching any server, you will get a per hour basis charge on that particular service, right? So you can see that service, you can see what the charges are, and accordingly you will be charged whenever you terminate that instance or whenever there is a monthly billing cycle of yours which is ending, right? So the first model is pay as you go model, which is widely used. Second model is save when you reserve. Now, what do you mean by that? Let's say you're launching a website today, right? And that website is for your company, and you foresee that I will be at least running this website for the next 3 years. Based on it's just a startup, I might not see that much growth, but I will sustain it for 3 years. In 3 years, my website is gonna there, right? Let's say this is the scenario. So what you can do with AWS is you can opt for dedicated instances or reserved instances. So you can say that I'm going to use this instance for 3 years from now on, right? And I'm not going to back out. I am going to use this instance for 3 years. Then what AWS will do for you in that case is it will give you a counter offer. It will give you a discounted price, right? Reason being that it is no longer an on-demand service. It's a service that you have asked from AWS, which you will use for 3 years, which means that you will have two options in front of you to get this kind of a deal. One thing is you can do a full upfront payment of 3 years, right? You can pay all the whatever discounted price they deliver to you. You can just give the amount for 3 years and you can use your instance, right? Then you're locked in. Or what you can do is you can also do a partial upfront payment if that eases out the financial stress on you, right? For example, you do not have that kind of money to pay for 3 years. So what you can do is you can divide your payments into EMIs and then you can pay it to AWS. That's a partial upfront payment. So with this, you can get discounts up to 70% of the pricing which is there in pay-as-you-go model, right? So guys, that's very cheap. So if you have an application where you know the server that you're going to use is going to be there for like 2 or 3 years, then it's better to go for reserved instances where you can opt for taking a server and you'll get huge discounts on using them. Right? The third kind of pricing is pay less by using more. What this basically means is the more you will be using your instance, for example, your instance, the type of pricing that you get, for instance, is on a per hour basis, right? The more you will use your instance, the less the hourly rates will become, right? So that's also an awesome feature by AWS, which says pay less by using more. All right. So guys, these were the pricing options in AWS. There's one more pricing option that you get in AWS, which is called spot pricing. What is spot pricing or spot instances? Spot instances are basically idle instances which AWS is running, and what it does is it offers it to you in a cheaper price, right? So for example, it's 2 p.m. in the afternoon and I know that the load is less at this particular time. So what AWS will do is it will offer you some instances at a lowered price rate because those are just sitting idle over there, and if you want to use them, you can use them. So what happens in that case is you take that instance and you bid it, right? If you want to take that instance, you'll have to bid amount on that particular instance. The higher the bid amount is, obviously that bid amount will be lower than the actual rates, but the higher the bid amount is, that instance goes to that particular person, right? Now there is a catch in this, basically, that if somebody bids higher than what you have bidded, in that case your instance will be stopped immediately and it will be given to someone else who has done the bidding higher. All right, so that's a catch over here, but it could be particularly helpful when you are dealing with workloads which are not that important, but anyways you have to do them, right? In those kind of scenarios, you can take up spot instances and you can just bid a particular amount which you feel you are comfortable in, and in case in future the price goes up, your instance will be stopped, but at least you're getting your work done in a cheaper rate, right? So that's the ideology behind spot instances. So I guess now it's clear with all of you what AWS pricing options you have. Now let me move ahead and let me tell you a very exciting point about AWS pricing, right? The free tier. So the free tier is basically one-time offer that you get whenever you sign up. So whenever you sign up on AWS, if you are using a T2.micro instance, which is 1 GB of RAM and 1 vCPU of computer, in that case, it will be totally free of cost to you, right? So what you do get in a month is 750 hours of usage. So you can launch 4 instances, 5 instances, all of them together collectively can be run for 750 hours. The moment you cross 750 hours, you'll be charged the normal price, but up till 750 hours of server usage, you will be not charged a penny, right? And this is what the free tier is all about. Now it is particularly helpful for people who are trying out AWS or people like us who are trying to learn AWS for our future careers, right? So I'll request you all guys, so whenever you're practicing on AWS, always be under the free tier, because that is literally not going to cost you anything. All right. So the 750 hours that you get are particular to EC2 and RDS. Apart from that, you get some other free tier limits as well. For example, in S3, you have, if you store data up to 5 GB, you will not be charged anything. Okay. Then in DynamoDB, if you have to store something, which is if the instance which you are running is under the free tier, and if you want to store something on DynamoDB till 25 GB, it is absolutely free. Okay, so guys, this is the kind of pricing that you get. These are the kind of perks that you get when you're using AWS for the first time. For more details on AWS free tier, you can just visit the aws.amazon.com official website, and they'll give you all the details. There are a lot of other services as well that they offer free tier in or free limits in. For example, the Amazon Connect service that we discussed, which was basically a one-stop customer support center setup. In that, you get in a month you will get the first 90 minutes of your calling for free. And the way you get charged for that particular service is not on the number of hours that you'd be using that service, but on the number of minutes a customer is speaking to an agent, right? That is how you get charged. That's, I think, pretty cool about Amazon Connect. Alright, moving forward guys, I think we have covered enough of theory. Now let's go ahead and do a hands-on where basically I'll show you guys how to set up your AWS services and how to migrate an application from your local computer onto AWS. So let's start off with our hands-on. So guys, what I've basically done is I have created a website using which we can upload data on S3. Okay, so this is how the architecture looks like. So basically my website can upload data on AWS S3, and that record is also saved in a MySQL database. Now, as of now, this MySQL database is on the local host, and also the website is on the local host. And right now my website cannot connect to S3 because it is not being able to authenticate itself. All right, so this is what we are going to, the first step that we're going to do is we're going to authenticate our website to AWS S3 to upload data. Once we have done that, we will migrate this website onto AWS infrastructure. All right, so without any ado guys, let me first show you how my website basically looks like. Intellipaat, basically the company that we work for, is an e-learning company, and we basically researched a lot of job descriptions, and what we came up with was this Cloud and DevOps Architect Masters course. Now in this, we have put down all the skills from all the job descriptions that we have got, for cloud related jobs. And also we are in touch with, since we are with a training company, all our instructors are basically working professionals. So we have got in touch with top cloud and DevOps professionals and asked them what are the relevant skills that you think are expected from a cloud engineer, person who is basically appearing for an interview. So based on what the feedback that we got from our instructors, based on the feedback we did from our research, we have come up with this course. And these are the things, or these are the skills that we teach to a person when we take him basically on board with us in the Cloud and DevOps Architect Masters course. So let me jump on to my browser, right? So guys, my website basically exists on localhost/new, right? So this is how my website looks like. The first thing that I would have to do is I will have to check if it is able to connect to a database. So basically whatever I will be uploading, I can view that over here as a list, but right now it cannot connect to the database. So what I do is I'll open up my MySQL on my local host. Here it is, right? And now what I'll do is I'll create a database called images. So because that is what I have configured in my code, right? And now let me create a table with the name names, and let there be one field called name with the value as varchar, and let us give pretty big value so that any length of characters can fit in this particular table. All right, so it says no database selected. Oops, I'm sorry for that. So use images, and now let's create the table. So when I do a refresh over here, it should be able to connect, but now it will show you an empty list because there's nothing inside my database, right? If you want to show anything over here, it will basically be visible once entry is made inside the database. Second thing is, right now, if I try to upload anything, let me go to pictures and let's say this is the image that I upload. If I click on open and if I click on submit, my file basically will not be uploaded. Reason being, it will say the authorized header is malformed, which basically means authentication is not yet given to my account. Now, how can I give authentication to my website so that it can upload on S3? For that, I'll have to head on to my AWS Management Console, and as we have learned, there is a service called IAM. So I will go inside that IAM service, and over here, what I'll do is I will create a user, right? And let's say the username is web demo, and what I will have to give this user is the programmatic access, so that by code this user will be able to access all the services on AWS. Now, the kind of services that I want my website to access is only S3, right? So let us put an S3 over here, and as you can see, there's a permission over here which is Amazon S3 full access. Let's give this access to this particular user, and let's review it, and let's finally create the user. Once we have created the user, guys, I will have the access key ID and I will have the secret key, access key. Now, this is very important for my application to be authenticated. So what I'll do is I will just copy this access key ID. I will go to my terminal. I will create a new page, and this is my access ID, guys. And this is what my secret access key looks like. Okay, so this is my access key, this is my secret access key, and this will be used to basically connect my website onto AWS S3. Okay, now let me show you how my index or how my code looks like, guys. So guys, this is my code which I'll basically use to upload files onto S3. As you can see, the key and the secret key are not filled as of now. So let us fill the key first. So the key is this. Let us enter it over here, and the secret key is this. Right, so once I enter the key and access key, secret access key, my website will now be able to authenticate itself onto S3, and now it should be able to upload objects into a bucket, right? Which bucket are we talking about? Let me quickly show you. So there's a bucket that I've just created on S3, and that bucket name is basically test Intellipaat. So as you can see, there are no objects in this bucket as of now, right? And now what I'm going to do is let me refresh this website. And as you can see, now it says new record created successfully. That is, the image that I chose earlier should now be uploaded over here. So now if I do a refresh, I can see there's one image that has been uploaded. Let's upload one more image for the sake of understanding it. Let's upload this particular image and let's click on submit. So what happens is, the moment it takes up a file, it changes the name of the file into a random name, and then it uploads it over here. So if I refresh, you can see there's one more image which just has been uploaded. Now, what I can do is I can just go back to my website and I can just click on checklist. So this will give me a list of files which are uploaded onto my S3. If I click on this list, I can basically download the file from S3, and if I click on it, you can see the file. This is what I uploaded, right? Similarly, if I click on it over here, this is the file that I uploaded, right? Similarly, let me upload one more file so that it's clear for everyone. Let's say I upload, let us not take an image. Let us try to put something else. So let's say there's this app, this test.jar that I can upload. So let's just click on open and let's click on submit. So this is the file. I click on submit, and now if I do a refresh over here, I should have that file. Okay, so that file might be a little larger in size, that's why it's not uploading. So what I can do is let me take this particular image, right, and let me submit this. As you can see, a new record has been successfully created. If I click on checklist, there is a new image which has been added. If I click on this image, I can clearly see that this is the image that I uploaded. Similarly, if let us try some other file as well. Let's choose a file. Let's try to upload this Excel file. Let's click on submit. And when I do that, a new record has been created. Great. If I check the list, this is the Excel file that has just been uploaded. If I click here, the Excel file is downloaded. If I click open this, this basically file should now open, right? Great, guys. So I think our website is working fine, but the problem is this website exists on my local host, right? And right now it is basically feeding data onto my local MySQL instance. So if I basically would just do a select star from images, select star from names. This is the name of the table. You can see that this is all the values that are there in the table, and these are the values that you can see over here. So the first thing that I should do is basically let us deploy a database on AWS through which my website will basically be connected. For that, I will be heading on to RDS. Since this database that I'm using is MySQL, let us try to deploy a MySQL database on AWS. So for that, I will be clicking on Create Database. And the type of database that I want is MySQL. Let's select that. And now let's click on Next. Next, I want to create a dev environment or test environment because this is just a POC. So I've selected this and I'll click on Next. Next, I can select the MySQL version. So let it leave it at default right now. And I want to enable only options which fall under the free tier usage. Okay, so let's select this option. And everything is filled automatically. Let's identify our DB using a name. Let's say it's web-demo, right? The master username, let's say the master username is Hemant. Let's specify the master password as well. And now let's finally click on Next. Right now it will ask me which VPC do I want to put my instance into. So I have the default VPC where my instance is being launched in. That's great. Second thing is public accessibility. Do I want internet to be able to access RDS? So yes, I want public accessibility to be enabled. If I select no, in that case, there will not be any public IP which will be assigned to my RDS instance. Only the VPC in which my RDS instance resides in, only the instances launched in that particular instance or in that particular VPC would be able to access that RDS. So when I say VPC, it's basically a virtual private cloud, or it's basically a virtual network, right? So if I do not give public accessibility to my RDS, then it will only be able to connect to machines which reside in that particular network on which it is being deployed, right? Not on the internet. Okay. So, but because our website right now is in my local host, from local host, I should be able to upload data onto the database of AWS. So for that, I will need public accessibility, right? Do I want to create a new security group? No, I don't want to. Let us select the default security group. Okay. What should be the database name? So the database name would be the same that I've given for my local MySQL instance, which is images. Rest you can just leave at default. Backup, I don't want any backup, so let's select 0. And disable monitoring, we don't want that. We don't want any upgrades made to my database, right? And I think that's it. Now let's finally click on Create Database. Now guys, the database instance, it takes around 3 or 4 minutes to create. Meanwhile, while this database is being created, let me tell you the next step that we have to do. Now, since this website exists on localhost, I want this website to be existing on basically AWS. I want this website to be uploaded on AWS. And for that, let us use Elastic Beanstalk, which is the platform as a service on AWS, right? So let's open the AWS Management Console, and now let's head on to Elastic Beanstalk. In Elastic Beanstalk, you can basically upload your website, and I'll show you how you can upload your website, and you don't have to configure anything on the instance. Every software, everything will be configured by Elastic Beanstalk itself. So as you can see, when you reach this page, you just have to click on Get Started, and now it'll ask you the application name. Let's say the application name is web-demo. Right? What platform is my website based on? So it's based on PHP. Do I want a sample application to be deployed previously? Yes, I do. So I'll just click on Create Application now. So guys, this will basically create a web app for me in Elastic Beanstalk. We have done this earlier as well. We're doing it once more so that we can upload our own website onto this particular Elastic Beanstalk application. Okay, so it'll again take guys 3 to 4 minutes for Elastic Beanstalk to get deployed. Meanwhile, let's check if our RDS is ready. I'll just head on to RDS. I can see there's an instance which is running. So it is still in the creation phase. So once the creation phase is over, you would be able to get an endpoint over here. So an endpoint is basically a URL through which you will be able to connect to your database. All right. So let us wait for this database to be ready. And once it is, I will try to connect to this database from my localhost and see how that goes. Right, so it's in the creating phase. Similarly, my Elastic Beanstalk is also being created. Let me show you my code, guys. Let me explain you my code a little bit. Right, so this is my main file. So in this file, basically, I am using the PHP backend language on which I have basically imported the AWS SDK, right? This SDK, you can basically just Google AWS SDK for PHP and you would be able to download it. Now I have included this particular folder in my root directory of my website, which is over here. So this is the folder which has all the libraries, right? And my index.php will basically has included this particular library, and then the service that I want to connect to is S3. So we are using the libraries of S3 over here, right? My bucket resides in Oregon region. The code for that is US West 2. This is my key. This is my secret access key. Don't worry, guys. I will be deleting the user account, so don't try using these keys. They will no longer work once I have the username deleted. Apart from that, it's pretty simple. It's a very straightforward code, guys. Right now, the database that I'm connecting to is on localhost. That's why the server name is localhost. When I would want to connect to my RDS instance, all I have to do is change this server name to the endpoint of RDS, and then it should work like a charm. Right, that's it. This is my index.php. My list.php, where I get a list, is basically I'm just connecting to that same database which exists on localhost, and I'm trying to read everything from the table. This is the field that I'm reading. On the front of that name, I'm attaching this URL. So this is the URL for my bucket, and this remains the same for each and every object which gets uploaded. Right, so I'm I'm attaching this along with the name, and this I am basically storing in an ahref tag, which basically gives me a link on my website. Right, so if I can show you over here, as you can see, this is a list, right? And this is the link. So this link is basically a ahref link in which I have embedded this URL with my file name. All right, so once I've done that, it works great. It works like it is supposed to. Now I guess we should go ahead and check if my RDS is ready. Yes, guys, so my RDS is now in the available state. So how do you connect to RDS? There will be a database which has been created on my RDS, but still the table is still not created, right? So first I'll have to create a table on this RDS instance, which would basically be exactly the table like what I have on my localhost. So how do I connect to my RDS? So just copy this endpoint, guys. And now you'll have to go on to CMD, right? So once you are on the CMD, guys, the next step is to go to the bin directory of your MySQL installation. So my MySQL installation is basically in WAM64. So I'm going to go in there, right? So I'm inside the bin directory now. Next thing would be that I will have to call in MySQL. -h would be the host name. The host name in my case is the Amazon's host name, which is this. The username for this RDS instance, it's Hemant. And the password is this. Let me specify it over here. Let's hit enter. And now, if everything has went well, I should be able to connect to my RDS instance. Let's wait. So while this is happening, guys, if it gets stuck like this, it could be that you're not able to connect to your instance, and the reason for that could be in the security group. So you'll have to check if the inbound rules for the security group are open to accept traffic. So let's click on inbound, and yes, so this is the problem over here. It's allowing all traffic, but it's only allowing to this particular security group. So what I'll do is I'll make it anywhere and I'll save it. Once I do this, let us come back here and try to run the command again. I'll enter the password and hit enter. So as you can see, I have successfully connected to my MySQL instance, which resides on AWS. Now this instance should have a database called images. Let's use that. And now let's create a table which would be the same as what I did on my localhost. So the table name would be names, and the field name would be name, and the type of information that can go in is varchar. Let's specify that. Okay, so my table is now successfully created, guys, and now my database is ready to basically take in data. Now what I'll be doing is, let us go back to RDS and let's copy this endpoint, and now let's make our website maybe be able to basically interact with my RDS instance. So it's pretty simple. Just change the server name to the endpoint of RDS. The username in my case is Hemant, and the password in my case for my RDS instance is Hemant1994. Alright, that's it, guys. That's all we have to do. And let's save this code. Similarly, in my list, I will have to change the values from localhost to these variables. I'll save it. And now when I go back to my website, let us open the local MySQL instance also. So this was my local MySQL instance. As you can see, there are only 4 entries over here, right? Now let's choose a file. Let's try to upload the same XLXX file, the Excel file that is, and let's now click on submit. So it says new record created successfully, but let us check here if this is where my data has been entered. So no, my data has not been entered over here. Let us check on my RDS if my data is being entered correctly over here. Select start from names. So yes, a data has been entered over here with the this particular name. And if I click on checklist, as you can see, even here I get the same value. So you can compare that this is the name that I'm getting over here and this is the name that I'm getting on my website. If I click here, I'd be able to download that Excel file successfully. Great, guys, this is what I wanted. So now my website is basically connected to my database instance on AWS. It was that simple. Now the next step is basically to put this website on AWS for good so that everybody in the world can access it. Now how can I do that? This is my Elastic Beanstalk, guys, and this is the dashboard that I get when I use the platform as a service instance. Right now it says here upload and deploy. So that's what I'm going to do. I'm going to click on upload and deploy. And now it's going to ask me to choose a file. Now the way you can upload a website over here, guys, is you will have to go to your website codes, right? And then you will have to zip these files like this, right? So once the files have been zipped, this zip has to be uploaded over here. So I'll choose a file. Let me go into that folder where I have the zip. Here's the folder. Let's click on open. Version label, let's try to give this version label as 1.0. Okay, and now let's click on deploy. So now my website is now getting deployed to AWS Elastic Beanstalk. It will hardly take some 2 or 3 minutes for my website to be ready on this particular platform. And once it is, we'll be able to use it via this particular link. This link will basically be my application now that I've shown you on localhost. This will now be available on this particular link. So let me close all the unnecessary windows. And now let's wait for this to be ready. Okay, so it will take around 2 to 3 minutes, like I said, and whatever version that I've specified, that version will now be reflected over here. Okay, so it would be AWS 1.0. So let's say in the future I make change to my code, any kind of change to my code, I would be able to upload it over here in the same manner possible. That is, I will have to click on upload and deploy, and then I will have to increment the version. I will show you that as well. Let this complete, and then we will go ahead and check. So as you can see, my running version is now AWS 1.0. Great. So this is what I wanted. Now it's the moment of truth. Let's try to go to this URL and see if our website is working or not. So great, guys, my website is now available on this particular URL. Let's try to check if it is able to upload everything. So let's first check a list. So we have one file which is there in my database, which is uploaded. Now let's choose a file. Let's try to upload the zip file itself, right? I'm not sure if it will be able to upload. Let's check. So the uploading has started. It says new record created successfully. Awesome. Let's go here. Let's refresh this. As you can see, a new entry has been made. Let's try to download this. So as you can see, the zip is being downloaded. And if we go to our S3, if we refresh over here, you can see the zip is present over here as well. And my zip is also downloaded. If you want to verify if all the contents are fine or not, let's do one simple step. Let's create a new folder here, right? And now let's try to paste this extract over here. It will extract all the files. Click on OK. So all the files are now being extracted. Let's do a Control X and let's paste here. Let's delete these files. So basically on my localhost hello, there should be a file. My website should be up and running. So localhost/hello. So as you can see, I can see my website over here. And if I do a checklist, if I do a list.php here, I should be able to see even the list. So that means these files that have now been uploaded to S3 are working correctly. And also I have successfully migrated my website, which is there on my localhost, onto Elastic Beanstalk without even going to the terminal, without installing any software on the server, right? It is now up and ready, and anyone who will visit this particular URL will be able to access my website. Okay, and as simple as that, guys. And it's basically hosting my files as well. My files are now all available on this particular link. So anywhere in the world, if anybody would go to this particular link, they will be able to access these files. They just have to click on it and they'll be able to download it.
What is Amazon VPC? So guys, Amazon VPC is basically a service. It's basically a virtual private cloud, which is given to us by AWS when we deploy resources on its cloud platform. And what this Amazon VPC basically enables us to do is basically launch AWS resources into a virtual network that we define, right? So VPC is basically a virtual network that we define. This virtual network can have multiple subparts as well. It can have multiple configurable properties as well. And the whole service is called Amazon VPC, right? Now, the definition is not that important, but the working is the most important for Amazon VPC, through which you will be actually able to understand what you can accomplish and what all is possible when you are basically making use of the Amazon VPC service. So let's go ahead and understand how Amazon VPC service basically work. So guys, this is the skeleton diagram for Amazon VPC, and you can imagine how you can basically, how internet basically works at your home system or in your office system by looking at this diagram. So what basically happens is, first there is the internet, right? So you are first always on the internet, and from the internet, there is a request which comes in. So let's say you are at your home system, and if somebody has to, reach out to your computer, let's imagine it like that. How will it work? So first you have the internet, and from the internet there will be a request which will come in. Now in AWS, what happens is, like I said, you have a virtual network that you create. So first of all, any resource in AWS that you create is enclosed inside a virtual network. It could be EC2, it could be any databases. So it has to be enclosed inside a network, right? So we will have this network. Let's say this is the network of ours, which is called the AWS VPC service. And any network or any internet connection which has to come inside this VPC service will have to come in through something called as a internet gateway. Okay, so when you create a virtual network, for that virtual network to have internet access, you basically need to create a resource called internet gateway, and this internet gateway is going to be a single point through which internet requests are going to go out, and internet requests are also going to come in, right? So the internet can basically be accessed using the internet gateway, and whenever a request is coming in through the internet, the first place that it goes to after the internet gateway is to a resource which is called routing table. Now, what is a routing table? Now, when you create an AWS network, what happens is you also have something called as the subparts of the network, or subnetworks, let's say, right? So let's say you create an AWS network, and in that AWS network, you create two subparts, which are basically called subnet 1 and then subnet 2. So these two subnets will have their own resources inside it. So let's say in subnet 1, you have a database which you have deployed, and in subnet 2, you have a EC2 machine or a virtual machine that you have deployed. Okay. Now let's say if the internet has to reach to this machine, which is there in subnet 2, the way it is going to work is, first it is going to, the request is going to come in from the internet gateway. From the internet gateway, now the request does not know how to reach the machine. So what it will refer to is basically something called as a routing table. So in the routing table, basically you will have all the details with respect to which, how can you reach the resource. So this resource will basically have a private IP address, right? And this private IP address can be reached out to using the routing table, right? Or in other words, you can also imagine it something like this, that how will the internet gateway know about these resources? The internet gateway knows about these resources when it is basically a part of the routing table. So when the routing table is visible to the internet gateway, then these resources are also visible, right? And from the routing table, basically you reach the subnet 2, and in subnet 2 you have that resource. Okay, so this is a skeleton of what AWS VPC is. First, the request comes in through the internet gateway. The internet gateway refers to the routing table, and from the routing table you basically go through the subnet where you have the resource, and from the subnet you go to the resource. Okay, now there are something called as firewalls in this architecture. Now you will ask, okay, you just told us that the request just comes in, so how is it filtered? So that filtering process happens using firewalls, and there are two kinds of firewalls in VPC. The first firewall is called NACLs, right? And this network access control lists, these are called, and these basically operate at the subnet level. That means that there is a firewall at a subnet level, and there is a firewall or the instance level, which is basically, or the resource level, which is basically called security group. So there are two levels of firewalls in a VPC network. Okay, so that basically means that when the request is coming in, there is no filter which happens on the AWS VPC level. The only filter which happens is on the subnet level, which is the network ACL. Okay, from the network ACL, if the request gets filtered, then it basically goes to the security group of the resource. So if I were to include these two firewalls in the diagram, it can be imagined something like this. That first the request will come from the internet. From the internet gateway, it will look for the instance that it has to go to in the routing table. From the routing table, once it gets to know where the resource is, it will go there. And in the subnet, it first has to basically go through the first level of firewall, which is the network ACL. From that firewall, it then goes in if the request is filtered out. And when that request is filtered out, then it encounters another firewall, which is basically called a security group. And if it filters that out, then only it is able to access the resource. Okay, so this is the flow diagram of how a request flows in a VPC. And now what I'm going to show you guys is basically how to create this kind of an architecture in AWS, right? So what we're going to do is I'm going to quickly jump on to my browser and let me open AWS Management Console. Give me one moment. All right, guys. So first you have to basically go to aws.amazon.com. And on aws.amazon.com, you basically will sign in. And this is where you will reach your AWS Management Console. Now, on the AWS Management Console, what we have to basically work with is virtual private cloud. And let's try to now create the architecture. So this is how our architecture looks like. So first, what we'll do is we'll create AWS VPC, right? So let's go ahead and create a VPC. So we'll click on VPCs, we'll click on create VPC, and whatever I've explained to you guys, we will try and test it out by doing the hands-on. So that is what we are going to do. Okay, so first let's name our VPC something. So let's call it VPC demo 1. Let's call it that. And now let's give it a IP address range. This IP address range will basically mean that all the resources in this VPC are basically going to have an IP from this particular range, which you are now going to define. So let's go ahead and define a range. Let's say it's 192.1.0.0/16, right? Let's say this is the range. And now we'll basically go ahead and click on create VPC. So our VPC has now been created, and what we have done is we basically went ahead and created a simple network. We have not defined any of these resources as of yet, right? We have just created an empty box, which is our AWS VPC. Now, whenever you create a VPC, guys, what happens is automatically, when you will go ahead and create subnets, it will automatically create some resources, and I will tell you that. So right now, these subnets are of some other VPC that they are not of the VPC that I created, right? So what I'll do is I'll go ahead and create two subnets, which is subnet 1 and subnet 2. So let's go ahead and create that. So let's click on create subnet. Let's call it subnet 1-demo. And the VPC obviously is going to be VPC demo 1. This is the one that I created. Now, this subnet can be deployed in 3 availability zones. These are basically different data centers that AWS has in the region that we are working in. Let's deploy it in the first data center, 1A, right? And now we have to specify an IP range, which is basically going to be part of the main range, which is there of the VPC, right? So let's specify a range 192.1.1.0/24. So this is going to be the range of the subnet that we are basically creating right now. So we'll click on create. And now the VPC 1 subnet 1 has been created. Similarly, we'll create one more subnet. Let's say it's VPC 1 subnet 2. Right? The VPC is going to be VPC demo 1. This time, let's say the data center is going to be of 1B. Right, and specify the IP range as well. So this is going to be the IP range. Okay, let's click on create. Okay, so my second subnet has also been created. So if we refer to our diagram again, so we basically created a VPC, we created 2 subnets, and now let's create the routing table. Okay, now right now I have not created any routing table, but if you go to your routing tables, you will be able to see that this is your VPC's routing table. As you can see, it's VPC-demo1, and this is automatically created. Okay, so this is whenever you create subnets, a routing table is automatically created, and this routing table, if you want to look, what subnets it is basically associated to. So you can just click on subnet associations. It is not, basically created by, or it is not basically connected to any subnet as of now, right? So a routing table is automatically created. And why is it created? Let me show you that as well. So if you go to routes in this, you will basically see that there is already a route which has been added, which basically says that all the IP address from this range can basically talk to each other in this virtual network. So this is the default rule, which basically says that if I deploy this resource and if I deploy this resource, they can talk to each other. Why? Because that is the default rule which is present in the routing table. Okay, so these two will be able to talk to each other. Why? Because this rule is present, and this rule is by default, and this rule you cannot delete as well. Okay, so this is one thing. Now what we want to do is, since these two subnets can talk to each other, but they cannot talk to the internet as of now. So that is something that we are going to configure. But how does the routing table know that which subnets can talk to each other? Okay, so for defining that, what you'll have to do is you'll have to click on subnet associations, click on edit subnet association, and include these two subnets over here. So when you do that, now this routing table says that both these resources can talk to each other via the routing table. And now what we want to do is we basically want internet to be available in this routing table as well, right? So we are going to configure that, but right now let's not configure the internet, and let's see what will be the behavior in case we don't add the internet, right? What we are basically going to do is let's go ahead and define the firewalls now. So let's first define the network ACL. So again, in this case, if you go to NACL, this is basically the subnet level firewall. So over here, you can see there's already a network ACL which is created for VPC demo 1, right? So this is also created by default. And if you look at the inbound rules or the outbound rules, so what is this firewall saying? That all traffic is right now allowed. So anyone who wants to have access inside this subnet, inside both the subnets, because both the subnets are associated to this NACL or this firewall right now, all traffic is enabled to all the subnets in this particular network. Okay. Similarly, if you look at the outbound rules, you can basically request anyone on the internet from within these two subnets. So that is what our network ACL is right now saying. Okay, so we're not going to touch that. So let's move on to security groups now. And when we move to the security groups, over here as well, you will be able to see that there will be a default security group which will be created, and which VPC is ours, we can basically make out by looking at the IDs, right? So our VPC is of the ID 69D, right? So that's what we have to look out in the security groups. So we'll go to security group 69D, right? This is the VPC ID of us, and this is the security group that is basically created by default. So let's name this as default security group or default demo 1. Let's name it that. So this is our security group which has been created, and if you look at this security group's inbound and outbound rules, they are going to be very limited, right? So all traffic is allowed, but it is only allowed from within the resources which are connected to this security group, right? So we can change this if we want. So we want anyone to be able to go through this firewall. So I'll just specify anywhere and we'll click on save rules. Okay. So now what we have done is we have opened both our firewalls, that is the subnet level firewall and the instance level firewall, right? One last thing that we should do before we can go ahead and deploy these resources inside these subnets is basically to tell these subnets that these resources can have public IP addresses. Okay. So how do we go ahead and configure that? So just select your subnet. So let's say this is subnet 1 demo 1 that I have basically went ahead and selected. So what I'll do is I'll click on actions, click on modify auto assign IP settings, and here I will say auto assign IPv4 address. So by this, now what is going to happen, that any resource that I'm going to create inside this subnet, it is automatically going to have an IP address. Similarly, I'll do that for my subnet 2 as well. So let me specify the name correctly. This is subnet 2 - demo 1. And in this, again, I will say that basically any resource which is deployed in this should have a IP address, a public IP address. Okay, all set. So now what we have done is we have not configured the internet gateway yet, but we have created a network. Inside this network, we have a routing table, and this routing table has a default rule, which basically is allowing both these subnets to talk to each other. We have created this firewall, which is allowing all traffic. We have created this firewall as well, which is allowing all traffic. Okay, so let's go ahead and test this architecture out. So what I'll do is I'll go to EC2, and now I'll basically go ahead and launch two machines, one in subnet 1 and the other in subnet 2. Okay, and there is a behavior that I want you guys to notice. So first I'll go ahead and create an Ubuntu machine. I'll create a t2.micro, which is basically going to be a part of VPC-demo1, right? It is basically going to be in, let's say, subnet 1. And other than that, everything can be left at default. In the security group, we are basically going to configure or select the default security group that we created, right? And now let's go ahead and click on review and launch. So now what we'll do is we'll basically select a key that we already have. So I'll select Mac-Mumbai. I already have this key and I click on launch instances. So with this, I have launched a machine in subnet 1. Now I want you to notice something. This is subnet 1 machine. And this is being deployed. While this is being deployed, let's deploy the second machine as well, which is again going to be an Ubuntu machine, t2.micro. It is going to be a part of our demo 1 VPC. It's going to be in subnet 2, going to be a part of the default security group. Let's review and launch. It's also going to have a key pair, which I already have. And now this machine is also launched, and this is going to be a part of subnet 2. Now, what is something that I want you to notice? So first of all, this will have an IP address because we specified in the subnet that the machine should have an IP address. But now if I try to connect to these machines, you will see that I will not be able to connect to them. So if I open my terminal really quickly, and let me try to go ahead and connect to these machines. You will see I will not be able to connect to them. It will basically give me a connection timed out kind of a request. And the reason for that is because I am on the internet, I'm trying to connect to these resources, but this internet gateway is not there, right? This internet gateway is the only way that this VPC will be able to talk to the outside world, okay? And because it is not there, you will see I'm getting a connection timed out kind of a thing. So how can we fix this? So now let's go back to our VPC console and let's go ahead and create something which we call as an internet gateway, right? So we'll go to VPC. Inside VPC, we will go ahead and go to internet gateways. And in this internet gateway, I'm going to create this. This is a default internet gateway which is attached to the default VPC that we created. And what we're going to do is we're going to create one more internet gateway. Let's call it IGW demo 1, right? And let's create it. Once it has been created, what we'll do is we will attach it to our VPC. So right now it's in the detached state. So I'll have to do and click on actions, click on attach to VPC and attach it to VPC-demo 1. Attach it. So it's attached. So now that it's attached, guys, we should be able to see this internet gateway in our route tables, right? So if I go to my route table, so this is my route table. This is the demo 1 route table, right? So if you go to routes, we can click on edit routes, and now we can add a route for the internet gateway, which is IGW-demo 1. We'll add that, and the whole internet can be accessed using this internet gateway. We'll click on save routes. And now if we go ahead and try to run the same command, you can see I'm able to connect to my machine. Isn't that great, right? So now, since we are able to connect to this machine, we should be able to connect to the other machine as well. So let me connect. And let's go to our second machine's IP address. So this is a subnet 2 machine. Let's connect to it. This is the IP address. All right. So now, as you can see, I have successfully connected to these two machines. And now let's see if these two machines are able to talk to each other, right? So how can we check if they're able to talk to each other? So if we try the public IP address, obviously they will be able to talk to each other because this is going to be via the internet. But what we want to see is whether they can talk within the network. And for that, we are basically going to make use of the private IP address. Okay. So this is the private IP address of subnet 2. So what we are going to do is from the subnet 1 machine, I'll try to ping subnet 2. And as you can see, I'm able to ping the machine in subnet 2. Why? Because in the route table, we have that entry wherein they are able to talk to each other. Great. So now let's try something out. So what we can do is we can go to, since subnet 1 is able to talk to subnet 2, let's go ahead and go to network ACL. That is basically the subnet level firewall. And there, let's try something out. So we'll go to VPC. And in VPC, we will now go to network ACLs. So let's create a new network ACL. It will basically be subnet 2-demo1. And this is going to be a part of VPC demo 1 VPC. Right, and let's say this is for subnet 1 and this is for subnet 2. So in this, what we can do is we can remove the subnet. Let's remove the second subnet. Let's say in this subnet, I go ahead and I specify that only network connection from subnet 2 is possible from subnet 1, but subnet 1 from subnet 2 is not possible. That means that let's say only this machine can ping to machine 1 and machine 1 is able to ping to machine 2. Now, how is that possible? I will just specify that all traffic from machine 2 is allowed, but from machine 1 is not allowed. So we'll specify something like this. So 1 second. Okay, so I basically just have to add /20 over here, save it. Okay, so now what I've specified is that only subnet 2 is able to ping into the network ACL. Now, what does that mean? That basically means that if somebody is trying to go ahead and ping subnet 1 to subnet 2, it should not be able to do it. Let's try it out. And now you can see, since I have edited the network ACL, I am not able to use these machines from my personal system as well. And the reason for that is now the subnet is not allowing my machine as well to connect to these machines. Okay, so let me make you understand that using the diagram over here. So what we did is basically these firewalls, these subnet level firewalls, have only allowed connection from machine in subnet 2. Only this IP address I have added in this firewall. Now, because of that, what is happening is from the internet, I'm not able to reach this subnet. Why? Because this firewall is blocking me. So I'll not be able to SSH into this machine now. Okay, so let's try to change what we were doing. Let's again go back to network ACL. So I'll go to VPC and we'll again click on edit inbound rules. We can again make it 0.0.0.0/0. Save it. And now again, if I come back to my terminal, I should be able to connect, right? Similarly, I should be able to connect over here as well. Okay, so instead of, let's say, changing the subnet level firewall, let's go ahead and change the security group firewall, right? So in the security group firewall, what we can do is we can tell that only my machine should be able to ping it, right? And then only subnet 2 should be able to ping inside it. Subnet 2 machine should be able to ping inside it. So how can we do that? Let's go to security groups. So our security group is this one, 69D. So let's go inside it. Click on edit inbound rules. And all traffic is allowed only from my IP. This is my machine's IP. And only from, let's say, I want to go ahead and allow only subnet 2 to be able to ping inside it. Subnet 2 machine to be able to ping inside it. Okay, let's click on save rules and let's see how this is going to work now. So now in this case, my SSH is going to work perfectly fine, right? So if I will try anything over here, it will work perfectly fine. If from my first machine, I try to ping machine 2, let's see what happens. So according to the rules that I have configured as of now, if I try to ping subnet 1 to subnet 2, according to the rules that I've configured, it should not connect, right? But let's see if our assumption is correct or not, and then I'll explain whatever the behavior is happening over here. Can you see we are not able to ping the first machine, that is subnet 1 machine to subnet 2 machine? Okay, this is the subnet 2 private IP. this is not able to ping, or on the diagram, this machine is not able to ping this machine, right? And why is that so? Because in the firewall for these machines, what I've configured is that only this machine, the subnet 2 machine, can go ahead and ping the other machine, or only this machine's IP address is allowed in the firewall and no other machine can ping, which basically means if I go ahead and go to my second instance, and if I try to ping the first machine, I should not have any problems. So if I select subnet 1 machine over here, select the IP address from here, come back, set the IP here, hit enter, you can see the ping is working, right? And why is that so? Because in these security groups, I have specified that only my subnet 2 machine connections will be allowed. So if I go ahead and change this, if I go ahead and make this 192.1.0.0/16, if I make that to basically work, now what will happen? So let me just verify if this is a CIDR range. Yes. So this is a CIDR range for all the instances or all the resources in this VPC. If I click on save rules now, you can see that this ping now again started to work, right? Why? Because this particular rule is now allowing everyone inside the VPC to be able to ping each other, right? And hence this ping started to work. Again, if I go ahead and if I change it to, let's say, only subnet 1 machine being able to ping each other, then it will be a different story. Just give me one moment. Okay. All right. Okay, guys. So now if I go ahead and change this to only subnet 1 machine's IP address, what is going to happen then? In that case, only subnet 1 machine will be able to ping subnet 2, and the other way will not be possible. So if we save the rules, so now you can see both of these are working, right? So let me clear the screen once more and let me start this command. Right? So now if I go ahead and save the rules, you will see that this is going to stop now in a few moments. So what we have now added, that we have added that only subnet 1 will be able to talk. So if we try this out. So subnet 1 connections are allowed and subnet 2 connections are not allowed. So if I try to ping from subnet 2 to subnet 1, this should not be allowed now. Can you see? The ping has now stopped. And why is that stopped? Because we have changed the firewall rules so that only one machine should be able to talk to each other. All right. Great. So guys, I hope this particular diagram is clear. So what we have done so far is we have created a VPC. We created 2 subnets. These 2 subnets, we basically had a routing table associated with it, which is created by default. This routing table did not have access to internet. So we created an internet gateway and we included that internet gateway in the routing table. And then we were able to basically access both the subnets from the internet. right? Then we went ahead and configured the two types of firewalls that we learned. First is the network, the subnet level firewall, and then we try to configure the instance level firewall, right?
Intellipaat, basically the company that we work for, is an e-learning company, and we basically researched a lot of job descriptions, and what we came up with was this Cloud and DevOps Architect Masters course. Now in this, we have put down all the skills from all the job descriptions that we have got, for cloud related jobs. And also we are in touch with, since we are with a training company, all our instructors are basically working professionals. So we have got in touch with top cloud and DevOps professionals and asked them what are the relevant skills that you think are expected from a cloud engineer, person who is basically appearing for an interview. So based on what the feedback that we got from our instructors, based on the feedback we did from our research, we have come up with this course. And these are the things, or these are the skills that we teach to a person when we take him basically on board with us in the Cloud and DevOps Architect Masters course.
Now let's go ahead and understand the different kind of subnets right now. So the only thing that we understood is that we could create two subnets, but there can be two types of subnets which you can basically go ahead and create. The first subnet is basically called a public subnet, and the other subnet is basically called a private subnet. So a public subnet is a subnet which can basically be accessed by the internet, and a private subnet is a subnet which cannot be accessed by the internet. Now, what do we mean by that? So right now, both our subnets are being able to be accessed by the internet. But what I want is only one subnet should be able to be accessed by the internet, and the other subnet should not be able to access by the internet. Now, how is that possible? So it is possible using an architecture like this. So what we are basically going to do is, we are basically going to have two subnets. We are going to have an internet gateway, but from the main routing table, we are going to not associate that routing table to our subnet 1, right? We are going to create a separate routing table for our subnet 2, right? Which is not going to be associated with the internet gateway. So all in all short, in the first routing table, the main routing table, we are going to remove the subnet 2 and we'll only have subnet 1, which is basically going to access internet. And we are going to create one more routing table so that our second subnet can associate with it and then be able to talk to the first instance or the subnet 1 instance. Okay, so let's go ahead and implement an architecture like this. So what we need to do in our existing VPC is, here nothing will change, subnet level nothing will change. In the routing tables, what we're going to do is, this is my demo 1 routing table. Let's say this is going to be my public routing table, since this already has the internet gateway attached, right? Let's create one more routing table. Let's call it as demo 1 routing table, but this is private. Okay, and this will be associated to VPC demo 1 VPC. Let's create it. Okay, this is created. Now in the demo 1 public routing table, we are basically going to go ahead and edit subnet associations. And I want to remove subnet 2 from over here, which is this. Let's remove this. So only subnet 1 I want to associate. So I'll just click on save. So now only one subnet is associated, which is subnet 1, which basically means if I try to access my instances, now let's try to SSH. This is subnet 1. Let's try to SSH into it. This is working perfectly fine. Okay, this should not work. Let me check what has happened. So this is the routes. This is basically having an internet gateway for this subnet, which is fine. Then we have this routing table. Okay, so in this, I will have to edit. I will have to select the subnet, save it. Okay. And now you can see that this instance has stopped working. I can just quickly go ahead. And try connect to the subnet 2 machine, which is this IP. You can see I'm not able to connect now, right? And why am I not able to connect? Because for my second subnet, it is now not having any route for the internet gateway, right? But for my first machine, it is having a route for the internet gateway. So that's why if I exit this and try to connect again to my first machine, the subnet 1 machine, I'm able to connect, but for this machine, it is giving me an error now, or it is not connecting. Why? Because this machine no longer has internet access. Okay, but what we can do is we can try connecting to this machine, the subnet 2 machine, from within the VPC, which basically means that if I come back to my diagram, okay. So in this, now what is basically happening is that from the internet, I am from the public route table, I'm able to connect to subnet 1 machine. But from the internet, I'm not able to connect to subnet 2 machine. So what I can do is, and observe, the reaction over here, that I will be able to go inside this VPC and I will be able to connect to subnet 1. From subnet 1, I will be able to connect to this machine, right? Now from this machine, I can basically go through this route table and then connect to this machine. Do you understand this network architecture, right? So from this route table, obviously I cannot connect to this subnet because this route table does not have any details regarding this particular subnet. Okay, but this particular route table, the private route table, has basically allowed connections between these two subnets. And because of that, what we can do is we can basically go ahead and connect to this machine, and from this machine I can SSH into this particular machine, but it obviously has to be using the private IP addresses. Okay, so let's try that. Let's try that over here. So what I'm going to do is, first I need on my subnet 1 the key pair. So let me go ahead and copy the key pair. So I'll just go ahead and copy the key pair on this machine. Done. Let me again go inside it. So I'm inside the first machine now, and I have this key pair over here. Let me give it the required permission. It has it. And now let's try to go inside the second machine. And that we will do now using the private IP. And as you can see, I'm inside the second machine now. So you can see the IP address is 192.1.2.96. This IP address is 192.1.2.96. However, if I try to go through the public IP address from my machine into it, I will not be able to do that since there is no internet connection. But because there is a possibility, or there is a connection between this machine and this machine, I'm able to SSH from this machine into the subnet 2 machine. Okay, and that is what we have just done. Great. So now we saw how to create a machine with no internet access, and I can show you guys that there is no internet access. So since this is subnet 2 machine, if I try to curl google.com, you can see there is no response, right? It basically just hung. Why? Because google.com is not reachable. However, if I go back to my subnet 1 machine, so I have just SSH out, I exited the SSH of the second machine, and I'm now inside the first machine. As you can see, the IP address has changed. So if I go over here and try to do curl google.com, you can see that I'm able to see some content from the internet. But in this case, I was not able to see any content. Why? Because the second machine does not have internet access, and the first machine has internet access. Now, in what cases will it be beneficial? It will be really beneficial in cases wherein the let's say in subnet 2, I have a resource which I do not want anyone from the internet to be able to access. Okay. Why I don't want that? Because probably it's a very critical machine for me. I don't want this machine to be hacked in any sort of way, right? So that's why I do not want anyone from the internet to be able to reach it out. So in that cases, what we do is we create private subnets, right? Now, there is a use case wherein probably somebody from the internet should not be able to reach out to this subnet, but from within the machine, if the machine wants to access internet, that should be possible. So how can that be achieved, right? So that can be achieved, giving internet access to private subnets, that can be achieved using something called as NAT gateways. So what are NAT gateways? NAT gateways are basically resources which help private subnets to use the internet. Now, how does it help it? By basically giving a proxy connection to the internet gateway. So what's going to happen is it's basically going to help us connect to the private or the public subnet, and from the public subnet we will be able to access the internet. So basically you can imagine it like this, that a NAT gateway is going to be a machine which will be deployed in the public subnet, and our system is going to ping that machine to access the internet, right? So that is what a NAT gateway is. So how can you create a NAT gateway? You can basically just go to the VPC menu, and then you can go to something called as NAT Gateways. Here it is. And you can click on create NAT gateway. Let's call it demo1 -NAT. Which subnet do you want it to be used in? We want it to be used in subnet 2. And subnet 2, it needs an elastic IP to work. So let's allocate it. So it has to be, it has to be associated with a public subnet, because this has to be deployed in a public subnet, and then we will try to reach out to this NAT gateway from our private subnet, right? So we will deploy it in subnet 1, which is basically having internet access. And then we are going to click on create NAT gateway. And now what is going to happen is, basically it is going to create a machine in the public subnet. And this machine, we are going to reach out from our subnet 2 for internet. Okay, so NAT gateway was created successfully. So if you can see, the state is pending. It will take some time to get deployed. So let's give it that time. You can refresh. State is pending. So now what we need to do is, once it is deployed, we can go to route tables. We'll go to a private route table, go to routes. And now we can just click on edit route. So now what we want to do is, we want to add a route to the NAT gateway so that they can connect to each other. So we'll click on add route. We will give all connection to what? To the NAT gateway. And since it is being deployed, it will take some time. So let's give it that time. If we go ahead and again check our NAT gateway. Still in pending state, it will take some time. So it usually takes around 3 to 4 minutes to deploy. So let's give it that time. Because like I said, this is a machine which is launched, right? So this machine is launched and the software is deployed on it. So it takes some while to get deployed. And once it is deployed, you will be able to see it in your route tables. So if we look at the details for this NAT gateway, you can see that this is the private IP address for this NAT gateway. Oh, I think we have deployed it in some other VPC, guys. We have deployed it in custom VPC. Sorry for that. So we'll have to click on create NAT gateway, NAT-demo1, new, and this has to be okay. This has to be a part of 69D. This is the one. So we basically connected to VPC subnet 1. This is some other subnet that I created earlier. We basically wanted to connect it to subnet 1 demo 1. This is our VPC, right? This is the public subnet for us. And let's allocate an IP address. Click on create NAT gateway. Okay, really sorry. So I selected the wrong VPC in this case. So this is the one which is being created now. So you will see that this failed. So why did this fail? This failed because in the custom VPC that there is one more VPC which exists, right? So there is no internet gateway which is connected to that particular VPC, and that's why it failed, right? But if we see ours, it will basically get deployed in some time. So if we select the details for this NAT gateway, now let's verify if everything is correct. So the VPC-demo1 subnet is subnet 1-demo1. This is the IP address. So this IP address is according to the CIDR range of subnet 1, which is again correct, right? Okay, this looks good. So it takes around 2 to 3 minutes to deploy. Okay, so as you can see, the NAT has been created now. And now if I go to route tables, if I go to the private route table, click on edit routes, click on add route. Here, if I go to NAT gateway, I can see the NAT demo 1 new. I can add the destination as 0.0, click on save routes. This is done, right? Now, what has changed? So now if I try to access the subnet 2 machine, I will still not be able to SSH into it from my terminal, from the outside. So if I try this out, this will still not work. Why it will not work? Because this subnet still does not have outside internet access, but from within it, it can go ahead and use the internet. So now if I try to SSH into my second machine, this is now my subnet 2 machine. And from here, if I now do a curl on google.com, you can see that the internet can be accessed, right? So how is that possible? That is possible using NAT gateways. Finally, let's go ahead and understand what is VPC peering. Now VPC peering is a very simple concept. Now what it says is, if you have two VPCs and if they want to be able to interact with each other, you basically just have to create a peering connection. That's about it, right? You could create two VPCs, and if these two VPCs want to interact with each other, not on the internet, but using the internal network, you can do that by creating a peering connection. Now, how can you create a peering connection? So first of all, what you can do is, let me go to VPC. Let me quickly go ahead and see the three VPCs that I have. So I have a default VPC, which everyone has when you create an AWS account. So what I'll do is, I'll basically go ahead and launch an EC2 machine in the default VPC. So I click on launch instance. Select the Ubuntu server. And I want to deploy it in the default VPC, which is correct. Select the default security group. Launch it. So this is my default instance, which is there in the default VPC. Now, what I want is this instance should be able to talk to subnet 1 machine and subnet 2 machine via the private IP addresses. So if you see the private IP address for this is 172.range, right? And the subnet 1 and subnet 2 machine are in the 192.range. So I want these two machines to be able to talk to each other. So right now, if I go ahead and this is my subnet 1 machine now. If I go ahead and try to ping this particular machine, the default machine, using the private IP, obviously I will not be able to ping it. You can see the ping is not happening. However, if I go ahead and connect to this machine using the public IP, I'm able to connect, right? But this machine is not able to ping this machine over the private IP. Now we are going to change this. So how can we change that? Come back to your VPC console, scroll down to the VPC Peering section. Okay, so there is something called as VPC Peering. Peering connections. Let's click on create peering connection. And let's say this is VPC, or let's say this is demo 1 to default. So who's the requester? Let's say demo 1 is the requester. This is the CIDR range. And what I want to go ahead and connect to is the default VPC. And I want to click on create peering connection. Okay, so you can say it says pending acceptance. Okay, and now what you can do is click on actions, click on accept request. And now you can see this peering connection is now active. Okay, but that does not mean the ping is going to work. The ping is not yet going to work. What you have to do is you have to go to route tables. So since this is subnet 1 machine, I'll have to add a route in the subnet 1 table. Let's add a route that anyone should be able to connect to the peering connection. So if I add this range, click on save routes. Okay, 1 second. So 192.1.1.0/24, save routes. And here I think we'll have to add this CIDR range, which is 172.31. Okay, the route has been created. And now same I will have to do in the default route table as well, which is this one for the default VPC. So I'll select this, edit routes, add a route. This will be for 192.1.0.0/16 peering connection. This is the one. Click on save routes. And now you can see the ping has started to work. So now what is it being able to ping each other? So basically this is my subnet 1 machine. My subnet 1 machine is now able to ping the default instance that I created in the default VPC. Why? Because we have created the peering connection. Similarly, from here, I will be able to ping the subnet 1 machine. So it will take some time. Let me check. Okay. I think in the security group I have not enabled, so I'll have to just change the security group settings quickly. This is the default one, demo one, security group. I'll have to go to inbound rules, and here this small rule I'll have to change, and I basically want to allow everyone to be able to connect. And once this is done, even my second instance is able to talk to my other VPC, which is there in the other instance, right? So guys, this is what VPC peering means, that two VPCs are now able to talk to each other by creating a peering connection and having their connection details in the routing table. So guys, this is how you go ahead and create a VPC peering connection.
Intellipaat, basically the company that we work for, is an e-learning company, and we basically researched a lot of job descriptions, and what we came up with was this Cloud and DevOps Architect Masters course. Now in this, we have put down all the skills from all the job descriptions that we have got, for cloud related jobs, and also we are in touch with, since we are with a training company, all our instructors are basically working professionals. So we have got in touch with top cloud and DevOps professionals and asked them what are the relevant skills that you think are expected from a cloud engineer, person who is basically appearing for an interview. So based on what the feedback that we got from our instructors, based on the feedback we did from our research, we have come up with this course, and these are the things, or these are the skills that we teach to a person when we take him basically on board with us in the Cloud and DevOps Architect Masters course.
So, introduction to AWS DevOps. The first thing is, why DevOps on AWS? So you can use DevOps on any cloud service or even on your on-premise environment. So if you have a business running, you will have an on-premise environment. You might have an infrastructure for yourself. You can run it on it also. But why AWS DevOps? That we'll see moving on. So first, what is AWS DevOps? AWS DevOps is a set of developer tools which is provided by Amazon Web Services. This allows us to create a CI/CD pipeline from the scratch to the deployment stage, that is from the source. For example, a version control tool, maybe GitHub, maybe Azure repos, maybe AWS CodeCommit. So from the source stage till the deploy stage, we can do everything. It is the same as any DevOps tools, any DevOps lifecycle, or any DevOps process, but the tools are provided by AWS. And then, so why AWS for DevOps? What are going to be the benefits of using DevOps on AWS? So the first thing is fully managed services, guys. So we know why do we use a cloud service? Because we don't want to manage our tools or the VMs we have launched, the data we have stored. We don't want to manage it, or we don't have to install softwares on it. We don't have to do anything. It is all taken care by AWS. They take care of our infrastructure. So that is the first reason, guys, fully managed services. And then built for scale. Because AWS DevOps, you will be using it on existing services like EC2 or Lambda. So when you use on them, they already have a scaling feature within them. So obviously it is built for scale. So you can easily scale it up or down. And then programmable. You can write scripts, you can write shell scripts, you can create a program which you can implement inside AWS Developer Tools, which can actually impact your DevOps lifecycle. And then automation. So DevOps is mainly automation. So Automation is one of the main reasons, and automation is available in everything like Azure DevOps, AWS DevOps, even in GCP. If you are implementing DevOps, automation will be available over there. Or if you manually use DevOps tools to create a DevOps lifecycle, even then automation is required. So DevOps main motive is automation. And then secure, yes, AWS provides security and it is their first priority. And then pay as you go. Pay as you go model is that whatever you use, you only pay for that, nothing else. For example, you launch a virtual machine using CodeDeploy. So that virtual machine is running for 2 hours and then it gets terminated. So you'll have to only pay for that 2 hours time. You don't have to pay for creating a virtual machine and running it. You don't have to pay a month's fee. You just have to pay the money for that particular 2 hours. So moving on. Now we've discussed what are the benefits of having DevOps on AWS. Now we'll see what are the tools provided by AWS. So these are the 4 tools provided by AWS, guys, and these are the most basic tools. There are still more tools for developing, but these are the 4 most basic tools for creating a DevOps lifecycle. So the first one is CodeCommit, and then Code Build, and then CodeDeploy and CodePipeline. So let us discuss them. Let's discuss these developer tools in detail now. So first let us discuss CodeCommit. So the name suggests that CodeCommit is a version control tool. It is like GitHub. So it is like Bitbucket. It is a version control tool, guys, but it is provided by AWS and it also provides the same features GitHub provides or Bitbucket provides. You can do all of those stuff which is available over there, like committing, pull requests, merging branches. You can do all of it even using CodeCommit. You can also see over here CodeCommit allows 5 active users per month. So basically this is going to be your private repository. So it allows 5 users per month. For if you have a startup and you only have 5 members, you can actually use CodeCommit and you won't be charged even a single rupee. And also you will be given 50 GB of space every month. So for example, our repositories maybe maximum of a size of 1 MB or 2 MB, but 50 GB, they provide 50 GB of space for the repository, guys. And also 10,000 Git requests per month, like pull or push requests. So this is CodeCommit. It is a tool. It is like GitHub. It is like Bitbucket. It is the same kind of tool, but it is provided by AWS. And then AWS Code Build. So the name suggests that this tool is for building your application. So it provides a fully managed CI service, that is continuous integration service. It will compile your source code. You can run tests, you can run unit tests, and also provide software packages and store it in AWS S3 so that you can take out those packages and use it to deploy your application. So you can see here AWS Code Build, 100 build minutes. That is, if you run a build, it might run for 20 seconds. So like that, you can run any number of builds which come up to 100 build minutes. And also it runs using build.general 1.small compute type usage. So it runs with this, and for every month you get 100 build minutes free. Moving on, AWS CodeDeploy. This is one of the important service, guys. This service is used to deploy your application on any service you choose, like EC2 or Lambda. So it is an automated deployment tool which can deploy services like EC2, Lambda, Beanstalk. So even if you launch Beanstalk, it will be launched in an EC2 instance or Fargate, and also your on-premise setup. So these are the 4 benefits provided by AWS CodeDeploy. So first is automated deployments, and then minimize downtime, centralized control, and easy to adopt. So the first one is automated deployments. Is when you set it up, whenever there is a change in your repository, it automatically runs again, it builds your code again, and it gives it back. So that's what automated deployment means. It doesn't build and it stores, it actually deploys it again. Whenever there is a change in your code, it deploys and the change will be visible in your website. And then minimize downtime. So whenever the code is changed, it takes very less seconds. your website will be down for maybe 1 to 2 seconds and the change will be on your website, guys. So it minimizes the downtime. For example, when you do it manually, you will have to go to your system or your server where your website is launched and you will have to change your code over there. When you do that, the downtime increases, but using CodeDeploy you can minimize that. So I'll show that in the demo, guys. And then centralized control, you can just use your command line interface of AWS or the management console and you can control all of the operations happening in CodeDeploy, CodeCommit and code build. And then easy to adopt, you can see works with any application, and same experience whether you are deploying it on EC2, AWS or Lambda. That means if whatever service you are deploying it to, maybe EC2 or Lambda or Fargate or Elastic Beanstalk, it provides you the same UI with the same experience. So it doesn't change, it is the same thing, but the deployment environment is different. So this is CodeDeploy, guys. And then finally, AWS CodePipeline. So we are going to use CodePipeline. We can use CodePipeline to create a CI/CD pipeline, guys. We can use all those services to do that. So first thing, it is a continuous delivery tool. That's why it is called a CI/CD pipeline. So it is also fully managed by AWS. As I told you, that is one of the benefit. And also you can automate your website or you can automate your application, which is running on CodeDeploy. So when you create a pipeline, whenever there's a change in code, it automatically pushes it to CodeDeploy and the change will be made. So that's how you use CodePipeline, guys. You can see over here, take it as an example pipeline. You have some website over in your source, that is your GitHub. So you build it and you test it using some programs. So after testing it, you can give any number of stages. This is staging. This means you will be seeing this deployed, but you will be seeing it in a IP address which only you might see. You might have given the security group like that. But in production, when it gets deployed in production, then you can view your website using the IP address or the DNS name from any other computer, guys. So this is how you use AWS CodePipeline. And then, so you can see over here, easy to integrate AWS CodePipeline with GitHub or with your own custom plugin. So you can integrate GitHub and CodePipeline easily. You can just click on connect to GitHub. There is an option for that. Or you can use your own custom plugin, like you would have created something in Bitbucket or any other version control tool. You can even use that. And then also it is pay for what you use. It's the same thing, guys. And also there is no upfront costs or long-term commitments. So it is basically free. Whatever services you launch using it, for example, the EC2 instance, so those are charged, not these services like pipeline or CodeDeploy. And also rapid delivery, which basically means whenever there is a change in your code and it is applied to the master branch, it will be applied to your website directly. And then configurable workflow. The workflow, you will have an UI. You can configure your workflow, how it should happen, which is the deployment server, which is the production server, which is the QA server, or you can mention builds or you can skip builds. So you can create a workflow for your own advantage and then get started fast. This basically means it's pretty easy. They have a lot of documentation, guys. You can just go on, create your own pipeline in no other than like half an hour. So it takes only that much time. And then it is easy to integrate. You can integrate AWS CodePipeline with any service. You can integrate with even Jenkins. So this is what they say, easy to integrate. So right now let us move on and let us create a CD pipeline using CodePipeline and CodeDeploy, guys. So let me open my GitHub repository. So let me close this. So this is the GitHub repository which I am going to use, guys. So you can see over here index.html, abspec.yml, readme. This is the readme file, and then I have some scripts. So first I'll show the index.html file. So it is basically a hello world HTML. And then the next thing, the most important thing is abspec.yml. So this is a YAML file. So what it does is, you can see over here, the source is index.html. Destination is this. So this is where Apache 2 installs its index.html file, but we'll be deleting that file and launching our hello world application. So you can see here before install script/install dependencies and script/server start server. So I'll show that what actually is there. I'm going to scripts install dependencies. So in install dependencies, you can see guys, it updates the instance. After updating the instance, it will install Apache 2. And also guys, in your script, make sure to provide -y. This means yes, because you cannot go inside and click enter yes. So whenever you provide -yes, it will automatically take the command as yes and it will install the whole software. So whichever software needs a yes, provide a -y guys. So if you don't provide, it will fail. And then it will remove the index.html file in this location. That will be created by Apache 2, and that will be the Ubuntu default page created by Apache 2, but I don't want that page to be launched. I want my page to be launched. That is my hello world page. So these are the stuff I wanted to show you. Appspec.yml, I'll show why we need that, where it will be used. So now let us start off with our management console. So the first thing we'll be doing is we'll have to create a code deploy guys. So I'll go to code deploy first, and also I'll open So if I go to code deploy, basically you can see all of this over here. You can see source repositories. You can actually create a repository guys. To create a repository is very simple. You can just provide a name, for example website, and then if you want you can provide a description, or you can just create. That's it. But one more thing, you cannot use your repository from your root account. You will have to use it from your IAM user, which you can create, but you cannot use it from your root account guys. So I'm not going to use this. I'm directly going to use from my GitHub. So this is it's actually pretty simple. And then build is for as I told you, it is for building your application. But right now I'm launching my website, so I'm going to use only code deploy and code pipeline guys. So first thing we'll have to do is we'll have to create a, here you can see EC2, then AWS Lambda and ECS. I'm not going to use Lambda or ECS. I'm going to use my EC2 instance. So you'll have to click on EC2 and then create application. You'll have to select it over there because we'll be creating a deployment group which will be targeting the EC2 instance which we mention using tags. If you want to use Lambda, you can choose that also, but I want to use my EC2 instance guys. So now we'll have to create a deployment group. But to create a deployment group, we will need a EC2 instance. But currently I don't have an EC2 instance guys. So because we'll have to mention EC2 instance over here, I'll have to mention my tag over here. So before moving on with creating a deployment group, I'll create a EC2 instance. So first, what is deployment group? So deployment group is it directs or it targets to which instance should this particular code deploy application should deploy the application to, that is the website. So deployment group. So let me create the EC2 instance first. Let me teach you how to do that, and also how to install code deploy agent in that, because without installing code deploy agent in your instance, you will not be able to use code deploy for your instance, any instance which you use. So I'm going to use a Ubuntu server guys. So I'm going to EC2. So I think you would have learned how to launch an instance from our other videos which are available in our channel. So currently I'll not be explaining each and every step in creating an instance, but I'll teach how to create an instance which will benefit in using code deploy. So the first thing you'll have to do is you'll have to go to EC2 dashboard and then go to instances, click on launch instance guys. So you can see over here, choose AMI. AMI is Amazon Mission Images. Basically this means the ISO file. That is, you can see this is Amazon Linux, this is Red Hat, this is SUSE Linux, this is Ubuntu, and also you'll be having Microsoft Windows. So you can choose any of this and launch the server. But I want a Ubuntu server guys. I'm going to launch my website in my Ubuntu server. So I'll be selecting this. And then these are instance types. You can choose any instance, but I'm going to go with free tier eligible instance, t2.micro, which doesn't cost me any money up till 750 hours every month. So you can use this particular instance, you can run this instance for 750 hours every month. So I'm going to go with t2.micro. Next. And here number of instance, I just need one instance. And then one more thing, guys. This is the most important thing. You will have to include a IAM role. So why an IAM role? Because the code deploy agent should access your EC2 instance, and also the EC2 instance should be connected to your code deploy agent. So to give a connection between these two AWS services, you will have to attach an IAM role. I already have created an IAM role, guys. So I'm just going to go to EC2 code deploy. If you don't have one, you can just go over here. I'll tell the basic how to create a role. So role, create role. You will have to choose the service which you are creating the IAM role for. So EC2, next permissions. And here you will have to provide code deploy. So you can see Amazon EC2 role for code deploy. You can just choose this, and next you can provide a name over here and create the role, guys. So I already have created a role. So you can see over here EC2. So I already have created a role using that particular permission. So I have created, if you want you can create it. If you already have, you don't need to. So I have it, I chose the IAM role. And then also I'll have to enter user data. So what does user data mean? So basically user data is the commands or scripts which you want to run while the instance is being created. Once the instance gets created, these commands and these scripts will be automatically run. So we don't need to open the instance and run all of these. This will be automatically run if you enter the user data over here. So I have the user data over here, guys. You can see over here, basically it will update my instance. It will install Ruby. Actually Ruby is required for code deploy. And then if you want, you can install wget, or wget is already available in your EC2 instances. And then I'm going to this location, and there I'm going to install my code deploy. After installing that, I'm just modifying my permissions, and after that I'm installing code deploy, which got downloaded. After it gets downloaded, now I'm starting code deploy, guys. After installing code deploy, I'm going to start the code deploy service. Only if it is started, then I can connect my EC2 instance and code deploy. So I'll copy these and enter it in code deploy, guys. That's it. So this is what we have to enter, and you can see over here it asks for, I've given -y. So basically -y means yes. So when you install Ruby, it basically asks yes. So providing -y doesn't affect that. It will provide yes automatically. So we have done all of the required things over here, and then adding storage, 8 GB is more than enough. And then you'll have to add a tag, guys. So to add a tag, hit on add tag. Then I want to, the key is going to be name, and my value is going to be web server. So this is going to be my value. Why I am creating this tag? Because I'm going to use this tag so I'll have to enter this tag over here so that this code deploy identifies this particular instance, guys. So moving on, next, configuring security group. So already SSH is available, but I actually don't need to SSH into my instance. But right now I'm going to allow an HTTP rule, because I need HTTP because I'm launching a website, guys. My website needs HTTP. Without HTTP, my website will not be able to be seen using a URL, and also it can be seen from any IP address across the world. If they are using my IP address from any browser from anywhere in the world and through internet, they can see my website, guys. So reviewing and launching it. This is just for making sure if everything is right. So I'm good with it. And you'll have to choose the key pair, guys. If you already have a key pair, you can just choose the existing key pair and move on and click on launch instances. And now your instance has been launched. So you can just go to view instance. You can see my instance is being created right now. It's in pending state. So only if this is running. So right now I think I can see it over here. So right now I'll go back, and now let me start creating this deployment group. So my instance, let it get created. So my deployment group name is going to be web server deploy. So web server deploy 1. And one more thing, you'll have to enter a service role, guys. This service role allows this code deploy to connect with EC2 and other services like S3 or whichever you mention. So I have this service role. You can also create a service role for code deploy. So I showed you how to create a service role for EC2. So this shows how to create a service role for code deploy, guys. And then let it be in place, and then environment configuration. In environment configuration, you will have to mention whether you're going to connect your auto scaling group or your individual EC2 instances or your on-premise instances. I'm going to connect my EC2 instance, which is running right now. It is initializing, guys. So right now, if I just hit name, and you can see many values, my value was capital W web and capital S server. So I'm going to choose that. So now you can see there is one matching instance. If I click here for details, you can see over here, and my instance is showing. So this is the instance, and it is showing, so that I have connected this code deployed group. So it is connected with this particular instance, guys. My deployment group targets to that instance. So now I'm good to go. And here you can see deployment settings, deployment configuration. So one at a time, half at a time, all at once. If you're having a lot of instances running, guys, sorry. If you have a lot of instances running, guys, you can provide half at a time. And after, for example, you have 10 instances, first 5 instances will run. After that, the next 5 instances will start. So if you provide one at a time, if you have 10 instances, first the first instance will get the website, and then the next, and then the next. So it will go one by one. After that, if you give all at once, all of the instances which you have provided, which you have mentioned, will get the website at the same time. So right now I have only one instance, so it doesn't matter if I choose any of these. I'm going to go with all at once. And I'm not using any load balancing, so I'm going to cancel that. And I'm creating my deployment group. So you can see additional settings. Actually, I don't have any alarms or triggers. So I'm just going to go with creating my deployment group. So here you can see I have created my deployment group, and also there is an edit option. Sorry guys. So you can edit it or delete it, or you can create a deployment from here. But I'm not going to create a deployment from here, guys. I'm going to create a pipeline which will do that for me automatically. So if I create a deployment from here, every time I'll have to come to code deploy and click on create deployment. I'll have to click on that button, which will create a new deployment every time I change my GitHub code or code in any repository, guys. So instead of doing that, I can just create a pipeline which will do that automatically for me. So right now we've created an application and it has a deployment group, guys. So we are good with that. We've learned how to create a code deploy application and a deployment group, and also how to connect a EC2 instance with code deploy. So you can see it's still initializing because we've run some commands. So those commands will be running inside. Normally it doesn't take this much time. So right now it's running. So that's okay, guys. So next, code pipeline. So only using code pipeline, we're going to connect our GitHub and code deploy. So whenever there is a change in GitHub, so it will be available in our instance. So right now I already created a pipeline which succeeded, and right now I'm going to create a new pipeline for my new code deploy application. So first thing, I'll have to provide a name. I'm going to provide web server pipe. So it will create a role. So it needs a role. It needs a service role, and it will create it automatically. We don't need to create it again and again. And then advanced settings, just click on default location and default AWS management key. Basically, default location means the artifacts that is the data which will be stored while we run this. That data will be stored in this bucket. So the data will be stored in code line US East 1 and this number. So it will be stored in this S3 bucket, guys. So that is default location. If you have any other bucket where you want to store your artifacts, you can provide it in custom location. And then next, now you'll have to choose your source provider. My source provider is GitHub. So I'm choosing GitHub. And the first thing it asks is connect to GitHub. So I'll have to click on it. It takes me and it connected with my GitHub account because I have already logged in. And then repository, I'll have to choose the repository which I have to deploy. So my website is in this repository, which is also called website. So I'm just going to click on it. And branch, I have only one branch, that is master. And then next. So I don't need a build, guys. Actually, this is a website. There is nothing to be built. It is a HTML page. There is nothing to be built. So I don't need to worry about building. So I'm going to skip build stage. So now you will have to deploy. You will have to click on a deploy provider. So you can see over here, there are various deployment options. You can choose Amazon S3 and launch this website as a static website. You can choose Amazon ECS. You can choose Alexa skill sets. You can choose OpsWorks, even Elastic Beanstalk, and then cloud formations also. But right now, as we are doing code deploy and code pipeline, I'm going to choose code deploy because I already have a code deploy application. So I'm clicking on it. You'll have to choose the region where we created. My code deploy is in North Virginia, so I'm good to go. If I click on this, it should show all of the code deploy applications available in the region. You can see over here, web server Apache and a web server Apache 2. So mine is web server Apache 2. I'll have to choose that. And then deployment group. I have only one deployment group. I'm choosing it and moving on. Next. So this is again same thing. Basic stuff. It asks you to review it. You can review it if you want, or you can just move on. So right now, let me see my instance is running. So currently, if I see, so there is nothing available, guys. So let me run this pipeline. So let me create this pipeline. So if I create this pipeline, what do you expect will be available? So there will be an UI with two things, that is the source stage and the deploy stage. So congratulations, the pipeline web server pipe has been created. So you can see source. My source is GitHub and it is in progress. Once it gets succeeded, then it will move on to deploy stage. And you can see over here, you can edit this. You can add more stages, that is more source over here. You can add more deployment stages over here, but I'm not going to do anything. I'm just going to, because I have already created. So right now GitHub has been succeeded. My code has been properly taken. So it took merge branch master from this particular GitHub repository. So right now code deploy is running, guys. So I'll go to details. Let us check whether this succeeds or not. Only if this gets succeeded, then my website will be available. So you can see, oh, my code deploy got succeeded. So right now, if I go here, you can see all the events happened and also whether it is succeeded or not. If any of this was not succeeded, for example, if this gets failed, so you will see the error code over here, and if you click on that error code, it will take you to a log page which will show what error is available in your code. So you can use that to debug your application. So you can see over here, succeeded, before install succeeded. So before install took 13 seconds. Why? Because in my appspec YAML file, you can see before install will install dependencies, and also it will start the server. So as it already showed you in my scripts, so install dependencies will update my application once again, my instance once again. It will install Apache 2. It will also remove the HTML page, index.html page within this location, because I want to launch my application, guys. So then start server will start my Apache 2 service. So only if the Apache 2 service is started, then I'll be able to see my website. So right now, as my pipeline is succeeded, I should see my website, guys. If I go over here, if I choose my IP or my DNS name, if I go over here and hit. So right now you can see hello world to Intellipaat. This is the website which is currently running, guys. So I'll go and show over here index.html and you can see hello world to Intellipaat. So right now, as I told you, this pipeline should automatically execute whenever there is a change in the master branch. So because that is what we mentioned, whenever there is a change in the master branch in this repository, this pipeline should automatically run. So what I'm going to do is I'm going to change few values over here. So I'm going to just change to hello world and then I'm going to commit my changes to master branch. So once I commit my changes, if I go over here, it should automatically start. So it is currently in progress because I have changed my code. After some time, you can see there will be a commit ID, the commit, which commit it took will be present over here. Once it succeeds, that change will be implemented in my CodeDeploy agent. That is my EC2 instance automatically, guys. You can see source update index.html because this is my latest commit. This is the latest commit ID which it took. So you can see it's running, guys. So right now, hello world to Intellipaat. So now it changed to hello world. So this gets succeeded and this changed to hello world. And you saw there was no downtime over here. So this is why you use a DevOps pipeline. This is how you create a pipeline using CodeDeploy and your version control tool. So whenever there is a change happening in your version control tool, whenever there is a change happening here, so I'll just, okay. So whenever there is a change happening in your version control tool, that is this change when it is committed in the master branch, once it is committed in the master branch, this pipeline will automatically detect the change happened in your GitHub. It will take the latest commit made and it will run it once again. Once it succeeded, once it is properly run, then it provides the code to CodeDeploy. So CodeDeploy right now will download the contents of this particular GitHub repository. It will store in some location. We do not know where exactly it stores it. It stores it in some location. It will copy the index.html file into /var/www/html. So only if the index.html is available in that particular location, it will be taken by Apache 2 server, guys. So you can see this is how you create a code pipeline and using CodeDeploy and GitHub. So we've learned how to do this.
Intellipaat, basically the company that we work for, is an e-learning company, and we basically researched a lot of job descriptions, and what we came up with was this Cloud and DevOps Architect Masters course. Now in this, we have put down all the skills from all the job descriptions that we have got, for cloud related jobs. And also we are in touch with, since we are with a training company, all our instructors are basically working professionals. So we have got in touch with top cloud and DevOps professionals and asked them what are the relevant skills that you think are expected from a cloud engineer, person who is basically appearing for an interview. So based on what the feedback that we got from our instructors, based on the feedback we did from our research, we have come up with this course. And these are the things, these are the skills that we teach to a person when we take him basically on board with us in the Cloud and DevOps Architect Masters course.
So we are basically going to discuss the website architecture on cloud, which probably Netflix will have when they have, deployed their application. So let's get started. So let me just share my screen with you guys. Okay. So guys, what we will be doing today is something, on the lines of this. So what we are going to configure is we are going to have a URL, a URL like this, which every one of you will be able to go to, and you will be able to see the website that we will be deploying on the cloud. Okay. So for example, let's take the example of Netflix.com. You will see when you go to Netflix.com, you're automatically routed to the Netflix website, right? You do not know where that server is hosted. You do not know, about the nitty-gritties of how it is working. But all you know as a user is if I go to a particular URL, I can see the website on the browser. So similarly, we are also going to do, the same thing today. I told you the output, but I'm going to tell you what goes behind, making an architecture like that possible. What goes behind you going to a URL and then being able to access a server is something that we are going to discuss today. Okay. Now, if you talk about, the cloud architecture at a very high level overview, this is what we are going to accomplish today. So from the security point of view, all our web servers, all our databases that we are going to deploy today are going to exist in a network which cannot be accessed, by internet. So this network, this particular rectangle that you see over here, it will not be able to access by the internet. That is, you and me from our computer, we will not be able to access these servers. Okay. Then we are going to create a network which will be accessible by the internet, right? And that is where are going to have a component like load balancer, right? What does a load balancer do and everything, I'm going to explain you in a while, right? But this is the network architecture that we are going to deploy today. So we are going to have a part of a network which will not be accessed by the internet. We are going to have a part of the network which will be accessed by the internet, and then we are also going to have a component which is going to be a URL with which we will be able to access our servers. Okay. Now there is a very important thing to understand over here, and that thing to understand is how basically uh, you know uh, why security is important when you are dealing with applications which exist on the internet, right? For example, you can have all the security in the world for your application. It could be password encrypted, right? It could have key pair which can be attached to it, but some way or the other there's always a hack to access some machines, right? So how we as cloud architects, how we as application architects can ensure that something like hacking, something like phishing, something like somebody else taking over your application does not happen when you are dealing with the application which is available to the whole wide world, right? People like you and me, probably we will not be able to understand when something is password encrypted. Like for example, your laptop, if it's password encrypted, people like you and me cannot go ahead and get inside your system. But there are security researchers which exist out there. There are people who are technically so sound that they can actually hack into your system even if you have a password attached to it. Now when you think about it as an architecture's as an architect's mind, the first thing that you might want to solve is not giving access to your system to anybody on the internet. Okay, now what does that mean? So let's say if somebody is able to crack the password of a server, what if I don't give the access of the server to that person itself in the first place? So in that case, he will not have access to the server itself, and he will not be able to crack the password also. Okay. Now, how do you stop someone from accessing a particular computer or a server, right? What if you cut the internet connection to your computer? If someone is trying to hack your computer and that person does not have physical access to your computer, right? How will he hack it? If you cut the internet connection off of your server, how will someone go ahead and hack it? So that is my point over here. So to solve that, or to basically be relevant to what I just said, what we are going to do is all our applications, all the websites, servers that we are going to have, all the databases that we are going to have, we are basically going to deploy it in a network which is not going to have internet access. Okay. So now the next question that you might ask is, then how will we access a network which does not have internet access from outside, right? For example, if you go to netflix.com, you're able to see that website, right? Why are you able to see that website? Because you have, or that website, or the server which is having that website has internet access, correct? So how will we ensure that we do not have access to our servers, but at the same time, if somebody wants content from our servers, we are also able to deliver that on the internet? Is something that we are going to solve using this cloud architecture. Okay. So we are going to have a component which is going to be called as an AWS Elastic Load Balancer. Okay. Which is going to be in a network which can be accessed from the internet. And then we are going to have a URL which is going to point to this load balancer, which we are going to have deployed in a network which can be accessed by the internet. Okay, now you might have multiple questions right now. So before we move on to the next slide, I would like to address those questions. But if it is about how will we do it, I will be telling you in a while. But if anything is not clear with respect to what I've just told you, please let me know and I'll be answering all your queries. Any questions? Any questions, guys? So Ehsan is saying, so we have to get to both network and also to the server. So no, Ehsan, what I meant was that our website is going to exist on these orange icons that you see. These are nothing but servers that we are going to deploy today. All right. And these servers will be deployed in a network which is not going to have internet access. Okay, I will show you how that is possible using cloud. But these will be basically part of a network which will not have internet access, so that people from the outside are not able to access them, right? And at the same time, when we go to this URL, we would want to access these servers. And this URL will obviously be on the internet, right? So it might sound a little confusing because you guys do not have background on cloud right now, but it will be more clear as we move along. Okay, so everyone has an idea about what we have to accomplish today. So Devashish is saying customers use website by NAT gateway. No, Devashish, that is wrong conceptually what you are saying. In order to use the server, which is second rectangle, Asan is saying, yes. So this second rectangle is basically going to be a network which will not have internet access. So Ganesh is saying difference between cloud and server. So Ganesh, cloud is nothing but the company which has infrastructure on it, which has their own infrastructure, right? When I say infrastructure, they have millions of servers on their side. Now, what you can do is on cloud, you can deploy a server, right? So on cloud, when I say, so let's say AWS has millions of servers with them. Now you tell AWS that I want one server. So that server, you are basically using it on AWS cloud, right? So cloud is nothing but the company who owns millions of servers, right? And you as a customer, what you do is you go to their website and you request for one or two or 100 servers out of those million servers to use. Okay, so that should be the difference between cloud and server. So Venkata Raghunathan has a question: how safe are our projects in AWS? So it depends on Venkat how well you deploy your architecture. If you have a sound knowledge of what you're doing, then I don't think it should be a problem of how safe your projects are on AWS. Vignesh is saying, in general, how many VMs are required on real-time scenario to host a service or website like Netflix? Well, it doesn't depend on the number, Vignesh. For example, let's say you have a 16 GB machine, let's assume, and I have an 8 GB machine, and I'm talking about RAM. So the kind of applications or the kind of concurrent applications that you can run on your machines is obviously more than what I can run on your machine since you have a 16 GB machine, right? So how many VMs are required? It all depends on what is the kind of configuration that they're running on each servers of theirs. Okay. And it also depends on the kind of traffic, which is coming on to their server. So let's say their application that they run, for each customer, their application needs around 16 to 20 MB of RAM. So in that case, you can do the maths that let's say if they have an 8 GB machine, right, and they have let's say around 100,000 users concurrent at every time who are watching the Netflix platform, what are the kind of servers that they would need? Okay. Hari Krishna is saying if there's no network connection, then how we are going to access them? Exactly, Hari Krishna, you are bang on. So there is a way to do that, and I will be explaining it to you how you can do it. Nagaraju is saying not accessible server we are keeping in DMZ cloud or on-prem. So Nagaraju, everything is going to be on cloud. Nothing is going to be on our system or on premise, right? So that is something that we are going to go ahead with today. So Amit is saying when you say not accessible by network, it can still be accessed by LAN. Yes, Amit, it can be accessed within the network, but it will not be able to access from outside the network. That is something that we are going to discuss. So Ayush is saying, can I use this link from any device? Which link, Ayush? I'm not sure what you're referring to. Ashish is saying, do you mean all the servers in the second are in DMZ or inside firewalls? So Ashish, everything is going to be on the cloud, right? Everything is going to be inside firewall. So everything that you deploy on cloud has a firewall attached to it, right? But we are not going to control it via firewalls. We are basically going to convert it via, networks. So we're going to understand that how. So Ganesh is saying if they don't have internet connection, how they're going to work. So Ganesh, I'm going to show you in a little while. Okay, so Vijay is saying server down means Vijay, server down basically means that server is not working. That is what server down means. So Raju is saying thanks for the introduction. Can we start the lesson? It's 8 p.m. already. So Raju, as soon as the questions stop coming, I will be going to start the class. But it's important to clear everyone's doubt, right? I cannot just go ahead. Devashish is saying which databases big companies like Netflix use. So Devashish, let's hold on to these kind of questions. If there is anything that you want to understand from what I've just told you, please go ahead and ask. If not, we can just take these questions at the end of the session as well. Okay, so Anaga is saying if you want to access these servers from second rectangle, then how can we access? So Anaga, I'll be telling you that in a minute. Ujjwal is saying how can we auto scale? I'll be showing you Ujjwal that also in this session. Ujjwal is saying auto scale on CPU metrics or how we can use business or other metrics. So Ujjwal, it usually is the CPU metrics, but let's hold that question because not everybody will be able to connect to what you're saying. Okay, guys, so if there are no more questions, let's go ahead and start. So what I'll be doing is, first of all, let me go ahead and show you how a network like this is possible, where you do not have internet connection in one part of the network and you have internet connection in the other part of the network. Okay, so First of all, guys, for people who are completely new to cloud, let me give you a brief intro as to what you have to do. So first of all, you have to go to a website called aws.amazon.com. Okay. Now, what is this website? This website is basically a cloud provider. Okay. This AWS is a company which gives you the service of cloud. Okay. Now, what is cloud? Cloud is nothing but it's a company which rents out uh, systems. For example, right now you are watching this session probably on a laptop or a desktop or a mobile. Okay, so let's assume you're watching it on a laptop or desktop. Now that desktop or that laptop is owned by you, right? So now let's say tomorrow you want to launch a website. Now, your system configuration has around 16 GB of RAM, let's assume, and you have around i5 or i7 CPU. So the kind of website that you're launching will be used by a lot of people, obviously. Now, when people use that website, obviously, since it's hosted on your laptop CPU percentage will go up because your laptop now has to process a lot of requests. And soon your laptop will completely be used. It will have 100% CPU usage. It will have 100% RAM usage, right? And then you will have to buy another laptop so that you can distribute the traffic which is coming onto your laptops for hosting your website. Okay, but if you have to buy another laptop, that basically means you will have to invest around 60 to 70,000 rupees again, right? And then only you can divide the traffic among the two laptops that you will own. Now the problem over here is, let's say money is not a problem for you. Problem over here is that it will take a day or a two for your laptop to come. Second of all, you will have to manage everything, that you will have to have a 24/7 internet connection working at wherever you're working from, right? You will have to have 24/7 electricity so that your laptop is always charged, it's always working, your internet is also working if if electricity is required to the modem, right? So all these things you will have to ensure. And while you're managing all these things, you are actually not able to work on your application itself, right? So that is exactly why a cloud provider was introduced, or a cloud provider as a business was introduced. Now what a cloud provider does is, it says that if you don't have money to buy a server, or if you don't have money to buy a system, what you can do is, I have millions of systems with me. You can ask me for the configuration that you want, and I will give it to you. You don't have to buy it from me, you just have to pay me the rent for using it, right? And that is what the cloud platforms are. So cloud platforms, they give us systems to rent from, right? And you can rent them on a per hour basis, right? And the per hour basis price is as low as 3 or 4 rupees per hour. Okay, so that is how cheap servers are for you when you take it from cloud. Apart from that, cloud also gives you the guarantee of having 24/7 uptime, which basically means they will take care of their electricity needs, they will take care of your internet needs, they will take care of ensuring that the hardware is not getting any kind of fault. For example, let's say your laptop, from which you're hosting the website, right? Tomorrow some short circuit happens in your laptop, and suddenly your website is now down. So these kind of problems will not come if you're using cloud servers, because they guarantee that they will ensure that their hardware is up and running 24/7. So that is why companies use cloud. That is why companies are using cloud platforms for deploying their applications. Why? Because they do not want the headache of buying hardware, maintaining it, ensuring the infrastructure around it, right? So that is what cloud is. Now, having said that, what we are going to do today is, again, we are not going to use my laptop to host a website. I'm going to use a rented server from AWS where I'm going to deploy my website, and we are going to deploy an architecture like this. using the cloud resources, using resources which will be given to us on rent. Nothing is going to be owned by us. Okay. Now you would have a question over here. All right. So if you are saying that they will charge me on a per hour basis, so if I want to practice this on my system, will I be charged? If I want to go to AWS and I want to deploy, let's say some servers, will I be charged? So not at all. So whatever we will be doing today is not going to cost you at all. So AWS as a cloud platform, it gives you a very good deal for all its new customers. What it says is when you first sign up on AWS, you get access to a free usage that AWS grants you. So AWS says if you're launching a server which has 1 GB RAM and 1 core of CPU, then I'm not going to charge you for it. You can launch it for free, right? And we are today going to try and be under that free tier and deploy our application so that everyone who is there in this session can plan it, can actually run their application, can try it out, whatever you are trying in this session, and understand how cloud usually work without even getting charged for a single rupee. Okay. So this is an introduction to what cloud is, guys. So any questions that you have with respect to what is cloud, you can ask me right now. If not, let's go ahead and then I'll show you how you can use cloud to deploy servers. Any questions? All right. If there are no questions, let's move ahead. So first of all, you'll have to sign up on AWS. I'm going to skip that step. I'm pretty sure everyone knows how to sign up or create an account on a website. Do that. And when you do that, you can then sign up or you can just sign into your AWS management console. Okay, so let me just quickly log in. And when you have signed up on the cloud, this is how your dashboard is going to look like. This is how your dashboard is going to look like. These are all the different kind of services that AWS offers, and we are going to make use of some today to do what we have to do. All right, great. So now that we are on this management console, the next thing that I'm going to do is I'm going to choose a service. So when you want to deploy any kind of server, if you want a machine from AWS, the kind of service that you have to make use of is called Elastic Cloud Compute, right? So the short form of this is EC2. So you will have to make use of a service called EC2. So EC2, you can choose, you can go to all services under compute, you will find the EC2 service, just click over there. And this is the management console that you will get. Okay. Now my job is to deploy a server. I will do that. But first I need the network that we were talking about, since the past 15-20 minutes. We need the network ready first where we will be deploying our servers. Okay. So the EC2 service is for deploying your servers. Now for getting a network or deploying a network on cloud, there's again a service, and that service is called VPC, which is called Virtual Private Cloud. So we are going to type in VPC, and you will get isolated cloud resources kind of a service over here. Just click over it. And here you can deploy the kind of network that you want. Okay. So now let me, brief you about what we are going to do. So first of all, whenever you talk about networks, guys, networks, the word network can be a very big architecture, but networks have subparts to it as well, which are basically called subnets. So if I have let's say your office network, so you guys must be working in offices, you might be in colleges. So your office will have one network. Then in that one network, you will have, let's say, a network for the HR department. You will have a network separate for the developer department. Then you will have a separate network for, let's say, your leadership team. So everyone will have different access to the different part of the network, and every network will have its own access. Okay. So first of all, let's deploy the big network. Let's deploy a network for our whole application, right? And our whole application, I'm not restricting it to say that this whole network will have internet access or not. This is the overall network that we are deploying right now. And inside this network, then we are going to create subparts where we are going to, define the functions that each subpart can have. For example, some parts will have internet access, some parts will not have internet access. So that is something that we are going to do now. Okay. So first, let's go ahead and create a network. For example, let's create a network for your office. So let's call this network as Netflix. Okay. This is where all my resources are going to be. So I'm going to name it as Netflix, and let me give, an address. So everything that you deploy on a network has, an IP address. For example, right now, if you're accessing the internet, your computer has an IP address. Why? Because you are connected to a network which is called internet. Similarly, if you are connected to your office network, you also need to have a separate IP address which will make you recognize on that network. Okay. So now what we're going to specify in this IPv4 CIDR block is the range of IP addresses that I'm going to have. That is, let's say if your computer connects to my network, what is the kind of IP address which will be assigned to you? So let's say I specify over here that anyone who's trying to connect to this network will have an IP address which will look something like, let's say this. So this is the range that I'm specifying over here. So here in this range, so your IP address will always begin with 10.1, and then this number will change according to what your network configuration is. So this is the range that I'm specifying over here, and this range is where my application is going to be deployed in. Okay, so let's click on create. And what you have now done is you have created an office network, or you've created a network for your application. Okay. Now inside this network, I'm going to create subparts. Okay, because some resources I want to give internet access, and some resources I do not want to give internet access. So let's see how we can go ahead and specify that. Okay, so I have created a network called Netflix. Now inside this network, let's create some subparts. So for creating the subparts to a network, what you do is you create subnets. Okay, so I'm going to click on subnets. So let's create some subnets for my Netflix network. So I'll click on create subnet. Let's say what I'm creating right now is for a network which is going to have internet access. So let's call all the networks which will have internet access as public, and all the networks which will not have internet access as private. Okay, so let's call this network as public. And when you're deploying servers in AWS, you can deploy it in many data centers. Okay, so right now what we are dealing with is the Oregon region. So Oregon is basically a place in the US where AWS has many data centers. And how many data centers are there? There are almost 4 data centers that you can choose from. So let's create, a public subnet in 2A data center. Okay, and let's call this public subnet as 2A. And this subnet will be deployed obviously inside my main network, which is Netflix. So let me select that, right? And it is going to be deployed in the 2A data center. And let me specify the IP address range, which is going to lie obviously between this particular IP range that I specified earlier. This will be the IP range where I will have, my resources will be assigned the IP address from. Okay, so let me specify it as 10.1.1.0/24. So these numbers that you see /16, they basically denote a range. 20, if I specify something called as /24, that's a smaller part of a range which is /16, right? For example, if I specify, so just assume it like this: if I specify /16, there are going to be around 65,000 IP addresses that I can give using this range. Okay. Now, when I specify something as small as /24, I will have an IP range of around 256 to 256 servers. Okay, so this is what this number means. So more on this you can actually understand later, because if I try to explain you how IP addresses, how ranges work, it will take a little more time. But and it's easy to understand. You can just Google it out and you will understand it. But for your understanding, I'm telling you that this range is a part of this particular IP range. Okay, and this range we are assigning to our public 2A subnetwork. Okay, so let's create it. And mind you guys, I'm not defining the features of this network yet. I'm just defining that I'm creating these inside my main network. Okay, so I've just created public 2A, which is basically a part of my Netflix network, and it is deployed in the 2A data center. Right. Similarly, let me create one more subnetwork. Let me call it as public 2B. This is going to be a part of the 2B data center. It is going to also have internet access. It is going to be a part of my Netflix. What do you say? It will going to be a part of the Netflix network, right? And the range is going to be 10.1.2.0/24. Okay, let's go ahead and create it. Okay, so now what we have done is we have created two subparts in the data center 2A and in the data center 2B. Now let's go ahead and create private subnets which are not going to have internet access. So let's create them. So let's call this as private 2A. It's going to be part of my Netflix main network. It's going to be a part of the 2A availability zone. And this is going to basically have this IP range. Okay. Now, similarly, let me create a private 2B as well. /24, and let me go ahead and create it. Okay. So, okay, there's a small change over here that I'll have to do. So once you have deployed it, guys, you can verify if it has been deployed in the correct data center or not. For example, private 2A has been deployed in 2A data center. That is great. But when we talk about public 2B, it has again been deployed in 2A data center itself. So what I can do is I can delete it quickly and I can create public 2B once more. Okay, so let me create public 2B, and VPC is going to be my Netflix network. It's going to be part of my 2B network, and this is going to be 10.1.2.0/24. Okay, so now I have private 2A, I have private 2B, I have public 2A, I have public 2B deployed, and these should be now in the respective data centers. If I've named it 2A, it's in 2A. If I've named it 2B, it's in 2B. If it's in 2B, it's in 2B, and 2A is also there in the 2A data center. Great. So I have my network deployed. Now let me go ahead and define their functions. So what I've decided is my public subnets will have internet access and the private will not have internet access. Okay. So what I'm going to do is first I need internet connection to my network. So how can I give internet connection to my network to these public subnets? let me go ahead and tell you. So for example, if you need a Wi-Fi at your home, or if you need internet at your home, what do? You contact an internet service provider. They basically bring a modem to your home, and then that modem you connect to your Wi-Fi router, and by connecting to your Wi-Fi, you're able to use your internet, right? Similarly, if I want to give internet to my network, what I'll have to do is, first I will have to go ahead and request for something called as a internet gateway. So let me create an internet gateway. Let me call it as Netflix network internet gateway. Let me create it. Okay, so it has been created, and now you'll see it in a list. So I've created the internet gateway. Now I will attach it to my Netflix network. So here you can see, you can find something called as attached to VPC. Let's click over here. Let's select the VPC that we want to connect to, which is Netflix. Let's select it, and let's click on attach internet gateway. Okay, so my internet gateway is now attached to my network. Okay, but still the resources that are going to be in my network, they will not be able to access it. The reason for that is, whenever you deploy a resource in a cloud, it is not directly deployed in the main network that you created. It is always deployed in a sub part of the network, which is basically nothing but the subnets that you created. So the subnets that you have deployed, you have to configure them to connect to this internet gateway. Okay, now internet gateway is part of your network, but your subnets are not knowing about that internet network. So in a simpler way, if I were to tell you, you have Wi-Fi at your home, but you are not connected to your Wi-Fi. So your laptop does not know if it can connect to that Wi-Fi or not. Okay, so what I'll be doing now is I will go ahead to something called as route tables. So route tables basically specify which IP addresses can connect to a particular resource in the network and which IP addresses cannot. Okay, so let me go ahead and show you guys how the route table is basically going to be configured. So right now, there is one route table which is automatically created for your Netflix network. Let's call this route table as the internet route table. So whichever subnets or whichever part of the network are going to be connected to this route table will have internet access. And let's create a route table which is called non-internet route table. Right, and let's also deploy it in the Netflix network only. So this route table that I have created over here is going to have all the resources which do not have internet access. Okay, so to this non-internet route table, let's go ahead and attach the subnets which will not have internet, and to this internet route table, let's attach the subnets which are going to have internet. Okay, so first let's attach subnets to the internet route table. We'll click on subnet associations, and here, as you can see, there are no subnets attached to it as of now. We'll click on edit subnet associations, and we will attach all the public subnets where we need internet to this route table. Okay, so now the route table have been attached. The subnets have been attached to this route table. And now what you will do is you will specify a route to the internet gateway in this route table. And then what will happen is all the subnets which are connected to this route table will be able to see that internet gateway. Or in other words, whichever laptop is at your home will be able to connect to that Wi-Fi. Okay, so let's click on edit routes. Let's click on add a route. And here, let's say everyone in this network should be able to connect. So when you have to say everyone, you give a destination or IP address like this. Okay, so all the IP addresses which are there in this subnet should be able to connect to my internet gateway, which is this, right? And let's click on save routes. So now what have we done? Let's revise. So we connected two subnets to this route table, which basically I named them to be public subnets. And these public subnets, I have given a property to them that they can connect to the internet by using an internet gateway. Okay. Is everything clear till over here, guys? Any questions that you have? Okay. So Samiran is saying, are you using the free tier account? Yes, Samiran. So this is not a free tier account, Samiran, but all these settings that I'm doing right now, they're all going to be, a part of, what do you say? It is going to be a part of the free tier. So you don't have to worry about it. Whatever I'm doing, you can also do, and you will not be charged whatever you have to do. So Ehsan is saying, even if you are located in a different region in the world, is it still 10.1 IP address? So Ehsan, the network that I've deployed, it's basically deployed in the Oregon region. So this is the region that I'm working on right now. I'm working in the Oregon region. So in Oregon region, the network that I've created, no matter which data center that you connect to, if you are a part of my network, you'll always have 10.1 IP address. So Nagraj is saying public 2B is not assigned availability zone, so I did that. So Raju is saying clear explanation. Okay, great, Raju. Hari Krishna is saying, did the internet rule table got created the moment we had created an internet gateway? No. So Hari Krishna, whenever you create, a network, automatically a default route table is created for you, right? But you can go ahead and create more route tables which can be attached to your network as well. Okay. Ujjwal is saying, how can we connect the public and private subnets? Good, very good question, Ujjwal. I'll tell you in a little while. So Hari Krishna is saying how to know that which CIDA ranges we can use. So you can follow the same formula which I told you, Krishnan. When you specify a subnet, an IP range which is ending with /16, that means you are specifying a range of 65,000 IP addresses. Okay, but when you increase the number, so let's say if you give /24, that means now you have reduced your IP address range. So what I've done is I created an IP range which said 10.1.0.0, where 0 and 0 can be anything, right? And then what I did was, while I was creating the subnets, I replaced the third value in the IP address. So I specified 10.1, and instead of 0, I specified a digit. So that digit is now going to be fixed, and only the zeros can be changed, right? So with that, I specified what ranges are going to be a part of the other subnet that I've deployed. So you can, if this is confusing for you, you can use the same ranges that as I've did, and it should be not a problem for you. Okay. Ujjwal is asking, how can we communicate between the two subnets? Ujjwal, like I said, I'll be explaining in a little while. Sri Ganesh is saying how to put data in subnet. Ganesh, please be with me. I will be explaining in a little while. Ashish is saying, can we limit the number of IP addresses that can connect to public networks? Yes, Ashish, you can do that. So right now what I've done is I've specified 0.0.0/0, which means each and every IP address can connect to the internet. If you want only specific resources to be able to connect to the internet, what you can do is once you have deployed your resources, you will get their IP addresses. Just specify that IP address over here, and only that IP address will then be able to connect to the internet gateway. I hope that answers your question. So Hari Krishna is saying, are these CIDR ranges region specific? So whenever you deploy a network, Hari Krishnan, in AWS cloud, it is always specific to that particular region. So right now I have deployed it in the Oregon region, right? So all these data centers in Oregon region can basically, have resources which are going to be a part of the network that I have created. But let's say I go ahead and I choose, let's say, the Mumbai region, right? So Mumbai region will not be able to deploy a resource in this network.
I hope that answers your question. Okay, any other questions, guys? Can we move forward? Any other questions? Okay, if there are no questions, let's move ahead. I hope everyone is on the same page, guys. Anywhere, if you feel something is not clear, let me know. All right. So now that we have one network which is going to have internet with us, and the other network which is not going to have internet with us. Why this does not have any internet? Because I've not specified any connection to the internet gateway, and I will also show it to you in a little while. Now, a very good question which Ujjwal asked me was, let's say I have some resources, in the public subnet, okay, and I have some resources in the private subnet. So how can they communicate with each other? And if yes, how? So let me answer that question for you, Ujjwal. So when you create route tables, automatically, the route table that you have created, it has a rule in it which says all the IP address ranges of that network, they should be able to connect to the local resources which are there as part of that route table. Right? What that means is the internet route table, it has two subnets, right? It has public 2A and public 2B. So when I say that these IP addresses, if anyone is requesting anything from these IP address ranges, right, they should be able to connect to all the resources which are part of the subnets which are connected to this route table. In other words, anyone in this network, through this rule, what I'm defining is anyone in this Netflix network, if they have been assigned an IP address, they can interact with the resource which has been deployed in the public subnet. Okay. Similarly, if you have a look at my non-internet route table, here also I have defined that anyone who is a part of the Netflix network can connect to all the local resources which are going to be there in my private subnet. Okay. So this is what I have specified from my router. Does that answer your question, Ujjwal? Is it clear to Ujjwal and to everyone that all the resources that I'm going to deploy in the Netflix network, they will be able to communicate with each other because they are part of the same network. If I were to give you an example of this, let's say inside your home network, your laptop is connected to your Wi-Fi, right? And your mobile is also connected to your Wi-Fi. So if you want, your mobile and your laptop can communicate with each other even if your Wi-Fi router is not connected to the internet. Okay, if you remove the internet line from your Wi-Fi router, and you will not be able to use the internet, that is for sure. But what will now happen is, if you two devices are connected to the same Wi-Fi router, you will be able to talk to each other. So let's say on your system, you create a shared folder, and you try to access that shared folder from some other laptop which is connected to the same Wi-Fi. You will be able to interact with each other. Okay. Similarly, all the resources which are a part of this network, the Netflix network, they will be able to interact with each other. So Hare Krishna this means we can access public subnet from private subnet. So Hare Krishna, yes, the resources which are there in the public subnet, I can talk to them. I can do a two-way communication with them, right? But if I want to connect to the internet, I will not be able to do it from the private subnet. Okay. So Ujjwal is saying once repeat. Okay, Ujjwal. So I'm saying that in my route table, I have specified, or this rule is automatically specified, which says anyone who is connected to this IP range, they can talk to all the resources which are there, deployed in the subnets which are associated to your route table. For example, this is a non-internet route table, and this will have the private subnets or private networks connected to it.
So anyone from this IP range, where is this IP range? This IP range is nothing but your Netflix network IP range. Anyone from this IP range can connect to your resources which are a part of your private subnets and can talk to them. But only the resources which have these IP address will be able to talk. No other resource. Is this clear? Okay, guys, is this clear to everyone? Right? Are we all clear with what we have done as of now? So we have created a network. We have created some subparts of the network. Those subparts, some parts have internet access, some parts do not have internet access. But irrespective of the fact whether they have internet access or not, they all will be able to talk to each other. Is this clear with everyone? Okay, Hari says yes, he's clear. Thanks, Hari, for the kind words. Others, are we all clear with whatever I've just explained? Please be a little responsive on chat, guys. Otherwise, I will not understand if you guys are actually able to follow me or not. Is everyone clear? Ganesh says he's clear. Thanks, Ganesh. Ashish, yes. Aradhna, yes. Thank you, Aradhna. Nagaraju says local network. Do we need to create any firewall rules? Yes, Nagaraju. So there are some firewall rules that we can create, but we have not got to them as of now. Just let me know if whatever I've explained to you is clear. Praveen says yes. Okay, so thank you all for the confirmation. I can see a lot of you have said yes. Thank you all. Now what I'll be doing is, so I think I've not connected the subnets to my non-internet route table. Let me go ahead and connect. So I'll just click on actions. Sorry, I'll go to subnet associations of my non-internet and let me connect the private subnets to it. So private 2A and private 2B. Let me connect. Okay, so now I have the two route tables configured and I have my network configured in the fashion that I've just explained to you guys. And now one final setting that we will have to do is we will go to subnets. Now the resources which can talk to each other on the internet or which will basically have internet access, they will need a public IP address as well. If they don't have a public IP, be outside from the Netflix network will not be able to talk to them. Okay, so how do we configure our resources which are being deployed in the public subnet to have a public IP address? This is a small setting that you have to do. So you will be clicking on your public subnet. You will be going to actions. You will have to go to modify auto assign IP settings. Click on enable auto assign public IP for address and click on save. So now all the resources which are going to be deployed in public 2A are going to have a public IP address. Public IP address is basically an address which can be reached out from the internet. Okay. All the 10.1 IP address ranges that I specified earlier are basically going to be a part of the local network, that is the Netflix network. But when we talk about the internet is also a network, right? So internet also has its own IP addresses which are given to people when they want to connect to each other, right? So for example, if I am connected to the internet, if I go ahead and see what is my IP address, this is the IP address that I have, right? And this IP address is basically given to me by my internet service provider. So similarly, if I want to deploy a resource on AWS which is connected to the internet and to which I want to connect to, it should have this public IP address. Okay, so that is what we have configured, that all the resources in my public 2A will have a public IP address, and even in public 2B, I will specify that they can have a public IP address. Okay, great. So now all the resources that I'm going to deploy in public 2A and public 2B will have an IP address. And now we can simply go ahead and go to my service EC2, which we talked about earlier, which is going to rent me servers. I will go to that service. And let me deploy some servers now. So what I'll do is I'll click on running instances. And let's click on launch instance. Okay. So the moment you click on launch instance, now let's see what are the kind of options that we see on the screen. So now when you want to rent a server from cloud, the first thing that you need to decide is what is the kind of operating system that you want to run on that server. Okay. So let's say I want to run a Linux server. So let me select Ubuntu. I want to run the Ubuntu operating system on my server. Okay, so I'll select it. And now it will ask me what is the kind of processor, what is the kind of RAM do you want for your server. So here's a list that you can select for. Now, if you want your server to be a part of free tier, you can see this green highlighted text over here which says free tier eligible. Select that. It will give you 1 core CPU and will give you 1 GB of RAM. Okay, let's go ahead and click on next. Next thing it will ask you is what network do you want to deploy this resource in. So I want to deploy it in my Netflix network, right? And since this is going to be a public instance that I'm deploying, because first what I want to do is I want to configure my server that I'm deploying on AWS, and later I'll shift it to a private network where we will not be able to access it from the internet. Okay. So I am going to deploy it in the public subnet as of now. And what I'm going to do is rest, I'm going to leave everything at default. I'm going to click on next. Now it will ask me what is the kind of space or what is the hard drive space that I want for my server. So when you deploy a Linux server, it has minimal requirements. So a Linux server with 8 GB of RAM will work. 8 GB of storage space will work. So I'll just click on next again. And now this is the place where people were referring to, will it have any firewalls? So when you talk about firewalls, you basically are referring to security groups in AWS. Okay, so my instance will basically, or my servers will be governed by a firewall which is called security group, and I can create a firewall or I can choose an existing firewall as well. So when you create a new network, what happens is automatically there's a firewall which is created, which is basically called the default firewall. So it's called the default VPC security group. Okay. If you select that firewall, what are the kind of things that you can configure over here? Let's see. So first of all, what you can configure is the kind of traffic which is allowed in this firewall. Okay. So right now it says all traffic is allowed. Good. What protocol is allowed? All protocols are allowed. Okay, so we'll have to restrict this firewall in a little while. We'll do that. What port range is allowed? Any port from any traffic is allowed. Okay, and who can connect to this firewall? Only the people who are part of this security group can connect. So this we will have to change, since I want to connect to the server to configure it. So I will have to put my IP address over here in the source. We'll do that in a little while. But for now, this is the firewall that you all were referring to, right? And this is something that we are choosing as default over here. You can create it as well. If you create it, you will again get the same options, but you will have to configure them. Okay, so let's click on review and launch. And now you can just review all the settings that you have done. If everything looks good, you can just click on launch. Now, AWS as a security option, it does not give you a simple password-based authentication to your server. What it gives you is a file which you can use to connect to your server. Okay, so that file is basically called a private key file, which you will have to download from over here, right? So I have a file that I already created. It's called Mac Oregon. So I'm going to select that. I already have it on my system. If you don't have it, you're creating it for the first time, you will have to choose create a new key pair. Let me create it since we are doing it over here. Let's specify as Netflix demo.
This is the file that I will be using to authenticate to my servers. Once you specify the name, just click on download keep here. This will be downloaded to your system, and then later you can use it to connect to your server. Okay. Now I click on launch instances. And with this, my server has now just been launched. Okay. And I've launched it inside a public subnet. Okay. Now, before I move to the next screen, if there are any questions, I'll be very, obliged to answer them. So let me just check. Balu is saying EC2 is one way of launching VMs. Are there any other way we can launch a Linux instance using AWS services? So Balu, AWS is basically one service which gives you servers. It gives you general purpose servers to launch. But the other services that are there in AWS, they are very specific to the kind of server that they will give you. For example, we are going to make use of a database server today, right, later in this session. So if you want to create a database server, you can create it with EC2 as well, right? You can launch a Linux instance. On that, you can install your server and on your database, right? And then it becomes a database server. But what AWS also gives you the flexibility is that, let's say you do not want to do all this hard work. What you want is a database server itself. So AWS has specialized services in its management console, which basically gives you a server which is pre-configured. And that is about each and every service which is there in AWS, right? So the different kind of methods that you can launch servers, this is the most common method which is used. But let's say you do not want to configure your server yourself. You want AWS to configure it. Then there are different services in AWS which you can choose, which will give you specialized servers. It could be a database server, it could be a web server as well, it could be a serverless architecture as well. So everything is given to you, but it will be pre-configured by AWS. So those are the different kind of ways that you can launch servers. Hope that answers your question. Altaf is saying, are these steps what we have done will be charged? No, Altaf, these will not be charging you if you do this, whatever I've done so far. Okay, so Hari Krishnan is saying the default security group we selected, was it specific to the VPC we created, or is it default for all VPCs? So it is specific for the network that we created. That was Netflix, right? It is not common to all VPCs. Okay, so Nagaraju is saying the free tier you have created, how many days it's free? It's free for 1 year, Nagaraju. But let me give you a limit as well as to how this free tier operates. So every month you have 24 into 30, that is, you have 720 hours in a month, right? So what AWS tells you is you can run a server for 720 hours in a month for free. That means if you launch one server, if you run it for 30 days and you don't never stop it, you will not be charged for anything. But the game changes when you launch two servers. So if you launch two servers, then the number of hours for those servers are counted independently. So 1 hour of those two servers accounts to 2 hours of AWS counting with the 750 hours limit. In other words, if you launch one server in AWS, you can run it for 30 days. If you don't stop it, it will not charge you. If you run two servers in AWS, you can run it straight for 15 days without getting charged. Why 15 days? Because now for your 1 hour, there are two servers which are running, right? And those two servers have the different pricing which is running on them per hour, right? So I hope you understand what I'm trying to say. So if AWS tells you that you can run 750 hours worth of servers in a month, 720 hours worth of servers in a month, right? But it depends on how many servers you run. So if you run 3 servers, then that 15 days time will reduce to 7 days. So it's always a good idea to stop the servers once you're done with them. So if you stop a server, right, in that case, you will not be charged. Right now, the servers are running. So there's also an option to stop them. So the moment you're done with them, just stop it and you will not be charged. So that is how you can be under the free tier. Okay, so Ashish is saying we are able to connect to EC2 via key pair only or other options available. Ashish, by default, you can connect only via key pair, which we downloaded. There's no other option available. Okay. Are there any other questions, guys? Any other question that I can answer for you? Cool. If there are no more questions, let's move ahead. Okay, so now I've just launched a server, right? And this server is now a part of my public subnet, which means this has internet access. So let's see what all things we have available for this server. So let's call this as Ubuntu server. Okay, so this has a public IP address. Great, I can use this IP address to connect to this server, right? It has the private IP. Private IP is basically the IP which is given inside the network. So as you can see, the range is 10.1, which is exactly what we specified, right? It is a part of the 2A data center, which is good. The firewall attached to it is default. So we will have to change the default rules for this firewall. And others you can verify whatever you configured, exactly those configuration you can see for your server over here. Okay. Now what I'll be doing is I will be selecting the security group, which is the default security group. And let me change the settings over here. So first of all, I'll be changing the inbound rules. So the inbound rules of my firewall right now are these. So let me change this. So I click on edit inbound rules. And now, first of all, let me tell the server that only I can connect to it. So I will specify my IP. And as you can see, this is my IP address that has been specified. So only my system will be able to connect to this server. And right now you can see this is the public IP that has been attached to my firewall. Okay. So any kind of traffic from my IP address will be allowed to this server. Okay. So this is the setting that I'm specifying right now. I'll click on save rules. And this setting is done. Now, this will be changed later when we will be deploying our full stack application. But for now, this is the IP range that I have specified. Okay. Now I'll go back to my dashboard, go back to my server, select the server that I want to connect to. So this is the Ubuntu server. So you will notice I have some other servers, EC2 demo, which have been created over here. So this account is used by a lot of people. So you don't have to worry about the other servers which are being launched. Just select the server that you want to use. So in my case, it's Ubuntu. Now I'll be connecting to it. Okay. So this is the IP address that I'll be connecting from. Let's copy it. And now to connect to it, I will make use of my terminal. Okay. Now here is something that will be different, that can be different on your system. What is different on mine? So I am using a Mac operating system. So I have something called as a terminal, right? So this is a bash terminal that I'm going to use to connect to my server. Okay. Now, when you might be on a Linux, you might be on a Windows system. So in that case, if you want to connect to your server, you will have to basically make use of a software called Putty. Okay. So there's a software called Putty, which will basically make you to connect to your server, right? So what we basically make use of is the SSH protocol to connect to a Linux server. So this tool, the Putty tool, will help you connect to your server using the SSH protocol. So just click on the first link that you see. You can see it says you can download Putty over here. Just click over it. And here you can download, the Putty version. So you have to download the 64-bit version. In case your processor is 64-bit, if you have 32-bit architecture, then you will be selecting the 32-bit version. Okay. Once you download it, there is one more software that you have to download, and that is called Putty Gen. Okay. Download this as well on your system. Now, once you have Putty Gen and Putty downloaded, what you have to do is, you remember the key pair file that you got? This is the PEM file. This is the key pair that you got, and this is only for Windows system that I'm telling you right now, guys. So this PEM file is not compatible with your Putty software. Okay. So what you have to do is you have to convert this PEM file into PPK, and that can be done using this PuttyGen software that you will be downloading. Okay, so how you can use the PuttyGen software? Let me show you some screenshots. So this is how your software is going to look like. You don't have to enter any values in key comment key phrase. So what I'll do is, okay. So this is how your PuttyGen will look like when you open it for the first time. So what you have to do is you have to click on load. Okay, it will open a dialog box. Select the PEM file that you downloaded. Click on OK, and then click on save private key. Okay, what this will do is it will save a PPK format file on your system, and that is basically the file which you will be using now to connect to your server, right? So PEM files are compatible with Linux systems, but PEM files are not compatible with Windows systems when you're using the Putty software. So you have to convert it to PPK. Okay, so with that done, once you have the PPK file, next you will be opening your Putty software. So your Putty software will look something like this. Okay, this is the UI that you will get. So the IP address of your server will go over here in hostname. So this is my Ubuntu server. This IP address will go over here in this dialog box, the hostname. Okay. So once you put the IP address over here, next what you have to do is you have to click on SSH, right? And once you open SSH, you will find something called as auth under it. Click on auth, and then you will get a browse window over here. Okay, so if you click on SSH, you will click on auth, you will get a browse button over here. Click on this browse button, select the PPK file that you downloaded earlier, and then all you have to do is click on open. That's it. So once you click on open, you and I will be on the same user interface as what I'm going to show you as of now. Okay, so this is the only difference that is going to be there while I am doing this demo and while you will be doing this demo. So first step, you have to convert PEM to PPK using the PuttyGen software. Put the PPK file over here in browse section of SSH auth, and then put the IP address over here by going to session, click on session, put the IP address over here, and finally click on open, right? So now a terminal will open just like this, and then I'll tell you what has to be done from there. Okay, so now what I'll be doing is, let me pass in the command. So this is the command that you will be using when you're on Linux. Okay, so people who are there on Linux, first you have to go to the folder which will basically have your PEM file, then pass in this command. So ssh-i basically means the server that you want to connect to. Sorry, the PEM file that you want to connect to. This is the PEM file that I'll be using to connect. And then now people on Putty, you will see a dialog box which will ask you for login as. It will ask you for username. So if you have launched a Linux machine which has Ubuntu operating system, the username would be Ubuntu. Okay, Ubuntu @ now when you just have to specify Ubuntu, hit enter, you will be logged in. People on Linux, you have to specify username @ of IP address of your server, and then hit enter. Okay, so it will ask you whether you trust this server. This will also be the same for people who are going to work on Windows. You have to type on yes, hit enter, and Windows people will be able to connect then and there to the server. People on Linux will find this kind of a warning which will say unprotected private key file. Okay, so you will have to pass in a command sudo chmod 500, which are basically going to change the permissions of your file, right? And then just change it with 500, and this should do the trick. Now pass in the same command, and There you go. I have connected to my Ubuntu server on AWS. So people who will be doing it on Windows, you will also see the screen as you are seeing right now on my screen, right? And this is how you connect to a server which is deployed on AWS. Okay. So let me see if we have any questions. So Raju is saying, is it enough if we stop or it has to be terminated? So Raju, if you are working under the free tier, it is enough if you stop the server. You will not be charged. But people who are not under the free tier, you will be charged for the storage. So the hard disk that is there with your server, it is not deleted if you stop the server. So you will be charged for the hard disk. But people in the free tier, your hard disk space also has some limits, which will be basically available under the free tier. So if you're choosing the 8 GB option, I think if you stop even 2 or 3 servers and don't use them, you will not be charged anything. Okay. So Ganesh is saying, why are you using Ubuntu instead of Windows? So Ganesh, when you are working in production systems, right? When you are basically, even if we let's talk about, the session today, which is about deploying an application like Netflix. So all of them, they use Linux systems only when they are deploying applications. And the reason for that is Linux basically takes up a very few amount of resources for the whole operating system that it has to run. And when you compare it to Windows, Windows takes up a lot of resources to run. Okay, because Windows also has a lot of features. So to minimize the cost of the resources that you're using, every company prefers to launch their applications on Linux operating system. And that is exactly what we are also going to do. Surendra is saying, how can we connect to AWS server through local window or Linux command line? So this is exactly what I have done, Surendra, right now. So I have connected my local machine. This is my MacBook. So I have connected my MacBook to the AWS server using the terminal, right? So this terminal, what I have commands I have passed is going to be the same for any Linux operating system that you use out there. For Windows, I've told you you can use putty to connect to your server. So I hope that answers your question. So Ashish is saying, can we create different users that allow to connect to EC2? Yes, Ashish. So if you are sound with Linux, now that you're connected to this server, you can do anything with this server. It's now yours. If you want to create more users, you can go ahead and do that. You can do anything with this server now. It's up to you. Okay. Nagaraju is saying PEM file is a secure key or cloud server. Yes, Nagaraju. So the cloud server has given us a PEM file, which is basically a private key. So I don't need any password. If I have this file, only then I will be able to connect to my servers. If I don't have this file, I will not be able to connect to my servers. So it's basically a replacement for having a password, because password generally gets leaked, right? If you are typing in a password, somebody might see what you're typing on the keyboard and they might get to know what your password is. So instead of that, if you have a file through which you're connecting, and given the fact that you are not going to share this file with anyone, nobody else would be able to connect to your server. Okay, so that's why it's a little more secure when you compare it with having a password. Okay, so Mopai is saying security group inbound rules. Can you show once? Yes, Mopai, I'll show you in a little while. Okay, so let me show you the security group rules. Mopai, 1 second. So these are my rules, Mopai. So I have enabled every kind of connection from my MacBook to the server that I've just connected to. Okay, great. Now that we have connected to our server, what I'll do is I will basically make it a web server. And then once our website is ready, we will deploy it in my private subnet, which is not going to have any internet access. Okay. So when you want to create a web server, first thing that you have to do is anything that you want to install on a Linux machine. first you update that machine. Okay, so I'll just type in sudo apt get update. It'll take like a minute to update the machine, or even less than a minute. So it took 10 seconds to update the machine. Now what I'll be doing is, so this is the command that I passed to update the machine, sudo apt get update. Next thing that I'll be doing is I will be installing a web server. So sudo apt get install Apache 2. So this is a web server which is now getting installed. Okay, so I just choose yes.
Intellipaat, basically the company that we work for, is an e-learning company, and we basically researched a lot of job descriptions, and what we came up with was this Cloud and DevOps Architect Masters course. Now in this, we have put down all the skills from all the job descriptions that we have got, for cloud related jobs. And also we are in touch with, since we are with a training company, all our instructors are basically working professionals. So we have got in touch with top cloud and DevOps professionals and asked them what are the relevant skills that you think are expected from a cloud engineer, person who is basically appearing for an interview. So based on what the feedback that we got from our instructors, based on the feedback we did from our research, we have come up with this course. And these are the things, or these are the skills that we teach to a person when we take him basically on board with us in the Cloud and DevOps Architect Masters course.
Okay, so web server is now being installed. And after this, we'll do a very cool exercise, guys. So you will be able to see that if I go to the IP address of my server now, so I'll just type the IP address over here in the browser. You can see I can able to access this page in my browser. Okay, but let me do one thing. Let me give this IP address to you guys, and then you can tell me whether you are able to access them or not. So I'll just put this IP address in the chat. Let me know if you are able to access this IP address. Can everybody go to that IP address and tell me whether they're able to access it or not? So Raj says he's not able to access. Okay, Raj. Others? Harikrishnan cannot access. Okay. Okay. Can you guys tell me why you are not able to access it? Can anybody tell me? Okay, so Deepthi has given me a right answer. Others? Nagaraju also has given me the right answer. Raj also has given me the right answer. Okay, I think everybody is on the same page. So yes, guys, because in this firewall that is in the security group, I just specified that only my IP address can connect to it. Okay. Now, if I change that, let's see what happens. So I'll just go to the default security group, which is this. I'll change the inbound settings. And okay, I think I'm not in the right security group. 1 second. So let me change these inbound settings. And now let me allow anyone to connect. Now, can you guys confirm if you're able to access your machine or not? this web page or not in your browser. Okay, Hari can access, great. Nagaraju can access, Altaf can access, great. All right, awesome. So since everyone is able to access now, you can now understand how this firewall basically works. Okay. Okay, so now what I'm gonna do is, guys, I'm gonna basically go ahead and define a web page over here. So let me show you how we are going to go ahead and define our web pages. Okay, so what I'm gonna do is, this is the architecture that we are going to deploy now. So I will have a separate web page for streaming servers. One second. So I will have a separate web page for my video page, and I will have a separate web page for my home page. Now let me show you why we are going to do like this. So let me go ahead and open the website called netflix.com and just see what is the behavior. So if I go to netflix.com, I automatically go ahead and get routed to netflix.com/browse. Okay, and if I select the account that I want to use, it's still the URL over here. It's netflix.com/browse. So netflix.com/browse is taking me to the homepage of Netflix. I hope everybody is clear here. Okay, now what happens if I play a video? Okay, so let me play this series over here. So now what you can see is the URL changed to netflix.com/watch, and then you have some numbers over here, which probably would be the numbers for your video. Okay, so you have connected to netflix.com/watch. One second. You have connected to netflix.com/watch in order to get to this page where it is playing this video. Okay, now let me show you what happens when you play some other video. So I'll again click on back. Let me play some other video. So let me play, let's say, this Space Force. Can you still see? It's still netflix.com/watch, and then you have these numbers which are after this URL. So these numbers basically are referring to the video which is playing on this page, but this page is same all the time. The page is always netflix.com/watch, which is basically referring you to this video player. And then to this video player, what you're doing is you're providing this number, which is basically now going to play the video that you are launching over here. Let's see if we remove the track ID, what happens. Okay, so this is the number which is associated to the video that you are playing, right? And this is the page that you're going to. You're always going to netflix.com/watch. So if you go to netflix.com/watch, you open the video player, and to that video player you tell, okay, so this is the video that I want to play, and that is what is being played over here. So let's see if I just type in watch, what happens. Okay, you can see they have routed me to something else because they do not want me to just access the web the video player. So when I go to netflix.com/watch, they basically reroute me to some other URL. But you now understand the working of Netflix. What they do is, if you go to netflix.com/browse, they are routing you to the home page. And if you go to netflix.com/watch, and some video ID if you specify, it will take you to that video which is being played. Okay, so now let's see how we can mimic this architecture on our system. So what I'm going to do is, if I go to netflix.com/home, I will be taken to the home page. And if I go to netflix.com/stream, or let's make it watch. So if netflix.com/watch, if I go to, it will take me to the video player. Okay, so this is something that we are going to configure now, and this we are going to do using the AWS infrastructure. Okay, so before we move on, guys, let me see if we have any questions. Okay, so Ujjwal is saying streaming and web page can be assigned SSL certificate to ELB. Well, Ujjwal, you can do that, but SSL certificates will only improve the security. So my point is to basically show you how this particular mechanism is done on AWS. So I'll be showing you that. So he's saying I'm talking about production. So yes, on production you can do that. In production you can, all you have to do is on your server you should have an SSL certificate, which is going to enable HTTPS connections, right? But since if you might already know that SSL certificates are, you have to buy SSL certificates. You cannot just get them like that. So we are not going to make use of SSL certificates today, but we are going to mimic the mechanism that I just showed you. So Devashish is saying, do we need to attach load balancer to Route 53? Yes, Devashish, we are going to do that. Actually, I've not reached that step yet. I'm just still talking about, the URL based routing that we are going to accomplish in some time. Okay. Any other questions, guys? Is everyone clear as to what we have to do? Is everyone crystal clear as to what we will be doing right now? Any questions? Anaga says yes. Thank you, Anaga. Others? Radna says yes. Thank you, Radna. Others? No queries. Thanks, Hari Krishnan. Okay, thank you. All right. So if everybody is clear, let me go ahead and show you how this architecture is basically going to work. So first of all, let's create a home page. Let's create a page that we will be routed to if you go to /home. Okay, so what I'm going to do is, this is my web server where I'm able to go and see this page. Let's change this page to look like a home page. So what I'll do is, so once you have an Apache 2 server which is running, you can go ahead in this path /var/www/html, and this will have a page called index.html. Okay, so this index.html page, if you change this, your HTML will change over here. Okay, so for now, let me first delete this index.html page, and now let's create a new index.html page which says, let's say, welcome to home page. So I will create an HTML page which will, this is a very simple HTML code that I'm writing over here, which will says welcome to the home page. Okay, so this is what I've created, and if I refresh over here, you can see it says welcome to the home page. And even you guys, if you refresh, you will be able to see this particular web page which says welcome to the home page. Okay, so Surendra is saying how to minimize streaming. Surendra, I didn't get your question. If you can rephrase your question, I think I can understand what you're trying to ask. Okay, other guys, now if you go to the IP address that I gave you earlier, you should see this page, welcome to the home page. Now our web page, our web server, our home page is now ready, and now what I'll be doing is I'll be deploying this inside a private subnet. So let's see how we can do that. So for doing this, I will first go to my dashboard. and this is the server that I created. So let me create a copy of this server first, and then that copy I will deploy it in the private subnet that we created earlier. So I'll just select the server that I created, click on actions, then you have something called as image. So let's create an image. Image is nothing but it creates a copy of your server which can be deployed multiple times then. So we'll create an image. Let's call this image name as homepage, home, Netflix -home. Let's specify this, right? Let's click on create image. And now my image is getting created, okay? And that image will basically have this web server already deployed. Great. So now that it is happening, I think it will take a minute or two to create that image, and you can see that image in the under the image section in AMIS. So if you go to AMIS, you can see that a Netflix home image is being created, and it is in the pending state as of now. So I think if we refresh it a couple of times, you can see it will change to available. So let's wait. So while this is happening, let me explain you how the other things are going to work out. So as you must have noticed, right? So if you want to have a home page which is going to be separate, and if you want to have a watch page which is going to be separate, you will be dealing with two servers, right? And if you're dealing with two servers, you obviously will have two IP addresses, right? But as you can see from the behavior of the Netflix website, the URL always remains the same, right? Only the web page is changing. So how do we accomplish that? So we can accomplish it by having a common medium in the middle, which can connect to both my watch page and my home page. Okay, so this resource, which is the Elastic Load Balancer that we're going to deploy in a minute, is going to have a URL which is always going to be the same. And this load balancer we can configure to understand if the URL is /watch or /stream, it is always going to route my request to the streaming servers. Whereas if my request is /home, or let's say just slash, or just say no URL at all, in that case it will be routing my request to the home page. So this is possible using the Elastic Load Balancer, right? And this is something that we are going to go ahead and deploy now. Now I think we are ready to now understand how our architecture is going to be deployed. So now what I'm going to do is all my servers, they are going to be a part of my private subnet where I do not have internet access, right? But as we have known from the previous from our previous understanding, we know that everything within our Netflix network will be able to interact with each other. Okay, so in my Netflix network, I have a public subnet, I have a private subnet. So private subnet does not have internet access. Public subnet has internet access. So in my public subnet, I'm going to deploy my load balancer, right? In my private subnet, I'm going to deploy all my servers, right? And these servers can only be accessed by the load balancer and nothing else. Okay, nobody else will be able to connect to these servers directly. Only through my load balancer, they will be able to access my servers. And this is a very good architectural practice when we talk about having security for our servers. Why? Because you can control which protocols can you interact with in your load balancer. For example, let's say a hacker wants to go ahead and make use of servers. They want to pass some commands, as I did on this terminal. Okay, so if you want your load balancer to restrict that, your load balancer will only allow HTTP traffic. What is HTTP traffic? HTTP traffic is the traffic that you get from your web browser. So only the web browser's traffic will be enabled through your load balancer. If somebody is trying to pass some command, if somebody is trying to connect through some other protocol, it will not be allowed. Okay. And even in that case, your load balancer will only allow some URLs. So only if you type in /home, you will be allowed. If you are typing something else, you will not be routed to my server. That again is a very good security aspect, that if your URL is pointing to netflix.com/home, only then you will be reaching my home server to access that content. You cannot access my content and from any other medium from that particular server. Okay, so this is how you can restrict hackers or restrict attackers from accessing your server, and it's a very good architectural practice to have your architectures deployed like this. Okay, so let me see if we have any questions with respect to whatever I've just explained. So Ehsan is saying, why did you have to create an AMI? So Ehsan, if I did not create an AMI, I will have to go inside, the server which will be there in the private subnet to configure it to have, the required softwares installed and the other software configurations. But I cannot do that obviously because no internet access is given to the resources which are there in the private subnet. So what I'm doing is I'm creating an image which has every bit of the software installed in it, and then I will just deploy that image inside the private subnet. In that case, I do not have to connect to it directly. Okay, so that is why I'm doing it. So Ujjwal is saying, how do we manage the private subnet server? So Ujjwal, we don't have to manage them, right? Because the reason being, we have created an image and we'll be directly deploying it over there now. So we don't have to manage them from our system. But one thing that we can do is something called as a bastion host. So a bastion host is might sound a very big name, but all a bastion host is that it is a proxy server. What is a proxy server? If I want to connect to instances in the private subnet, can somebody tell me how can I access it? Can somebody tell me if I have to connect to a server from my local system to this server which is there in this network, how can I connect to it? Given I have access to my AWS management console, given I can deploy as many resources that I want, is there a way that I can connect to this server for passing a command? Can anybody tell me how we can do that? Okay, so Ganesh is saying which condition the Elastic Load Balancer will allow access to private server. I will show you in a little while, Ganesh. Prasad is saying, are we not using S3 for storing the video or media files? So Prasad, we can do that, but right now we are focusing more on the architecture. So we're not getting into the implementation details. So I hope that answers your question. Ujjwal is saying, is Bastion host the best solution for connecting to your private servers, Ujjwal? Yes. So Devashish is saying, what we put in private subnet exactly, and what is the another port you were telling that restrict to access? So in a private subnet, whatever you see in this rectangle, Devashish, we'll be deploying that. So we will be deploying, the servers which will our home page and our streaming page inside our private subnet, right? Our home page and our streaming page will then be able to access it uh, through the load balancer which will be deployed in the public subnet. So this is the architecture that I explained you. Altaf is saying, I have him having the below issue. If you can suggest, it will be great. Otherwise, please proceed. So it says no. So Altaf is getting an error. Not supported authentication methods available. So Altaf, you have not selected the PPK file in the SSH option of your auth. So select that, then put in the IP address, and then click on open. That should resolve your doubt. Okay. Ujjwal is saying Git or AWS CLI. Okay. So Hari is saying, please repeat the question. I'll do that, Hari. Nagaraju is saying using proxy to connect. Okay. Nagaraju, you're right. Proxy to connect, but how will we do that architecture? How will we create that architecture of connecting it, to the servers that they're deployed in a private subnet? Is something that I'm trying to ask. Mopa is saying allowing a route in the route table, we can connect to the private server. There is an easy way, Mopa, also. So just think on the lines of how your load balancer is accessing your are accessing your private servers. Just think on those lines and you will be able to crack the answer. Ramesh is saying NAT gateway, no Ramesh, not NAT gateway. Okay, so can anybody guess it? Okay, so Parveen is saying first connect public network server, from that server connect to private network. Okay, so Parveen has given me the right answer. So what I'll have to do, guys, is this rectangle over here is my public subnet, right? So what I'll do is I'll deploy a server over here, which will have internet access. I will connect to this server from my system using SSH. Now, once I'm inside this server obviously can access every resource which is a part of the Netflix network, right? So using this server, I will then SSH into the private servers that I have in the private subnet. Is everyone clear with what I've just told you? Any doubts in what I've told you? I will deploy a EC2 server over here in the public subnet. That subnet will have, that EC2 server will have access to all the servers which are there in the network, right? Even if it's private or public. So then what I will do is once I'm inside this server which is there in the public subnet, I will SSH to the server which is there in the private subnet. Does that make sense? Is everyone clear? So Altaf says yes. Okay. Hari says yes. Ganesh says no. Okay, Ganesh. So you can tell me what is not clear. I'll be happy to answer. Surendra says yes. Raj says yes. Anaga, Ramesh. Thank you for the confirmation, guys. So Ganesh, let me repeat it for you. So this rectangle over here is my public subnet. Is this clear? Ujjwal and Amit are also saying repeat. I'm going to repeat it, guys, for you. So this rectangle is my public subnet. Is this clear to you? Okay. Okay, great. So Devashish is saying, but why we need to do this? Public will be exposed to hacker. So Devashish, we are going to do this just to configure. So somebody asked a question. If I have to configure my servers, if I have to do some maintenance on my private servers, how will I do it? So I will deploy a temporary server in the public network. I will connect to it, and through that I will connect to my private server. So this is just for maintenance, right? And only for that reason I will be deploying that server, nothing else. So Nagaraju says someone hacked Netflix public server, they may get access to the other server. You're right, Nagaraju. But like I said, it is only temporary. When I have to do some maintenance on my private servers, I'll be doing this. Other than that, I'll not be doing it. Okay. All right. So, okay, let me get back to what I was explaining. So this is my public subnet. Everyone understands this. And this rectangle is my private subnet. Okay. So this rectangle has internet access. This rectangle does not have internet access. This is the rectangle where my private servers are going to be deployed. And this is the rectangle where I'm going to have a public server deployed, which in this case, I've also deployed a Ubuntu server. So I've deployed it inside a public subnet. Okay. Now, do you guys agree that whatever I'm going to deploy in this rectangle or this subnet is going to have access to resources which will be deployed in this rectangle, which is the private subnet? Does everyone agree with that? Okay, Nagaraju says yes, Hari says yes. Ganesh, do you agree with that? Ujjwal, Amit? Okay, everyone has said yes. Amit, I'm waiting for you. Okay, Amit says not sure. So, Amit, as I said earlier, we are inside one network, and the Netflix network that we created, right? That is the big network that we created. Inside that big network, we created small networks which were public and private. Public had internet access, private did not have internet access. Okay, so all these resources which are a part of the big network, which is Netflix, all the resources can talk to each other. Is that correct or not? Do you agree with that, Amit, or not? Okay, Amit says yes. All right. So now because they can talk to each other, now imagine this rectangle is my private subnet. Okay. And this rectangle is my public subnet. And what is the difference that I told you between the two is the public subnet has internet access. The private subnet, it does not have internet access. Okay. So if I connect to a server which is there in my public subnet, right? Because I'll be able to connect to it. Why? Because it has internet access. If I connect to a server in the public subnet, I can then connect my private server through this public server, right? If I connect to this Ubuntu server on my terminal like this, and then in this server which is there in the public subnet, if I enter the SSH command again, and I enter the IP address this time, the private IP address of the private server which is deployed in the private subnet, will I be not be able to connect to it? Okay, so Amit says yes. So Amit, that is exactly what I'm trying to tell. If I have a private machine which is deployed in this private subnet, if I have to connect it from my machine, what I'll be doing is I'll be launching a machine in the public subnet, and through that I will be connecting to it. Okay, it'll be more clear to you when I do it in the terminal. So Devashish is saying, do you mean to say in real-time scenario we do not have any public machine? They use only private machines? Yes, Devashish. So every big MNC, right, which are dealing with uh, a product which is accessed by millions of people, every day, right? And if they are following the right security best practices, none of their servers will be exposed on the internet. It will always be inside a private subnet. So that is what I am trying to tell you. Okay. All right. So coming back, now we have our homepage image ready, right? Now let's create an image for our streaming server as well. So what I'll do is, again, let's create one more image from this server itself. Let's again go back to this directory. Let's change the index.html, and this time let's say welcome to the streaming page. Save it. Okay, and now if you go to this IP address, you will see it will now say welcome to the streaming page. Okay, and now let's create an image out of this as well. So again, we'll go to EC2. So in our Ubuntu image, we'll go to image, we'll go to create image, and let's call this image name as Netflix stream. Okay, so now the image will be created for that as well. Now what I'll do is I will go ahead and launch my home page in my private subnet. Let's see how we can do that. So I click on launch instance and I will choose my AMIs over here. I'll not choose any operating system now. I'll just choose my AMIs. And now I will choose the Netflix home image, which I created earlier. Let's select it. I want to launch it in the free tier server. Everything is going to be the same that we did earlier. Just that now I will be selecting a private subnet which I'll be deploying it in. So I'll be choosing the private 2A network. Let's deploy it over here. And this is our home page that we're deploying. Security group, we will select again the default security group. And we're going to restrict it. Don't worry about that. We're going to restrict that security group. And let's choose the same key pair that we used earlier, Netflix demo. Acknowledge that we have it and click on launch instances. So this is now getting launched in US West 2A. It's going to be launched in the 2A data center. This is basically now called Netflix-home. This is the home server that you have launched, home page that you have launched, and it will take a little while. And as you can see, it is now running. Now, if you have a look at the settings of this server, you will see that it will not have a public IP address, right? Why? Because we deployed it inside a private network, right? But it will have a private IP address. But this private IP address can only be reached out within the network. It cannot be reached out from outside of the network. Remember this, okay? So this is the IP address that we will be connecting through from our public instance, which is nothing but this instance that we connected to earlier. All right. Okay. So we have launched our home page. Now let's go back. Let's see if our streaming page is ready. So even streaming page is now ready. Let's launch this as well. So I'll just select the streaming image, click on action, click on launch. This is another way of launching it, right? This is the server that I want to launch. I want to launch it under the free tier. It will be deployed in the Netflix network. And this time I'm going to deploy it in private 2B data center. Okay. Everything else going to be the same. Security group, I'll select the default one. Click on review and launch it. Select the same key pair that I selected earlier, acknowledge that I have it, click on launch instances. And with this, my streaming page has also been launched. Okay, great. So now I have two servers which are now deployed inside private subnets. And as you can see, I do not have a public IP address over here. Okay, and hence I will not be able to access them from the internet. These are not having any internet access, and I will prove it to you in a little while. Okay, so I have the home page which is now running. I have the stream page which is now running. I have, let's name it as proxy server. So I have a proxy server which is running in the public subnet, which has internet. Now what I'll do is, using this proxy server, I will be connecting to this home page and the stream page server. So let's see how we can do that. So first we need to copy the PEM file that we have on this proxy server. So let's copy it. So the way you can copy it is, use a command called SCP, which is called secure copy. So first you will have to authenticate yourself using, the proxy server's PEM file. Then you will have to specify the file that you want to copy. So the file name is again this PEM file I want to copy, right? Where do I want to copy it? I want to copy it on the proxy server, which is this IP address. and I want to copy it in this particular file location, which is /home/Ubuntu. Hit enter. Since I specified sudo, it is asking me for my computer's password. Specified that. And now the file has been copied successfully. So now if I SSH into my server again, you can see that the file has been copied, netflix-demo.pem. It has been copied onto my proxy server or my public server that I launched earlier. Okay. Now people on Windows, if you want to do the same, what you can do is follow a simpler method. You can download a software called FileZilla. Okay. So FileZilla helps you to copy files from your local system to your specified server, right? So you can use this software to connect to your server and copy files. How you can use it, I will request you to just follow a small tutorial on YouTube and you will understand how to use this tool. It's very simple. Okay, so let me see if I have some questions. So Nagaraju says static PAT need to configure this for private servers. Static private address, is that what you mean by PAT? Nagaraju, can you explain me what PAT means? But I don't need to configure any static addresses for my private servers, Nagaraju, because my private servers, the private IP that they get, they're already static. They are never unassigned from those servers if, let's say, I'm not using them. If let's say I'm not detaching them manually. Even if I stop the server, if I restart the server, it will always going to be the same. Okay. Kirti saying any feedback link, sir. So Kirti, I did not understand. You mean the feedback for this session? For the feedback for this session will be available once this webinar is ended. You can use it to give feedback. Raju saying you created AMI from public. Will it bring the enable auto IP feature to private instance? No, Raj, it will not bring it because that feature is basically enabled on AWS. On AWS configuration. It is not enabled on the server's configuration. So as you might understand, a public IP address is an external resource to the server, right? So your server will not get the public IP address. Don't worry about that. So Harikishan is saying, is this similar in Windows as well? So Harikishan, like I said, you can use the FileZilla software for copying the files. Devashish is saying we can use FileZilla to copy. Yes, Devashish. Nagaraj is saying port address translations. So port address translations will not be required, Nagaraju, when you want to connect, and it will be more clear to you as we progress in doing this hands-on. Anaga is saying, can you please repeat the step in short once again? So Anaga, what I've done is I use the SCP command. If I can show you. Okay, so I use this SCP command to copy the PEM file from my system to the remote system that I have on AWS. So this is what I've done. And once I did that, I can see that it's now available to me. And now I can use this file to connect to my private servers. This is what I've done. Ashish is saying, sorry to ask, what does AMI mean? AMI basically means, Ashish, Amazon Machine Image. So Amazon Machine Image basically means the machine that you launched. If you want to create a copy of it, you create an AMI for it. That is what AMI is. So Mupai is saying Ubuntu server is not able to connect to .ppk file in North Virginia region. So Mupa, what is the exact error you are getting? If you can tell me that, I can help you further. So if you are using a Linux instance, I do not understand what you mean by I tried with a Linux instance instead. So if you did not launch Ubuntu, in that case, your username will be ec2-user. It will not be Ubuntu. So Altaf is saying, how can we install software in private subnet instances? So Altaf, that's why we created the image. So our image already had the softwares installed, right? So we do not have to install it in the private instances again. Okay, that's why we created the image and then we launched it inside the private subnet. Okay, great. So now that I have the PEM file on my server, guys, the next thing that I will be doing is I'll be connecting to my private server. Now, where is my private server? My private server is this. Let's connect to a Netflix home server. Okay. So Netflix home server, this is the IP address, the private IP address for my Netflix home server. Let's try to connect to it. So I will be typing in SSH-I and then the PEM file, the username, and then the private IP address. So as you can see, earlier my IP was 10.1.1216. Now it has changed to 10.1.3.193. And that is the IP address of my Netflix home server. As you can see, the private IP address of my Netflix home server is 10.1.3.193. So this basically means I have successfully connected to my private instance. Now, for some of you who still have a doubt whether, if I pass this on my local machine, what will happen? So right now I'm inside the AWS server, right? But let's say, this is the terminal for my local machine. If I pass the same command over here, okay, first let me go to the folder which has the pen file. Okay, so if I pass in the same command over here, you will be able to see it will not recognize what this address is. Can you see it's not connecting? It's not doing anything. Why? Because it does not know what this IP address means. Why? Because my local machine is not a part of the Netflix network, which is there on AWS, right? But this machine is, and that's why when I passed this command, it was able to connect to this Netflix home server. Now, what I'll do is I'll just check if the web server is running. Yes, so it is active, it is running. That means if I curl, so this is something that I'm just doing for my checking, guys. If you don't understand, it's fine. Okay, so that means my Apache server is working on Netflix home, which is great. So let me just exit. So I've exited, and now I'm back to my public server. You can see the the IP address changed. And now let me log into my Netflix streaming server as well. So I'll just change this IP address to my stream server. So my Netflix stream server has the IP address as 4.167. Let's specify that. So as you can see, I have connected to my Netflix stream server now. And if you check if the web server is running over here, yes, it is running over here as well. Great. So both my servers are running fine, and I've just showed you how to, if some maintenance is required, how to do maintenance on your private machines, right? Now what I can do is, once maintenance is done, I can just delete this proxy server, and then I'll not be giving any access to my private machines. One thing that I forgot to show you was, let's say this is my public machine that I've launched on right now, right? This is my proxy machine that I've connected to, right? This has internet connection. How do we know that? First of all, we are able to SSH it from my local machine. At the same time, if I type in curl google.com, you can see that there is a response that I get, right? But if I, let's say, go to my private machine, right? And if I do a curl google.com over here, you can see that I'm not getting any response over here. Why? Because this machine does not have internet access. Okay, and this proves that. Great. Let me exit. And now that our web servers are ready, they are ready inside, a private subnet. Let's configure our load balancers to connect to this machine. Okay. Meanwhile, let me see if we have any questions. So Sri Ganesh is saying how long this session will continue. So Sri Ganesh, it will take 15 more minutes and then we will be done. Ehsan is saying, I'm confused about proxy servers. Did we create this server? So Ehsan, this proxy server is nothing but the same server that I deployed in the public subnet where I created the image, right? So I'm not creating one more server. I'm just using this as a proxy server now because that is also a part of the same network, which is the public subnet, right? So essentially what you just need is a machine in a public subnet that you can connect to, and through that you can connect to your private machines. So there's nothing to be confused about, but if you still are, let me know. I can explain you further. Okay. So Devashish is saying how people connect to private network if we don't have public machine. Devashish, there is no way that you can connect to a private machine. And that is why it is a good architectural practice to do it. Any other questions, guys? Should we proceed? Okay, great. So now what I'll do is, so Devashish is saying only we use website page. So Devashish, nobody else will be able to use this website page also. It will be through the load balancer that people will be accessing it. So let me go ahead and show you how that architecture is, and then we can discuss if anything is not clear. Okay, so now what I'll do is, let's create a load balancer. So I'll just scroll on my EC2 console, and I will be able to see something called as load balancers over here. Let's click over it. So let's click on create a load balancer. And I will be creating an application load balancer. So application load balancer basically works on the application layer, and it basically helps us to do path-based routing, that which is something that we are trying to accomplish, which is if I go to netflix.com/stream, I should be going to my stream server. If I go to /home, I should be going to my home server. So we'll be creating an application load balancer. Let's name it as Netflix-demo. This is going to be an internet facing load balancer, right? And the protocol that we are going to use is HTTP protocol. Okay, so here, as you can see, this is very important. So the only protocol that this load balancer is going to allow is HTTP protocol, nothing else. All right. Which VPC will this load balancer be a part of? It will be a part of the Netflix VPC, and this has to connect to 2A and 2B servers, private servers. So if they have to connect to private servers in 2A and 2B, this load balancer has to be deployed in public 2A and public 2B. Only then it will be part of the network, and then it will be able to connect to your machines. Okay, so what is the configuration that we did here? So you have configured your load balancer to connect to your private machines only using the HTTP protocol, nothing else. Okay, let's configure the firewall for this. So firewall, we'll be using the default firewall only, will not be making any changes. Let's specify routing now. So for routing, you will have to specify which servers to connect to, right? So right now, let's go ahead and specify a target group. Let's name it as public-server. And now let's go ahead and specify the public server IP address. So the way I can do that is by specifying the the servers that I'll be able to connect to, right? So what I'll do is target group is nothing but the set of servers that you can connect to, right? So let's specify the name of this to be, let's say this is the home page server, right? Let's click on next. And now what I can do is I can select the home page that I want to connect to. So this is the home page that I want to connect to. And let's click on next again. So this is the target group that I've just created for my home server. I'll be creating one more target group. Don't worry about that. So let me first create it and then I'll explain you what I've just done. So let's create this load balancer now. Okay, so load balancer is now created. Next thing that we will be doing is we will be creating one more target group. So we have created one target group for homepage server. Let's create one for streaming server. Okay, this streaming server will also be a part of the Netflix VPC. And now let's go ahead and click on create. Okay, so now my target group has been created. So I have a homepage server and now I have a streaming server as well that I would want to connect to. And in this, so homepage server should have the homepage server connected to it. So it is not connected. Let's connect the homepage server over here, which is Netflix home server. Let's register it to this target group, save it. And similarly, in my streaming server target group, let's connect our stream server, register it, and click on save. Okay, so both of these now have the targets attached to them. And now what we can do is now we will be specifying the rules for our load balancer. So let's go back to our load balancer. And now what I can do is so now I have to specify this routing rule, which is if I go to /stream, then it should connect to the target group of my streaming server. And if I go to /home, it should connect to the servers of my home server, the server of my home page. Okay, so let's see how we can configure that. Okay, so you will have to go to listener and then you will have to specify rules. So let's go ahead and edit these rules over here. Okay, so right now what is happening is anything which is going to this server, it will be routed to the home page server. Okay, so let's add a route over here. Let's click on insert rule and add a condition. So we'll be adding a condition for a path, and the path will be if it goes to /stream or let's say /watch, right? It should then forward this request to the streaming server. All right. So if the path is /watch, the request will be forwarded to the streaming server. Okay. If there is no path specified, it will be routed to my homepage server. If there is, let me specify one more thing. So let me first save it, right? And let us add one more rule. So if the path is /home, in that case, it should forward the request to my homepage server. And now let's click on save. Okay, so now I have configured my load balancer to forward the request to my homepage server when this path is specified. So let's check if this is working or not. Okay, so I'll just go back. This is my load balancer that I created, right? So this is the URL that is there for my load balancer. Let's copy it. Let's paste it on my browser. So as you can see, I'm being routed to my home page. Now I will right now get an error if I go to /watch. It says requested URL was not found in this server, and the reason for that is that whenever you want to go to a particular path, what you'll have to do is you will have to specify a folder in your server. Okay, I will clear it to you in a little while. So let me first make it work, and then I'll answer all your queries. Give me 1 second. So if I go to /stream server, which is this IP address, I have to go inside this server. I have to create a directory called watch. And inside this directory, I will have to copy the index.html. Okay. And now you can see if I go to my load balancer /watch. 1 second. Okay, so this is my streaming server. All right. And inside my streaming server, if I go to watch, I have my index.html. And let me verify my settings of load balancer. So if I go to listeners and if I go to the rules, so if /home is there, it'll go to homepage server. If /watch is there, it'll go to streaming server. And let me verify streaming server's IP address. Okay, streaming server target is Netflix stream and it is healthy. Okay, so now if somebody is going to my streaming server and the path is /watch, it says it's 100%. Okay, we'll verify that in a moment, guys. Let's see what the problem is over here. So I think if we go to rules and try to edit these rules. Okay, let's try and see if this works for us. So if I'm going to /watch, yes. So the star was missing over here. So now if I'm going to my load balancer /watch, I'm going to the streaming page. And similarly, what I'll also have to do is, let me exit and let me go to my home server as well. Okay, so here as well, I will have to add a home directory. Let me quickly do that. Okay, and now if I go to my load balancer, let's say I'm going to /home, you can see I'm being routed to the welcome to the home page. And if I'm just going to the URL, then also I'm being routed to welcome to the home page. Okay, now I know that you guys will have a lot of questions. Let me pick it one by one and then I'll be answering it. Okay, Kishore says a lot of kind words. Thank you, Kishore. Ashish is saying, how do we deploy applications to private networks in future? So, Ashish, for deploying application to private networks, it's going to be the same way that I showed you. We created a private subnet, right? And in that private subnet, we deployed some resources, right? So this is how you do it. Now, if you want to configure them, you will have to have a proxy server that will be deploying in a public subnet, which will then be able to talk to your private subnet. But that will be the way. Okay, so Sri Ganesh is saying, what is the function of load balancer? Sri Ganesh, load balancer basically is one single endpoint through which you can interact with a lot of servers. So that is what the function of load balancer is. Murthy is saying, any plans to show registered users versus new user accessing websites through ELB? Murthy, that will not actually, be any difference, because if you create users, that will be actually on the application. It has nothing to do with the load balancer. Nagaraju says group level strictness is off. In rules, what is it? So stickiness basically means, Nagaraju, when let's say you are connected to a server and you're uploading something over there, right? So if you have uploaded something to that server, it will not be replicated across the other servers. So when you enable stickiness for the session that you are connected to, your request will always be routed to the same server through which the load balancer has given you the first access. Because what happens is right now we just have two servers. We don't have any replicas of it. On production architectures, we have a lot of replicas of each server. So which replica to connect to, your load balancer randomly picks up one and connect you to it, whichever is available. But if you have something that you are uploading and you're in the process of uploading it, the problem is that you have to be on the same server while that process is happening. And that is what stickiness basically attends to. So Devashi is saying, why we put star in /watch. So Devashi, star basically means that anything after this URL, whatever is anything, whatever thing what you want to add after /watch, right? It does not matter. You should still be routed to the same server. For example, if I type in /watch, right, and then I can type in anything over here. So if this file exists on the server, I will still be on the watch server, not on the home server. So this is what star means. That means I can have anything after this URL, and still my request will be forwarded to that target group which has the watch servers, no other target group. That's what star basically means. So Raju is saying, won't be using Route 53. We will be using Raj. Okay, so Kishore is saying, wanted to connect with you. Okay, so Kishore, let's talk after this session. Surendra is saying, awesome and big session. Please share me recording on this email. Yes, Surendra, it will be shared to you. Nagaraju is saying, many thanks for the sessions yesterday and today. You're welcome, Nagaraju. Okay, Murthy is saying, proxy server, private subnet for UI application, private subnet for RDS will be typical config, right? It will be the same config, Murthy. Now that you know how the networks are basically configured, you can launch any resource, and then you can just have to specify that that resource has to launch in a private subnet. All right. And then since with databases, the scene is that only your application will be connecting to the database. Nobody else, nobody from the outside also will be connecting to your database. So in that case, you don't have to configure anything else, right? Since your database will be going to be a part of the Netflix network, right? So your database can automatically be connected to your application servers which you have deployed in the private subnet. Okay. Altaf is saying Netflix architecture, good and easy to understand. Do we have any other cloud architecture repository where we can try to implement and simulate? Altaf, not as of now, but you can just subscribe to the Intellipaat YouTube channel. So if we have something coming up, we can actually, we are actually going to publish it over there, and you will be the you'll be the right audience to get notified in that case. Ashish is saying, thanks. For example, if you have multiple servers, say 100, do we need manual SSH to all with proxy? No, Ashish. So that is why you deal with images. So I created an image, and through that image now I can create 100 servers. So I don't have to configure every one of them. Now let's say there is one common change that I have to do in all the servers. So what I'll do is I'll create an image and then I'll replace all those 100 servers with the new servers that I'll be deploying. So that is how you do it. Devashi is saying, is companies like Netflix use Windows or Linux? Which OS they use for hosting their website? So Devashi, they use Linux for hosting it most of the times. It'll never be Windows. It'll either be Linux or some type of some custom operating system that they have made. It'll never be Windows. So Sharath is saying, please share the recording. Sharath will be shared to you. Don't worry. Raj is saying, Hemant, do you also teach AWS Solutions Architect course in Intellipaat? Yes, Raj, I do. So you can just check with Intellipaat in case you're interested. Okay, guys. So now what we'll be doing is, now we will be connecting a custom URL to our load balancer. And I understand we have already, taken a lot of time for this session. It'll just take 5 to 10 more minutes, guys, and then we'll be done. Okay. So first things first, what you need is a URL first. So what you need to do is just go to your Freenom website. So there's a website called Freenom. It basically gives you free URLs. Okay. Otherwise, if you have to buy a URL, it's a proprietary resource. You'll have to pay for the URLs that you want. But with Freenom, you can get a free URL at your will. Okay. So just sign up on Freenom. So I already have signed up. So let me just connect to it. Let me sign in quickly. Okay, I'm connected. Let's go to my domains. So right now I have some domains, but I'll be showing you once you sign up, how you can create your own domain. So what I'll be doing is, as you can see, these are some domains that I have. I'll be creating a new domain, just like you guys would be doing when you sign up. So I'll just go to register a new domain, go to services, go to register a new domain. And in register a new domain, just specify the name of the domain that you want. So in my case, I want Netflix-demo. Let's check the availability. So as you can see, these are all domains which are free and I can get them. So let's get this domain. Check it out. Continue. And just agree to the conditions and click on complete order. So with this, your order has been confirmed and you can now go ahead to my domains. You have the Netflix demo domain registered to you. You can just click on manage domain. And here you will have to go to click on management tools and then click on name servers. Okay, and what you have to type in is custom name servers. So these are some name servers that you have to fill in. Now, how can you fill these name servers? Again, go back to your AWS Management Console. Click on services, type in Route 53. Now, once you're inside Route 53, you will have to choose a hosted zone. Let's click on create hosted zone. And over here, just type in the domain name that you created. So it's Netflix-demo.pk. Give the same name over here. Click on create. And this will create a hosted zone for you. Now, as you can see, these are name servers that you will have to enter over there in Freenom. Okay, so just select this. Copy these name servers one by one. Go to the second name server, again copy it from here. Third name server, again copy it from here. Fourth name server, again copy it from here. Okay, so that's all the changes that you have to do on Freenom. You can close it now. Now in Route 53, you just have to do one small change. Click on create record set, right? And now what you'll be doing is you'll be pointing. So what have you done so far? You have mentioned these name servers in your Freenom website, right? So now your domain will be pointing to these name servers, which are basically the Route 53 service that you have. Now this Route 53, you will have to point to your load balancer. So how will you do that? You will find this section called alias, click on yes. And here you have to select your Netflix demo load balancer. Okay, click on create. So entry is made over here. Similarly, one more entry you have to create with the similar settings, just that in name you will have to enter www as well. Click on alias yes, select the load balancer, click on create. Okay, so with this, now your Route 53 is ready. And now what you can do is just go to a browser, type in netflix-demo.tk, hit enter, and it will now route you to the home page directly. And now if you go to the URL /watch, it is now pointing you to the streaming page. And this is exactly what is happening on your Netflix website as well. So let me quickly show it to you. Okay, so if we go to netflix.com/browse, it'll take you to the home page. If you type in netflix.tk/home, it'll take you to the home page. If you type in netflix.com/watch and then the video title, it will take you to the video player, which will play the video file for you. And similarly, if here you go to netflix.com/watch, you will be taken to the streaming page. And guys, this is how you mimic the architecture for Netflix on AWS.
Intellipaat, basically the company that we work for, is an e-learning company, and we basically researched a lot of job descriptions, and what we came up with was this Cloud and DevOps Architect Masters course. Now in this, we have put down all the skills from all the job descriptions that we have got, for cloud related jobs. And also we are in touch with, since we are with a training company, all our instructors are basically working professionals. So we have got in touch with top cloud and DevOps professionals and asked them what are the relevant skills that you think are expected from a cloud engineer, person who is basically appearing for an interview. So based on what the feedback that we got from our instructors, based on the feedback we did from our research, we have come up with this course. And these are the things, these are the skills that we teach to a person when we take him basically on board with us in the Cloud and DevOps Architect Masters course. Why should you become a cloud engineer? Now guys, let's start off with the basic necessity. What is the salary that a cloud engineer actually earns, right? So let's talk about that. So what we have done is we have basically collected data from a lot of sites which basically do job postings. We have done it from ZipRecruiter, we have done it from Indeed, we have done it from Glassdoor. And this is what we have seen. So in the US, a cloud engineer, an average cloud engineer basically earns $128,000 per annum. In India, an average cloud engineer earns around 7 lakh rupees per annum. And in the UK, you have around 60,000 pounds per annum. Okay. So guys, this is an average salary. Now, based on your experience, let's say you have a 10 or 12 years of experience in the IT domain and you plan on to shift onto the cloud sphere. In that case, you might even get a salary up to 20 plus lakhs per annum in India, right? I'm just talking about with the limited experience that I have. So I have friends who have salaries for 25 plus lakhs per annum, but that given that they also have a very strong background in the IT domain, right? I also have seen people who have basically shifted from non-IT domains and they started in the cloud sphere. And even in that case, given that, you can implement what you have learned in your past experience in the cloud domain, they easily can grab a salary of around 12 to 15 lakhs based on their experience, right? So these are the two things that I talked about. The other thing is it also depends, like I said, on your experience. And if you're a fresher and you're just starting out and you're thinking of basically starting off with the cloud domain, you can easily earn around 4.5 to 5 lakhs per annum if you are a fresher, given you don't have any experience in the industry and you are just starting off as a cloud engineer in this space, right? So this is the salary that you get when you basically become a cloud engineer, and based on your experience, you can expect a different or a varied salary exposure. Okay, moving forward, guys, now let's talk about the things which are important for you to get a higher salary. Now, how do you differentiate yourself from the people who are also there appearing for the same profile and are there in the interview room? So what differentiates you is your certification. So what are you certified with? Are you certified from AWS? Are you certified from Microsoft? Or are you certified from Google Cloud? Now, these are the top 3 cloud providers in the market right now. And each and every company who works on cloud would have their product on any of these cloud, right? And basically that is the reason any company who is basically expecting a cloud engineer in their firm, they would expect you to have a certification from either of these 3, right? And once you get certified, that basically tells the company, okay, so now you're certified in this particular domain. We now know that you know cloud up till a particular proficiency, and then they start asking questions from that particular level. Now, this might not be helpful for some people who have a hybrid kind of a profile wherein they are working as a software developer full-time and they also work on cloud for some part of their project, right? But if they try to shift their domain, they might get a job even without getting certified. That is also possible. But usually certification helps you when, let's say, you are working in a domain where cloud is not at all used, right? Let's say you're working as a system administrator, and let's say you're working for a company like IBM, which have their own private cloud. So what you don't have experience in, or what you cannot put in your resume, is that you have worked on AWS, you worked on GCP, you have worked on Azure on certain projects. That you cannot put. So for people like these, for people who don't have the working experience in these domains that are AWS, Microsoft Azure, and Google Cloud, if you are planning to become a cloud engineer, you would be to get certified in these cloud domains, right? So once you get certified, that basically tells the company, even though this person has not worked on production for these clouds, this guy has been basically certified by a parent body of the cloud provider. For in our case, let's talk about AWS. So in case of AWS, the parent company is Amazon. So Amazon certifies this guy that he's proficient in their cloud infrastructure, right? And this is what the certification tells me. Now, on this certification, obviously, you'll have to also do some projects that you would be doing independently, and that you'll have to add to your resume. And that is how you will tell the company that you're appearing for that I have done some projects in cloud, although I did not get the time while I was working in my company in the production environment. But this is what I've done in the side time of mine, right? I've done these projects, and I've also got a certification from this company that I am a solution architect or a developer or an administrator, whichever certification you do, right? So a certification is very important, and with the certification, you can expect a salary hike, right? And the average salary which we have discussed, this 139,000 is just a number. But whatever we discussed, you can aim for those salaries, given you don't have the experience in a current company with the certification. So you will have to get certified if you want to become a cloud engineer and you don't have the relevant experience right now. Okay, moving forward, guys, now let me tell you some of the average salaries based on the certifications. So if you are an AWS certified solutions architect in the US, you can expect around $130,000 per annum. If you are a AWS certified developer, you can expect around $130,000. And if you are a Microsoft Azure certified solutions architect, you can expect around $121,000. Now, all these salaries are basically the average salary. So what I can tell you is from $120,000 to $130,000 in the US, you can earn once you get certified by these companies and given you have the relevant experience. Okay. Now, you might have noticed over here that you have something called as a solutions architect, or you have something called as a developer, and all of these are basically certified by AWS. So what are these? Now, guys, for the people who are from the IT domain, and if they want to make a shift to the cloud, and you also want to bring along with you the experience that you have in the IT industry, what you can do is, let's say you are a developer right now. Okay, Okay, and what you want to do is you want to become or you want to do development in AWS with, let's say you have an application on Node.js and you want that Node.js application to interact with some services on AWS. So what will you have to know? You'll have to know some SDKs, you'll have to know how to interact with AWS APIs. So all that knowledge is basically gained by a person who is a AWS certified developer. When we compare him with a solutions architect, the solutions architect job is not to code. So most of the people that I've trained or that I know basically are solutions architect. The reason for that is when they started off in their IT journey, they did not know much about cloud. And they started off as a normal software engineer or a system admin or something like that. And now for the people who don't know coding, right, and they still want to be in cloud, people can easily crack the solutions architect profile. The reason for that is in the solutions architect profile, what you have to know is how to plan things. What you have to know is how to architect applications without happening or without knowing the actual implementation of the code. So that is what the solutions architect profile is. But mind you guys, this profile is super tough as well as you progress in your career. So you will find architects who were developers before, who were system admins before. They have the complete knowledge of the inside and out of the product. They can code also, and they also know how to plan. So those kind of people are also solutions architect, and obviously their salary are on the higher range. If I talk about a solutions architect who knows coding, who knows in and out of the application and knows multiple clouds, his salary can go up to 40 plus lakhs per annum as well in India, right? So that is the kind of scope that you have when you get yourself acquainted with AWS. It's a journey that you'll have to start with, right? But you will even find solutions architects who are sitting at 4 or 5 lakhs per annum. And those people are basically freshers who have joined the industry and they just know AWS, right? You will also find solutions architects who are around 14 or 15 lakhs based on the experience that they had and now they have shifted to cloud. So based on your experience, you can go up the ladder, right? The Certified Solutions Architect Associate is just a certification, but what matters is what experience you're bringing to the table, and that just makes everything change, or that makes the dice rolling when you're basically applying for a job. Okay. Moving forward, guys, now let's talk about what is the cloud engineer role. So we have talked about why you should be a cloud engineer, where I talked to guys about. We have talked about the money aspect. Let me also give you one more aspect, guys, that Forbes or some independent body, we are going to discuss about it in the future, in the next couple of slides. But they have predicted that whatever revenue cloud is earning right now in 2019, by 2023, that revenue itself of the whole cloud industry is going to double, right? So that basically means whatever number of job postings that I'm going to show you today, they are going to basically double or triple by the year 2023 or 2025, right? So that's the kind of growth that cloud is going to see in the future. And if there is any time to shift to the cloud domain, it is right now, right? So if you are thinking about moving to the cloud domain, or if you want and are intrigued with what cloud is and you want a job in the cloud domain, right now is the time that you should migrate from your current job role to cloud, right? Now, what will you do when you become a cloud engineer? What exactly will be your role? Let's discuss that. Now, guys, a cloud engineer, or like for my friends who are not acquainted with what cloud is, guys, cloud is nothing but, in the most simplest terms possible, it is the use of remote servers on the internet. Okay. So if you have remote servers on the internet and you use them from the comfort of your own laptop, you are basically on cloud. You're basically using servers which are not there in your premises. You're using servers which are away from you. So that means you're using the cloud. So don't get confused with what cloud means. Cloud basically means you don't know where the server exists. You just have an IP address, you have the username and the password, and you just type that and you can see the desktop of that machine and you can do anything you want. That is cloud, right? In the most simplest terms. But it gets a little complex when we talk about, so I talked about a server that you would be existing on cloud that you can connect with, right? Now you have specialized servers in cloud which can do a particular task. For example, you have backend servers, you have front-end servers, you have database servers, and you can do a mix and match of these servers and create a whole ecosystem of application around you. So this is what a cloud engineer knows. He knows how to use the services provided by a cloud provider in the most optimum fashion possible and create a highly available and highly reliable application out of it, right? Doesn't matter if you code the best application in the world, but if your infrastructure is not supporting your application, you won't get the kind of performance you want out of your application, right? And that is exactly why you need cloud engineers, because they know how to deploy your application. They know which server to deploy it on or which service to use it on, use on cloud provider to deploy a particular application. If I were to give you an example of how it works from the top of my mind is, there are two backend languages. I'm not sure if everybody of you would have heard of it, but just hear to the example and you'll know what I'm talking about. So there is a programming language called PHP and there's a programming language called Node.js. Now Node.js basically works on single thread while PHP works on multi-thread, right? So what happens is when you have to choose between PHP and Node.js for your application, let's say you work in a company and that company has made an application, the development team has made an application and now they come to you asking, or they are planning to make an application and they come to you asking which programming language should we use? Should we use PHP or should we use Node.js? Now you as an architect, you tell them that, if you're using PHP, it's a multi-threaded language. If you use Node.js, that's a single-threaded language. Now this is something that you will find in any of the documentations. But what an architect needs to know is what are the advantages of using single-thread language and what are the advantages of using a multi-thread language. When you use a single-thread language, you cannot give that language processing intensive tasks. For example, if there is one task that requires a lot of processing, that would not function well on Node.js, given it's a single-threaded language, right? While on PHP, if there are multiple threads which can run at a single time, that particular language can accept process, an application which involves a lot of processing, right? But if your application does not have that much of a processing, it's just about doing CRUD operations on databases, right? In those kind of scenarios, you can use Node.js because it performs way better than PHP. Now, this knowledge which I just told you is a knowledge that an architect should know, right? Or a person who is handling a team or who's going to deploy your application on a particular infrastructure or in a particular environment should know. And this is similar to this knowledge in infrastructure, a cloud engineer should also know, right? For example, if my application is process intensive, if it requires a lot of processing, how much of RAM or how much of CPU would a single server require? That I have to plan. Which service on the cloud? Like for example, in AWS, there are 3 types of compute services. Mainly, right? You have EC2, you have Elastic Beanstalk, you have Lambda, right? So where to put which application you have to know. For example, Lambda requires backend or basically does backend processing for you, right? So backend part of your application would go on AWS Lambda. Now, obviously, if it's going on AWS Lambda, you'll also have to make it highly available. So AWS Lambda handles it for you. But when we talk about your front end, where a lot of users are going to ping your website, that task will basically requiring a lot of scaling up and down because the traffic is not the same at every time. What I basically mean by that is, let's say you are running a company and at around 4 p.m. you get the maximum traffic, right? So in that case, you need a server capacity of around 9 or 10 servers at that time. And at 6 p.m. the traffic drops. Okay, at that time you don't need those many servers. So how to configure the auto scaling properties in cloud providers, right? That and all this knowledge is what an architect gains when he basically gets certified or when he roasts himself by doing work day in and day out as a cloud engineer, right? So guys, a cloud engineer role, to sum it up, is to know what application would go on what service of the cloud and what would be the best practices of deploying an application. That is what a cloud engineer should know, right? Now, he has to work on planning, he has to work on architecting, then he also has to work on managing the infrastructure once it's deployed. And obviously, he also has to look at how we can monitor and support this particular application. All this planning, all this implementation is done by the architect or the administrator or the developer, but essentially they are known as cloud engineers. And this is what your role would be when you shift into the cloud domain. So to sum it up, if you are applying the best practices and whatever principles you have learned in cloud, then that profile would sum up to become a cloud engineer profile. Now, moving forward, guys, let's talk about the skills that a cloud engineer should have, right? So a cloud engineer or a person, if I'm a company and if I'm hiring a cloud engineer, I would expect certain skills out of a person. So I would expect he should know some programming language. I would expect he would know some Linux scripting skills that he should have. I would expect him to have some troubleshooting skills, and I would expect him to know multiple cloud domains. Now, this is not what I think the companies would expect. This is basically the research that we have done, and I'll show you in some moment, guys. I'll show you some job descriptions from companies who are basically hiring cloud engineers, and I'll show you what kind of skills that they ask, right? So how to become a cloud engineer? So I told you guys some companies expect some skills. Now, how to get yourself acquainted in those skills? But before that, let me show you actually what are the requirements and skills that are expected from a cloud engineer. So guys, a job description is what we will be looking at. So in this particular section of job roles and responsibilities, I'll be showing you some job descriptions from multiple companies, and then we'll sum it up and see what are the required skills which the industry is demanding right now to become a cloud engineer. Okay, so let's start off with the first job description. So this is a job description which is by Cisco, right? And they are basically hiring a cloud infrastructure engineer, and what they expect this guy to know is DevOps. He should know how to resolve customer issues. That is, he should be customer centric, right? He should know how to deploy cloud applications on AWS. He should know about VPCs, which are basically services in AWS, EC2, again a service, etc. Right? So these are the skills that they expect from a cloud engineer. You would be wondering, what is DevOps over here, right? So I will explain that in a few moments. But as you can see, these are all the skills that they expect from a cloud engineer in the Cisco company. Now let's go ahead. Let's talk about Amazon. So Amazon is also hiring cloud engineer, and what they expect is they should know troubleshooting. They should have experience with AWS, Google Cloud, Rackspace, software layer management, etc. They should know a programming language among Java, Perl, Ruby, or Python. And they should have experience in managing full stack applications, right? This is the expectation from a cloud engineer by Amazon company. Then there is a company, McAfee, which I'm sure all of you know. Now, in this, you are expected to know AWS, you're expected to know Azure, you're expected to know Google Cloud, right? You're expected to know CloudFormation, which is basically a service in AWS. You are expected to know Puppet, Ansible, and Chef, which are basically DevOps tools. You're expected to know Python, right? So all these skills are required. So what I'm trying to tell you is it will not work if you just know one cloud provider. It will not work if you just know one programming language. You have to know a combination of multiple things, and only then this cloud engineer profile can be taken on. Okay, and more skills and more relevant you become with the job descriptions. For example, I'm not focusing on any one company. What I've done is I have generally taken out skills from multiple cloud engineer profiles, and then I have accumulated them together. Let me show you how that looks like. So the required skills are these. So if you were to sum it up, if you want to become a cloud engineer, you should have knowledge of AWS, Azure, and GCP, right? Then you should have an experience in any of these programming languages: Python, Java, Go, R, Clojure. I would recommend you, if you are planning on to learn programming language, you should basically either learn Python or Go, basically, because they are huge when it comes to the demand that they have right now. You should have a little experience in Linux operating systems. Not a little, actually. I'll say you should be an intermediate in your Linux skills. Then you should also know tools like Puppet, Chef, Git, Docker, Kubernetes, Nagios, Terraform, etc. Right? So don't get scared, guys, with all these big words. I'm not only telling you the problem or what the companies expect, I'll also give you a solution as to how you can prepare for this. Okay? So, and you should also have an understanding of APIs and web services. Okay? So these are all the skills that are required to become a cloud engineer, and I would say even if you gauge around 60 to 70% of these skills, you can apply for a cloud engineer job. This is basically job description for a generic company which is out there. Now, how relevant you become to become a cloud engineer is this list. The more and more you know this list, the more and more you become relevant, and you can apply for any cloud engineer job as you move along. Okay. Now, let's talk about what are the skills that we have summarized. So I've told you guys that you should know Linux. So first off, when you start on the journey of becoming a cloud engineer, you should start off by learning Linux. If you know Linux, you can skip this. But if you don't know Linux, first you should learn this, right? Then you should start off with all the cloud providers, that is AWS, Azure, and GCP. You should start learning that. Once you are done with Linux and cloud providers, you now know how things work on cloud, okay? Now what you have to know is how companies implement or upload or basically help their development team to integrate their development tools with cloud, and that is exactly what DevOps is for. If I were to give you an example, let's say there's a developer in a company and what he knows is basically a place where he can upload your code, right? For example, a developer's best friend is basically a version control system. Let's assume he's using GitHub, right? So all he knows is how to code and how to upload it on GitHub. But from GitHub, how do you test that application? And if the test is complete, how do you make it available on production? That life cycle is basically what DevOps caters to. Okay. Now, how does cloud fit in DevOps is when you have deployed an application on, let's say, your production server, most of the companies now are basically using cloud, right? Which basically means they don't have any infrastructure of their own. Probably the developer's machine would be there in the company, but the server on which the application is deployed is not in the company. It's on the cloud. So I think you got the idea that whenever your applications are either getting deployed on testing server or on the prod server, these servers are nothing but these are servers which are deployed on the cloud, which could be either AWS, Azure, or GCP. So how to create the DevOps lifecycle on the cloud is what you'll have to learn. And that's why you also have the DevOps tools as a skill when you want to become a cloud engineer. Then you should also know a programming language. The reason for that is I told you guys a cloud engineer should also know how to code. The reason for that is let's say an application stops working, all right? And now the developers have no clue why it's not working. So it's your job to understand the code and understand where exactly the problem is occurring. And that's why it is recommended that you should know a programming language. Otherwise, if you're planning to aim for the cloud developer role, in that case, what you'll be doing is you basically will be implementing your application with the cloud, right? And if you're integrating your application with the cloud, which basically means you have to interact with the services of the cloud, then you have to know how to implement SDKs, right, in a programming language. And that exactly would be covered when you know a programming language, right? And finally, because today, in today's world, we are no longer working with monolithic applications. What are monolithic applications? There is no one code which will basically run my whole application. You basically have different parts of the application deployed separately, and these different parts interact with each other. And these are what APIs are in the most simplest terms. Okay. So if you did not get that, let me just tell you in a brief sentence that earlier all the applications had one single code base and they were deployed and the application used to work. But what happened was, as we progressed in the software development journey, we realized that let's say I'm using the Uber app and I have to add a feature in the payments section. So I'll have to open the whole code base again. I'll have to go to the payments section of the code and I'll have to make changes and then upload the whole code again. This unnecessarily broke something or the other in the whole code base. And now what we follow is a microservices architecture. And in the microservices architecture, what we do is we basically break the application into multiple parts, and then these parts interact with each other using API endpoints, right? So as a cloud engineer with the modern applications that we deploy, you should also know what are APIs. Okay. So these are the required skills for you to become a cloud engineer, and you should follow this particular fashion when you are basically preparing for a cloud engineer role. Okay. Now, I told you guys how you can prepare for a cloud engineer role, right? Now, if you were to do it on your own, this is the way. If you want help from us or from any e-learning company, I'll tell you a way as to how you can learn that as well. Okay. But before that, I'd like to tell you guys the present is good. I mean, if you want to become a cloud engineer right now, it's the best possible time you can become. If you become right now, what is the future that lies in front of you? It should not be like that in 2-3 years, the demand goes down, right? So let me tell you the future of a cloud engineer. So guys, these are basically some statements that I have picked up from these companies. Like Forbes says cloud engineer or cloud architect profile is in the Forbes top 15 list of highest paying tech jobs right now, right? Forbes says around $146,000 is the median salary for a cloud professional, which is basically a jump because when they did the survey in 2016, it was $22,000 less than the figure that you see right now. So as the number of years are passing by, the obviously the inflation is also there, but $22,000 is not the kind of inflation that you would see, guys, right? So it's a huge jump in the median salary, in the average salary of a cloud engineer. Then according to Glassdoor, in the last month alone, right, we are talking right now in August 2019. So in July 2019, there were 5,765 jobs posted in India just for a cloud engineer. And there were 33,272 jobs which are posted that were in the US. Okay. So this is the huge demand that you can see that is there for a cloud engineer profile. Similarly, there's a company called Canalys. So they say AWS, which is the biggest cloud provider in the market right now, it owns around 31.5% of the cloud market share. Now you would think that 31.5 is not a huge number, but when you compare it with Azure, which is the second largest cloud provider, it has around 14 or 15% of the cloud market share, which is actually the half of what AWS owns. And it is the second largest cloud provider, Microsoft Azure. So as you can see, AWS has a whole lead. And the reason for telling you this is when you're planning to learn about the cloud providers, which I basically told you three, which are AWS, Azure, and GCP, you should always start with AWS, given you don't know AWS yet, right? The reason for that is once you learn AWS and let's say, you plan on going on with the other skills like the DevOps skills and the programming languages skills, you can actually skip Azure and GCP for a while, because when you apply for jobs, 31 out of 100, 31 companies would be using AWS, 16 companies would be using Microsoft Azure. And if I were to go by my memory, around 8 to 9% or 6 to 7% is actually by the GCP. So out of 100, 31 companies AWS, 16 companies Microsoft Azure, and 6 to 7 companies would be Google Cloud. So this is the current figure. So if you go by probability, you are likely to get a job as a cloud engineer if you know AWS, then if you know Microsoft Azure and GCP. But our aim is to know all the three. But if you were to plan as to how to learn all the skills that we have discussed today, you should start with AWS. So this point is specifically for that. And finally, according to Report Linker, so this was the fact that I was talking about in the beginning of the session, that right now the cloud industry has the revenue of around $258 billion annually, right? So by 2023, this is going to become $623.3 billion. That's more than the double of what the cloud industry is gaining right now, right? So this basically just tells us how much the cloud industry is going to grow in the future. All right. Moving forward, now let's talk about the job roles that you have in cloud. So I told you can become a cloud engineer, but actually a cloud engineer is basically a generic profile which companies post on the job portal. It is basically built up with a combination of job roles. So what are those job roles? So the first profile is solutions architect, which I told you about, wherein you have to plan, you have to know the in and out of your application. You should know which part of your application should be deployed on which service of the cloud. That job is basically the solutions architect job. Then you have the cloud developer. So cloud developer is a person who knows how to develop applications and also how to write SDKs so that the application can interact with the cloud services. So that's a guy who is a cloud developer. Then you have a person who is a SysOps administrator. A SysOps administrator is a person who basically manages the infrastructure once it has been deployed by the architecture, right? So once the infrastructure has been either designed or applied by the architect, the SysOps guy's job would be to implement that architecture or handle that architecture according to the norms that has been specified by the solutions architect. So this is what a SysOps administrator is. So for all my friends who have an experience in development and they feel that, I want to stay in development right now, I don't want to become a full stack cloud engineer, I basically want to be in development, but I would want some of my job to include cloud, then your profile that you're aiming for is cloud developer. For my friends who are already system administrators and they basically want to skill up themselves by becoming system administrators for particular cloud provider, they can basically aim for the SysOps administrator profile. And for the people who want to move up the ladder, they basically have around 14 to 15 years of experience either, or basically they are from a non-IT background and they want to shift in the cloud domain. You should start off with the solutions architect profile. Okay. Then I have some more profiles which are basically cloud network engineers. So people who are focused on just networking aspect of cloud. If you want to become a network guru, then in your case, you should opt for the cloud network engineer profile. And then you have the cloud DevOps engineer, which is basically a profile which basically expects you to know cloud in and out, which expects you to know DevOps in and out. And this is basically the profile that I was telling you about that you should aim for, right? You should know all the skills that are basically expected from a person who is a cloud engineer and basically then would become a generic cloud engineer who can apply to any company. So this is that guy. So your aim is this. If you want to start off from a particular point, your point would be this. You become a solutions architect first, get yourself certified in that, then work your way up for cloud DevOps engineer. And similarly, you can become a cloud developer or a SysOps administrator, and then you can get certified in cloud DevOps engineer. Similarly for cloud network engineer as well. Okay. Now we discussed all the jobs which are there in cloud. If you want to become a full stack, if you want to implement cloud in your job, I just showed you some profiles which you can get certified in. Now, some of my viewers today would be wondering, like, the current job that I am in right now, can I implement cloud in that? So let me show you some stats. So guys, the top 15 tech jobs which have the cloud related skills in the job description, that is what we are going to discuss right now. So guys, a software engineer, if you go by the generic job descriptions that we see every day, more and more software engineer job descriptions are expecting the software engineers to know cloud, which basically means if you are a software engineer right now and you are aiming for the future and you still want to be a software engineer, then almost 8 to 9% currently job description expects you to 8 to 9% of your job description. That means, let's say you have 100 skills, out of those 10 skills should be in cloud, right? So this is what the 7.92 number means. Then you have the senior software engineer profile, which basically again expects you to have around 6.7% skills in cloud. Software architect expects you to have 6.21%. So basically the aim is to show you guys that all the profiles that you see over here, although they do not coincide with any cloud profile, still they have some elements of cloud skills in their job description, which basically means most of the companies which are related to IT today are doing something or the other thing on cloud, and that's why they expect all their employees to know cloud, right? So what I'm trying to tell you from this slide is, whatever profile you are in, if you want to be relevant to the industry, you should know or you should start upgrading yourself with cloud today. Okay. Then these are some of the other profiles that you can have a look at. For example, a cloud engineer profile, a generic cloud engineer profile, a data engineer profile, a Java developer profile, system engineer, data scientist, then a system administrator, Java developer, .NET, front-end developer, back-end developer. All of these people, they have some element of cloud skills in the job description, and that is what you should aim for. If you are currently sitting in these profiles and you don't have this cloud skill, you should get started today. Intellipaat, basically the company that we work for, is an e-learning company, and we basically researched a lot of job descriptions, and what we came up with was this cloud and DevOps architect master's course. Now in this, we have put down all the skills from all the job descriptions that we have got, for cloud related jobs. And also we are in touch with, since we are with a training company, all our instructors are basically working professionals. So we have got in touch with top cloud and DevOps professionals and asked them what are the relevant skills that you think are expected from a cloud engineer, person who is basically appearing for an interview. So based on what the feedback that we got from our instructors, based on the feedback we did from our research, we have come up with this course, and these are the things, or these are the skills that we teach to a person when we take him basically on board with us in the cloud and DevOps architect master's course. Today in this session, we are going to discuss the top AWS questions that can be asked to you in your next AWS interview. So the first question says, what is the difference between an AMI and an instance? So guys, an AMI is nothing but a template of an operating system. It's just like a CD that you have of an operating system which you can install on any machine on the planet, right? Similarly, an AMI is a template or is an installation of an operating system which you can install on any servers which fall into the Amazon infrastructure. All right, you have many types of AMIs. You have Windows AMI, you have Ubuntu AMIs, you have CentOS AMIs, etc. There are a lot of AMIs that are present in AWS Marketplace, and you can install them on any servers which are there in the AWS infrastructure. All right. Coming on to instances, what are instances? So instances are nothing but the hardware machines on which you will install AMI, right? So like I said, AMIs are templates which can be installed on machines. These machines are called instances. And again, instances also have types based on the hardware capacity. For example, a 1 CPU and 1 GB of machine is called T2.micro, right? Similarly, you have T2.large, you have T2.extra large, then you have IO intensive machines, you have storage intensive machines, you have memory intensive machines, and all of these have been classified in different classes, right? Depending on their hardware capability. So this was the difference between an AMI and an instance. Our next question asks us, what is the difference between scalability and elasticity? Alright, so guys, scalability versus elasticity is a very confusing topic, and if you think about it, so scalability is nothing but increasing the machine's resources. For example, if your machine has 8 GB of RAM today, you increase it to 16 GB. Therefore, the number of machines are not increasing. You are basically just increasing the specification of the machine, right? And this is called scalability. When we talk about elasticity, we are basically increasing the number of machines present in an architecture. We are not increasing the specification of any machine. For example, we choose that we require a 3 GB machine with say around 8 GB or 10 GB of storage, right? So any replica which will be made or any auto scaling which will happen, it will only happen to the number of machines. It will nowhere be related to the specification of the machine. The specification of the machine will be fixed. The number of machines will go up and down, and this is called elasticity. On the other hand, scalability is basically termed as the change of the specification of the machine. That is, you're not increasing the number of machines, you're basically just increasing the specs of the machine. For example, the RAM, the memory, the hard disk, etc. And this is the basic difference between scalability and elasticity. Moving forward, our next question is, which AWS offering enables customers to find, buy, and immediately start using software solutions in their AWS environment? Now you can think of it as, say you want a deep learning AMI, or you want a Windows Server AMI which specific software is installed on it, right? So some of them are available for free, but some of them can be purchased in the AWS Marketplace. So the answer for this is AWS Marketplace. It's basically a place where you can buy all the AWS systems that you or all the AWS or non-AWS softwares that you require to run on the AWS infrastructure, right? So the answer is AWS Marketplace. Moving on, our next question would fall under the domain of resilience architecture. So all the questions that we'll be discussing henceforth in this domain will all be dealing with the resiliency of an architecture. All right. So a customer wants to capture all client connection information from his load balancer at an interval of 5 minutes. Which of the following options should be chosen for his application? All right. So I'll read out the options for you. The option A says enable AWS CloudTrail for the cloud balancer, for the load balancer. Option B says CloudTrail is enabled globally. Option C says install the Amazon CloudWatch logs agent on the load balancer. And option D says enable CloudWatch metrics on the load balancer. All right. Now, if you think about it, CloudTrail and CloudWatch are both monitoring tools. So it's a bit confusing, but if you have studied it deeply, or if you understand how CloudTrail works and how CloudWatch works, it is actually not that difficult. All right. So the answer for this is A, that is, you should enable AWS CloudTrail for the load balancer. Reason being, option B is not correct. CloudTrail is not enabled by default or is not enabled globally to all the services. Option C says install Amazon CloudWatch. So option C and option D, you will not even consider, reason being that you're talking about the log of the client information, right? What all people are connecting to the load balancer, what IP addresses are connecting to the load balancer, etc. CloudWatch deals with the local resources of the instance that you are basically monitoring. For example, if you are monitoring EC2 instance, CloudWatch can monitor the CPU usage or the memory usage of that particular instance. It cannot take into account the connections which are getting connected to your AWS infrastructure, right? On the other hand, CloudTrail deals with all these kind of things wherein client information or any kind of data which can be fetched from a particular transaction, all of that can be recorded in the logs of CloudTrail, and hence for this particular question, the answer is enable AWS CloudTrail for the load balancer. Moving on, our next question is, in what scenarios should we choose classic load balancer and application load balancer? All right. So for this question, I think the best way to answer this question would be to understand what exactly is classic load balancer and what exactly is application load balancer. All right. So a classic load balancer is nothing but, it's an old-fashioned load balancer which does nothing but round-robin based distribution of traffic, which means it distributes traffic equally among the machines which are under it. It cannot recognize which machine requires which kind of workload or it requires which kind of traffic. Whatever data will come to a classic load balancer will be distributed equally among the machines which have been registered to it. On the other hand, application load balancer is a new age load balancer which basically deals with identifying the workload which is coming to it, right? It can identify the workload based on two things. It can either identify it based on the path. For example, you can say that you have a website which deals in image processing and video processing. So you can say it might go to intellipaat.com/images or /videos. So if the path is /images, the application load balancer will directly route the traffic to only the images servers, right? And if the path is /videos, the application load balancer will automatically route the traffic to the video servers. And this is application load balancer. So whenever you are dealing with multivariate traffic, that is traffic which is meant for a specific group of servers, you would use application load balancer. On the other hand, if you have servers which do the exact same thing, right? You just want to distribute the load among them equally, then in that case you would use a classic load balancer. Our next question says, if you have a website which performs two tasks, that is rendering images and rendering videos, both of these pages are hosted on different parts of the website but under the same domain name. Which AWS component will be apt for your use case among the following? Alright, so this I think is an easy question, reason being we just discussed this, right? So the answer for this is application load balancer, reason being the kind of traffic which is coming is specific to its workload, and this can be differentiated easily by an application load balancer. Okay, so we are done with the resilient architecture questions. Now let's move on to the performance architecture domain, where we'll be discussing about how to about architectures which are performance driven, right? So let's take a look at the first question. So the first question says, you require the ability to analyze a customer's clickstream data on a website so they can do behavioral analysis. So your customer needs to know what sequence of pages and ads their customers clicked on. This data will be used in real time to modify the page layouts as customers click through the site to increase stickiness and advertise click-through, which option meets the requirement for captioning and analyzing this data. All right. So the options are Amazon SNS, AWS CloudTrail, AWS Kinesis, and AWS SES. So let's first start with the odd one out options, right? So we have Amazon SNS, which deals with notifications. So obviously, because we want to basically we want to track user data, right? So SNS would not be the apt choice for it, because sending multiple notifications in a short amount of time would not be apt. Similarly, SES would also not be the apt choice, because then we will be getting emails on basically the user behavior, and this would amount to a lot of emails. So hence it's not an appropriate solution, I think. Then we have AWS CloudTrail and AWS Kinesis. Actually, both these servers can do this work, but the keyword over here is real time. right? You want the data to be in real time. So since the data has to be in real time, you will choose AWS Kinesis. CloudTrail cannot pass on logs for real-time analysis. Kinesis is specially built for this particular purpose, and hence for this particular question, the answer will be AWS Kinesis. Moving on, then our next question is, you have a standby RDS instance. Will it be in the same availability zone as your primary RDS instance? Okay. So the options are, it's only true for Amazon Aurora and Oracle RDS. Second option is yes. Third option is only if configured at launch. And the fourth option is no. Alright, so the right answer for this, I want you to think about it like this, that whenever you want a standby RDS instance, it will only be there when your RDS instance stops working. Now, what could be the reasons that your RDS instance could stop working? Probably it could be a machine failure, or it could be a power failure at your at the place where your server has been launched. It can also be probably a natural calamity which would have struck your data center where your server exists. So all of these could be reasons which could lead to disruption in your RDS service, right? Now, if your standby RDS instance is also in the same availability zone as your primary, these conditions cannot be tackled, or these situations cannot be tackled. All right. So it is always logical to have your standby machines in some other place, right? So that even if there is a natural calamity or if there is a power failure, your instance is always up and ready. And because of that, AWS does not give you the option of launching your standby RDS instance in the same availability zone. It always has to be in another availability zones. And that's why the answer is no. Your RDS instance will not be in the same availability zone as your primary instance. All right. So our next question is, you have a web application running on 6 Amazon EC2 instances, consuming about 45% of resources on each instance. You are using auto scaling to make sure that 6 instances are running at all times. The number of requests this application processes is consistent and does not experience spikes. All right. So the application is critical to your business and you want high availability at all times. You want the load to be distributed evenly between all instances, and you also want to use the Amazon AMI for all instances. Which of the following architectural choices should you make? Alright, so this is a very interesting question. So basically, you want to run 6 Amazon EC2 instances, and they should be highly available in nature, and they would be using an AMI, of course, because they are auto scaled. So which among the following would you choose? So you have the options: deploy 6 EC2 instances in one availability zone and ELB, deploy 3 EC2 servers in one region and 3 in another region and use ELB. You should deploy 3 EC2 on one AZ, that is availability zone, and 3 in another availability zone. And you should deploy 2 EC2 instances in 3 regions and use an Elastic Load Balancer. All right. Now, the correct answer for this would be C. The reason being that AMIs are not available across regions. Right? So if you have created an AMI in one region, it will not be automatically available in another region. You will have to do some changes and only then, or do some operations and only then it will be available in the another region. So this is reason number 1. So the region options mentioned over here get casted out because of this reason. Second, if you look at the first option, which says deploy 6 EC2 instances in one availability zone, that defeats the purpose of high availability, because like I said, if there is any natural calamity or a power failure at a data center, then all your instances will be down. So it's always advisable to have your servers distributed. But since we have that limitation of using an AMI, and therefore and also the limitation that it is not accessible across regions, we would choose distributing our instances among availability zones. And I'd say we just had the option of 2 availability zones, right? It could be 3 availability zones and we could deploy 2 servers in each and this would also amount to high availability. All right. And of course, because you want to load balance traffic, if you apply an ELB on top of 3 availability zones, it will work like a charm. Regions, across regions, it can become a problem, right? And but in availability zones, it definitely works and it will work perfectly. All right. So the answer for this question is you would be deploying EC2 instances among multiple availability zones in the same region across an ELB. All right. So our next question is, why do we use Elastic Cache and in what cases? All right. So the answer for this is basically related to the nature of the service of Elastic Cache. So Elastic Cache, as the name suggests, is basically a cache which can be accessed faster than your normal application. For example, if you talk about a database instance from which you are gathering information, right? If you're always dealing with the same kind of query, for example, you're always fetching the password for particular users, right? So if you're using an Elastic Cache, that data can be captured or can be cached inside Elastic Cache. And whenever a similar request comes in, which is asking for that kind of data, your MySQL instance will not be disturbed. The data will directly be relayed from Elastic Cache, and that is the exact use of Elastic Cache, right? So you use Elastic Cache when you want to increase the performance of your systems, right? Or whenever you have frequent reads of the similar data. So if you have frequent reads of similar data, you'll probably be querying the same kind of data every time, and basically that will increase the load on your database instance. But to avoid that, you can basically introduce an Elastic Cache layer between your database and your front-end application, and that would not only increase the performance but also decrease the load on your database instance, right? So this was all about performant architectures, guys. Our next domain would deal with secure application and their architecture. So let's go ahead and start with the first question of this domain, which talks about a customer wants to track access to their Amazon simple storage service buckets and also use this information for their internal security and access audits. Which of the following will meet the customer requirement? So basically you want to just track access to the S3 buckets. Now if you want to track access, let's see what are the options. So you can enable CloudTrail to audit all Amazon S3 buckets. You can enable server access logging for all required Amazon S3 buckets. Enable the requester page option to track access via AWS billing, or you can enable AWS S3 event notifications for put and post. All right. So I would say the answer is A. And reason being, why is the answer not B? Because server access logging is actually not required when you want to deal with tracking access to the objects present in the S3 bucket. Requester page option to access via AWS billing, again, it's not required because there's a very simple feature of CloudTrail which is available to all the buckets across S3. So why not use that? And using notifications for S3 will not be apt. Reason being, there will be a lot of operations that would be happening. So rather than sending notifications for each and every operations, it is better that we log those operations so that whatever information we want out of that log, we can take, and rest we can ignore, right? So the answer for this is Amazon using AWS CloudTrail. Okay. Our next question is, imagine if you have to give access of AWS to a data scientist in your company. The data scientist basically requires access to S3 and Amazon EMR. How would you solve this problem from the given set of options? Okay, so you basically want to give a particular services access to an employee, and we want to know how would we do that. Okay, so the options are we should give him credentials for root. Second option being create a user in IAM with a managed policy of EMR and S3 together. Create a user in IAM with managed policies of EMR and S3 separately. Give him credentials for admin account and enable MFA for additional security. Okay, so a rule of thumb, guys, never give root credentials to anyone in your company. Even yourself, you should never use root credentials. Always create a user for yourself and access AWS through that user. All right. This was point number one. Second, whenever you want to give permissions to services or permissions of particular services to people, you should always create or use policies that pre-exist in AWS, right? So when I say that, I basically mean never merge two policies. Okay, so for example, if you're using EMR and S3 together, that basically means that you create a policy that gives you the required access in one document. That is, in one document you mention the access for EMR, and in the same document you mention the access for S3 as well. Well, this is not suggested. Reason being, you have policies created by AWS, which are basically created and tested by AWS. So there is no chance of any leak in terms of security aspect. Second thing is, see, needs change, right? So if tomorrow your user says he doesn't want access for EMR anymore, he probably wants access for EC2. Right? So in that case, what will you do? If you had the policy in the same document, you would have to edit that document, correct? But if you created documents separately for each and every service, all you have to do is remove the document for EMR and add the document for the other service that he requires, probably EC2. You just add the document for EC2 and your S3 document will not be touched, right? So this is more easier to manage than to, writing everything in one document and editing the code later to give permissions of specific services that he requires now, right? So that is something that is not much manageable. So the answer for this is create a user in IAM with a managed policy of EMR and S3 separately. All right. Let's move on to the next question. So how would a system administrator add an additional layer of login security to a user's AWS management console? So this is a simple question. The answer for this is enable multi-factor authentication. So multi-factor authentication basically deals with rotating keys, that the keys are always rotating. So every 30 seconds, a new key is generated, and this key is required while you're logging in. So once you've entered your email and password, it will not straight away log you in. It will again give you a confirmation page for a code that you have to enter, which will be valid for those 30 seconds. Now this can be done using apps. So you have an app called, if you have an app from Google, you have apps from other third-party vendors as well, right? So these apps are basically compliant with your AWS, right? And you can use them to have access to the keys which are changed at every 30 seconds, all right? So it is better. If you want to enable multi-factor authentication, it is the best way of adding a security layer over the traditional username and password information that you enter. All right. So our next domain deals with cost optimized architectures. So let's discuss these questions as well. So our first question is, why is AWS more economical than traditional data centers for applications with varying compute workloads? All right, so let's read out the options. So we have Amazon Elastic Compute costs are billed on a monthly basis. Okay. Amazon EC2 costs are billed on an hourly basis, which is true. Amazon EC2 instances can be launched on demand when needed, true. Customers can permanently run enough instances to handle peak workloads. All right. So I'll say, because this question is talking about the economical value of AWS, option B and option C are correct. Reason being, you're charged according to the hour, and at the same time, you can have them on demand. If you don't need them after 2 hours, just pay for 2 hours, and then you don't have to worry about where that server went, right? So this is very economical as compared to the fact that when you buy servers and their need finishes, say after 1 or 2 years, when their hardware gets outdated, so it becomes a bad investment on your part, right? And that is the reason AWS is very much economical in terms of reason being that it charges you according to the hour and also gives you the opportunity of using servers on the basis of on-demand pricing. All right, so this would be the answer. So option B and option C would be the right answer for this particular question. Moving further, our question says you're launching an instance under the free tier usage from EMI having a snapshot size of 50 GB. How will you launch the instance under free usage tier? So the answer for this question is pretty simple. It is not possible, right? You have a limit on how much of snapshot size you can use that would fall under the free tier. 50 GB is not the size, is basically a size which will not fall under the Amazon free tier rules, and hence this is not possible. All right. Our next question says your company runs a multi-tier web application. The web application does video processing. There are two types of users which access this service: premium users and free edition users. The SLA for the premium users for the video processing is fixed, while for the free users it is indefinite, that is a maximum time limit of 48 hours. How would you propose the architecture for this application, keeping in mind cost efficiency? Alright, so to rephrase this question, basically you have an application which has two kinds of traffic. One is free traffic and one is premium traffic. The premium traffic has an SLA that the task should be completed in say 1 hour or 2 hours. The free traffic, they do not guarantee it when it will finish, and it has a maximum SLA of 48 hours. So if you were to optimize the architecture for this at the backend, how would you design the architecture that you get the maximum cost efficiency possible using this architecture? All right. So the way we can deal with it is there is a thing called spot instances in AWS, which basically deals with bidding. So you bid for AWS servers in the lowest price possible, and as long as the server prices are in the range that you specify, you have that instance for yourself. So all the free users who are coming to this website can be allotted to spot instances because there is no SLA. So even if the prices go high and the systems are not available, it does not matter, right? You can wait for the applications for processing if you're dealing with free users. But for premium users, since there is an SLA, you have to meet a particular deadline. I would say you use on-demand instances. They are a little expensive, but I think because premium users are paying for their membership, that should cover that part. And spot instances would be the cheapest option for people who are freeloaders or people who are coming free on your website, because they do not have any urgency of their work and hence can wait if required if the prices are too high for you. Alright, so our next domain will talk about operationally excellent architectures. So let's see what all questions are covered in this particular domain. Alright, so imagine that you have an AWS application which is monolithic in nature. So monolithic applications are basically which do not which have the whole code base in one single computer, right? So if that is the kind of application you're dealing with, it's called a monolithic application. Now this application requires 24/7 availability and can only be down for a maximum of 15 minutes. If had your application been not monolithic, I would say that there would be no downtime. But since it's a monolithic application, the question has mentioned, there is an expected downtime of say 15 minutes. How will you ensure that the database hosted on your EBS volume is backed up? Now, since it's a monolithic application, even the database resides on the same server as that of the application. So the question is, how will you ensure that your database is backed up in case there is an outage? So for this answer, I'll say the answer is pretty easy. You can schedule EBS snapshots for your EC2 instance at particular intervals of time, and these snapshots would basically act as a backup to your database instances which have been deployed on EC2. So hence the answer is EBS instance snapshots. Alright. Our next question is, which component of AWS global infrastructure does AWS CloudFront use to ensure low latency delivery? Now, AWS CloudFront is basically a content delivery network, which basically means if you are in the US and the application that you're accessing has servers in India, it will probably cache the application in a US server so that you can access that application faster than to send traffic packets over to India and then receiving them back. All right. So this is how CloudFront works. It basically caches the application to your nearest server, and so that you get the maximum the minimum latency possible. And it is possible using AWS edge locations. Okay, so edge locations are basically the servers that are located to near your place or near a particular availability zone, which basically cache the applications which are available in different regions or are at far places. Today in this session, we are going to discuss the top DevOps interview questions that can be asked to you in your next DevOps interview. Continuous development, and let's see what our first question is. So our first question asks us, can we explain the Git architecture? Now this is fairly an important question, reason being Only if you understand the underlying basics of how Git works, will you be able to troubleshoot a problem when you face it and when you are working in a company as a DevOps engineer. All right. So let us try to explain what Git basically is and how its architecture is. Now, most of you might know that Git is a distributed version control system. Now, what is a distributed version control system? Let us explain it using a diagram. In a distributed version control system, basically your repository is distributed among the people who are contributing to that repository, and that is why it is called distributed. So that means that anyone who wants to make a change in the code that is present in this repository has to first copy this repository on his local system, commit the changes to the local file system of this repository, and only then he can push this repository onto push the code changes or the feature additions and everything to the remote repository, right? Nobody can work directly on the remote repository, and this is the main principle of how Git works, and that is the reason it is called a distributed version control system. Right? If you were to talk about the life cycle as to what are the steps to implement if somebody wants to say upload or change some code present in our remote repository. So the first thing that they have to do is pull the repository from the remote system. Once they have pulled the repository, it becomes their local repository. Change whatever files they want to change, and then once they have done with the changes, they will have to do a git commit, or they'll have to commit the files to the local repository. Once the files have been committed, they will have to be pushed to the remote repository so that it becomes visible to anyone and everyone who will pull this project the next time. All right. And this is how the whole Git architecture works. Now, I hope you guys understand what is the working of Git and what exactly is the architecture of Git. Moving forward, now let's talk about the next question, which says in Git, how can you revert a commit that has already been pushed and made public, right? So basically you have done some changes in the code, you committed those changes to your local repository, and now you have also pushed the changes to the GitHub repository. Now, if you have a CI/CD pipeline in place, which basically means that the moment you commit to Git, it automatically takes the code and deploys it on a server. If that is the kind of configuration that you have done, then probably the code that you have pushed has also been deployed on a server. And that is when you come to sense that the code is wrong, and you quickly have to change the code so that everything becomes working again. Right now, this is a very hot fix, or this is a very quick fix that probably every DevOps engineer employs whenever there is a problem in the production server, right? So what is that quick fix? The quick fix basically says that whatever last commit was working perfectly, just roll back to that so that everything becomes normal until and unless you have fixed the new commit. That is basically the intention behind the revert procedure. Now, how can you implement the revert procedure? It can be implemented using the git revert command, and let me show you a quick demo of the git revert command so you know how you can implement it in a computer. All right. So this is my terminal, guys. Basically, I will SSH into an AWS server, and I'm in. So I have a GitHub repository that I have created for demo purposes. So like we discussed, the first stage in the lifecycle of Git is to clone the repository. So we'll just copy this address. So we'll just copy this address. 1 second. Yes. So we'll just copy this address, and then we'll come here and we'll type git clone and then the address. Okay. Now this project is basically a website that I created. It's a small website that I created. Now, in order to see that website, we will have to paste this code inside our Apache folder. So let us go inside our Apache folder, which is present in this directory. All right. Now I'll do a quick git clone along with the repository address, hit enter. And now if I do an ls, you can see that there is a folder called DevOps IQ, which has been created inside this folder. I will go inside DevOps IQ and do an ls. And you can see there's one more folder called DevOps IQ. All right, so let's go inside that. And now if I do an ls, these are the two files which are present inside my code base. Okay. Now, if you were to see what this website actually looks like right now, I can just go here and I can type in the IP address. So it's 18.222.123.58/DevOps IQ and /DevOps IQ. All right, this is how the website looks like for now. Now I have to make some changes so that the background becomes a little more better. So what I can do, I'll just go back here. I'll go do a nano and change the code of the website and say I'll change it to, I have an image in the images folder. Let me change it to 1.jpg. All right, let us save it. And once you've saved it, the next thing that you have to do is commit the changes to your local repository. And let us do that. So first I'll have to add the files to the repository. Now I'll have to commit the changes. And the message should say changed background. All right. So the changes have been committed, and now I'll push these changes to the remote repository. So it's HSHAR and the password is this. Now before making these changes, let me quickly show you the code that you are currently going to see before I push anything on this repository. So can you see the code is images/2.jpeg. I've changed the code to be 1.jpeg. So let me hit enter and let's see if our code gets changed over here. So now if I do a refresh, let me do a refresh. You can see the code has been changed just now. So it says 44 seconds ago, the code was changed. Awesome. So now because my code has been changed, if I go to this website now and hit enter, you can see the background is now changed. It is now a different background. Now what I want to do is I realize that this change that I did is probably wrong, and I want to revert to a particular commit, to the older commit that was actually working. All right. So what I can do is I'll just come back to my terminal. Let me clear the screen. First thing that you do is do a git log. So now you get a log of all the commits that you have made to this particular repository. Now this is the particular commit that you have particularly applied right now, and this is causing you a problem. So just copy the commit ID for this, and now just go ahead and do a git revert. So git revert and then give this ID which you just copied. Okay, and hit enter. So once you do that, it will tell you the information about this particular commit ID, right? So just review everything, and then you can see that the commit has been reverted. So now I have not pushed the changes, but then if I come back here and if I hit enter, you can see the older website comes back because the code has now been changed. And if I want to make these changes to the remote repository as well, all I have to do is git push origin master, and it'll ask me the credentials, and the changes have been pushed. Right now if I come here and I just see the code again, if I do a refresh, you can again see that the code has changed back to 2.jpeg, which was our earlier code which we made changes to. All right, so guys, this is how you can do a revert on basically a commit and a push that you have made to your remote repository as well, right? So if you encounter any problem during working while working as a DevOps engineer, you should remember this session where I taught you how to revert a particular commit. All right, so with that, let's move on to our next question, which says, have you ever encountered failed deployments and how have you handled them? Now see, any DevOps engineer in the world will have faced a problem in which, probably the things that he had planned, the things didn't go according to his plan, right? That absolutely happens. And if somebody is asking you in a DevOps interview, have you committed mistakes? So you should, just to impress them, probably never say yes, right? So if you have never committed mistakes, that's awesome, right? But then I know that every engineer or every DevOps engineer who has worked in the industry would have faced a problem while working and would basically account to a mistake that he made while deploying things. All right. Now, the important thing or the important key takeaway from this kind of a learning should be that whatever mistake you make, you learn from it, right? And you never commit it again. And that is basically the intent behind this question as well. The interviewer would want to know, if you made the mistakes, what did you learn from those mistakes? Okay, so if an interviewer was supposed to ask me this question, I'll say, obviously I have encountered failed deployments, and what have I learned from them? I'll just give you the best practices that I think are viable for any DevOps engineer who is working in the industry. So the first thing that everyone should follow and should make it a thumb rule is that you should automate code testing. Not only does it save time, because now your tester does not have to wait for your developer to basically push the code and then check it. The developer can check it in real time because you have written a script for his application, and all the major tests which are to be done, which are pretty common, can be done using automated code testing, right? Now, like I said, it's not only for time saving, but also it removes the part where a human error can occur, right? So if you are working, when you work with people commit mistakes. But if you can write a code which will basically test each and every functionality, that code will never make a mistake. And that is why you should always automate things as far as possible, right? So like in my example, what happened was that there was basically a commit to the repository, which was basically a feature addition, right? And the tester did not see all the functionalities, or forgot to see some of the functionalities that could impact the other components of my product. And because of that, when it got pushed onto production, basically a disaster happened. Everything stopped working, right? And that was only because the testing did not happen properly, right? So for all the critical processes of your website or your product, you can basically create a code which will test that website. And basically that would basically close down most of the doors to mistakes. All right. The next thing is you should always use Docker for same environment, right? And this is basically the ideology behind DevOps, that these kind of problems where a developer used to work and the tester could not run his code on his computer, but the developer said that everything is working fine on his system. Docker basically solves that problem, right? So use Docker as much as you can for the same environment problem that you might face. Then we should always use microservices. Now, when you are working in a company, it could be that the product is in the legacy phase and hence it's on a monolith kind of a thing, but you should never encourage this kind of an architecture, right? Reason being, say you did a bad commit or you did a bad push on the production server, but it should not impact the other components of your product, right? If probably you have done something to search, and if it's a bad commit or a bad push, the only functionality that should be impacted should be your search functionality and not the other functionalities. And that is the sole reason behind why we should use microservices. That is, we should divide our application into different small products which we would deploy on servers, and these products should be independent of each other. When we talk about the monolithic architecture, all these components are coinciding with each other, have the dependency upon each other. But when you talk about a microservices kind of an architecture, you remove that dependency so as to, even if one component fails, it does not impact the whole application. Fourth point being, you should always overcome risks to avoid failures. Now, this basically means that if there is a code change, or if there is a feature addition which works sometimes and sometimes it does not, and you're not able to figure out why is exactly that thing happening, it is better to wait and troubleshoot it than to push it just to meet your dates, right? Because the latter can cause you a big problem in production when you're in a company like probably like Airtel, or in a company like Samsung or Ericsson, where their products, each second of their website's uptime brings in money, right? So if your website is down for 30 seconds, that could amount to a huge loss, and that would be on you, right? So for you to not face that kind of a situation, always be 100% sure before you make a change or a release onto the production server. All right, so this is the end to the domain of continuous development. Let's go ahead and now talk about virtualization and containerization. All right, so let's start with the first question of this domain, which says, what is the difference between virtualization and containerization? Now, this is a very important question, guys, because most of us get confused between virtualization and containerization. So let's see what are the differences between these two things. So virtualization is nothing but installing a new piece of operating system on top of a virtualized hardware. What does that mean? So basically there are softwares like hypervisor or any other software which specializes in virtualizing hardware. So if you have a server which has around 64 gigs of RAM and 1000 TB of hard disk space, with a software like hypervisor, what you can do is you can take that space and divide it among multiple operating systems, right? You can deploy multiple operating systems on the same hardware by virtualizing the hardware so as to the operating system will feel that, say, if you virtualize 1 GB of RAM from this whole system and say around 100 GB of storage, the operating system will think that, you know, it only has 1 GB and 1 GB of RAM and 100 GB of storage space available to it. It cannot go beyond that. Reason being, it does not know of the hardware which is beyond, or which is ahead of the hypervisor software. All right. So in virtualization, basically you have an hypervisor which is on top of your, which sits on top of your operating system and virtualizes the hardware beneath it, right? Then you have a guest operating system. So basically once you've virtualized the hardware, you install guest operating systems on top of that. For example, the best example for this would be VirtualBox, right? You install VirtualBox and then you can install operating systems on the VirtualBox with a given spec that you will decide, right? And once you've installed the guest operating systems, on top of that, there would be the binaries or the libraries that you probably would be downloading or that came with the operating system. And on top of that, you have the applications which would be running, right? So the key takeaway from virtualization should be that it's the whole operating system is installed from the kernel level to the application level. Everything is fresh, everything is new. Now let's talk about containerization. So the thing in containerization is that the host, on top of host operating system, you install a software called the container engine. Now the container engine is just like any other software, like you have an hypervisor, you have a container engine. Now the container engine does not encourage installing a whole operating system. For example, if you want to run a container for Ubuntu on, say, a Mac machine, you can do that, right? But it will basically, in that container, you will have basically the bare minimum libraries that amount to become the Ubuntu operating system minus the kernel, right? So in a container, you do not have a kernel. The kernel is always used of the host operating system. And this is the main difference between virtualization and containerization, that in virtualization, you have a separate kernel present of the virtual operating system. But in containerization, you do not have that. And that is the reason the containers are very small. They have the bare minimum libraries required for that container to behave as a particular operating system, but the container itself does not contain any operating system. It basically is based on the same kernel on which the host operating system resides. All right, and this is basically the main difference between virtualization and containerization. Intellipaat, basically the company that we work for, is an e-learning company, and we basically researched a lot of job descriptions, and what we came up with was this Cloud and DevOps Architect Masters course. Now in this, we have put down all the skills from all the job descriptions that we have got, for cloud related jobs. And also we are in touch with, since we are with a training company, all our instructors are basically working professionals. So we have got in touch with top cloud and DevOps professionals and asked them what are the relevant skills that you think are expected from a cloud engineer, person who is basically appearing for an interview. So based on what the feedback that we got from our instructors, based on the feedback we did from our research, we have come up with this course. And these are the things, or these are the skills that we teach to a person when we take him basically on board with us in the Cloud and DevOps Architect Masters course. Moving forward, now the next question says, without using Docker, that is without using Docker to get into a container, can we see the processes that are running inside the container of the Docker container engine? All right. So this basically is relating to the same fact that if you want to see the processes of a container which are running inside the Docker container engine, if you can see them from the outside, basically that means that the processes are running in the same kernel of the host operating system. Right? The processes that are running in the Docker container engine would be basically as an addition to whatever is running on the host operating system as well. And you can see that using the ps-aux command. Right? So for the host operating system, it's just like any other software or any other process that it has to run. But for the container, it basically thinks that it is running inside an operating system, which it actually is not. Right? So can you see the processes? So the answer is yes, you can see the processes which are running inside a Docker container. And how can you see that? How can you basically see these processes? Let me demonstrate it to you. Okay. So we have come back to our AWS server. Let me clear the screen. All right. So if I do a Docker PS right now, you can see that there are no containers which are running on this system as of now. Now what I'll do is I'll run a container for Ubuntu. So I'll do a Docker run -it and then -d and then Ubuntu. All right, so this ran a container for me. And if I do a Docker PS now, you can see that there's a container running, which is basically of the Ubuntu image. So if I go inside this container now, so I'll do a Docker exec -it and then bash. Docker exec -it and then sorry, I forgot the container ID. So the container ID and then bash. So if I do that, I'm inside the container, right? And there's no process running inside this container as of now. Now, if I were to duplicate this, let me quickly again do an SSH. So I'll do an SSH into the same server again so that I'm on $. Okay, great. So if I do a ps-aux, these are all the processes which are running inside the operating system right now, right? But let us make it a little simpler. What we can do is, let me see all the processes which has the word watch in them, right? So let me make it more clear for you. So these are the processes which have the watch keyword inside of them. Okay, so there are basically 4 processes which are running and which have the keyword watch inside of them. Now what I'm going to do is, inside this container, I'm going to launch a watch process. So what is that watch process? That watch process is basically going to watch a particular command in a set interval of time. And what is that command? I basically want to say, let's see the ls-l command. Okay, so what is it doing? It is keeping a watch on the command ls-l in every 1 second, right? You can see the time over here. It is incrementing every second, and basically it's keeping a watch on all these files which are there inside the container continuously. Okay, now again, so this is the dollar prompt. That we are outside the container right now. Now if I again do the same command, that is again I search for processes which have the word watch in it, I can actually see that there is a new process which is running over here, and this process is running inside the container, which I'm able to see from the host operating system level, right? So the host operating system is basically treating this particular process as if it was running on its own system. That is, the container and the host operating system, because they are sharing the same kernel, the host operating system is taking this process as if it was running inside of it, right? But if we look closely, this watch command is running inside the container, right? Let me just quickly stop it. You can see we are still inside the container, and we have stopped the watch command. And if I go here and if I refresh, you can see that this watch command is again gone, which was being mentioned over here before. And this is exactly what we wanted. We basically wanted to see a process which was running inside a container from outside the container, that is from the host operating system, and that is exactly what we just did. All right. So the question that without using Docker, can you see the processes that are running inside a container? So the answer is yes, you can do it. All right. So the next question is, what is a Docker file used for? What do you basically use a Docker file for? So a Docker file is nothing but it's basically a text document to create an image using an older image and adding some files into it. All right. So it's basically like a script that you run in Linux, which can do all the things for you that are required. For example, I might need an Apache image, and I want my website to be put inside the var/www/html folder inside this particular Apache container. Now, in order to do that, if I were to do it without a Docker file, I would have to first download the Apache image. So I would probably type docker run -it-id and then Apache. Once I've done that, I will exec into the container and then go to the directory called var www.html. Probably I'll do a git clone of the website that I want, and then my website will be available in that container, and hence I'll be able to use it, right? This is one way. Second way is I can create a Docker file which will basically build this image for me without me having to do all these things, all these manual things which I just told you. All right. So let's see how we can do that. So let me just exit this container and let me remove the container which are just running inside my system right now. Okay. So if I do a docker ps now, it's clean. Now what I want to do is I want to run this particular container, docker run -it-p. I want to basically expose the port 83 to this container's port 80, and I want to run it as a daemon so that it runs in the background, and that is it. Okay, so I have the container running, which is this. And what I want to do is I want to basically copy the website into this container. So let me do a docker exec into this container -it. This is the container ID, and then container ID and then bash. So I want to go inside this particular folder. So if I do an ls over here, you can see that there is an index.html and an index.php which are running, right? So it's on exposed on port 83, which basically means if I go to a browser and if I go to the server's IP address on port 83, I should be able to see this Apache page, and this is basically the container which I just ran over here. Okay, what I want to do is inside this particular directory, I would be basically copying the code of my website. Now let's see how we can do that. So let me just exit this container. Let me do a docker ps. Let me do a docker stop to this particular container. So what would this do? So basically if my Apache was running over here, it should stop once I have stopped this container. Okay, so it is stopped. So if I do a refresh over here, you can see the site can't be reached. This is exactly what we want. Okay, now let me do a git clone of my GitHub. I'll do a git clone. All right. Awesome. Now I'll go inside this folder, and basically I want to copy this particular folder inside the container. All right. So for doing that, let's create a Docker file. And what I want to say is in the image shhar/web app, I want to add the folder DevOps IQ. And where do I want to add it? Inside the container, I want to add it in this particular directory. Okay. This is where I want to add it. And inside DevOps IQ. Okay, fair enough. And that is it. That is all you have to do. I'll just come out of this editor and I'll now do a Docker build of this Docker file with the name test. So it says successfully built an image and it has been tagged as test. Great. Now if I run this image now, docker run -it -p, say I run it on port 84, run it as a daemon and run the image. Okay, great. So if I go to port 84 now, let's see if the container is working first. So yes, the container is working. Now if I go inside DevOps IQ, what do I see? Great. So I can see the web. So basically my website is now available inside the container by simply writing a Docker file to do that. And this is exactly what we wanted. Awesome, guys. So what is the Docker file used for? It is basically used for creating an image without having to do all the manual stuff of adding your files and everything. All right. Now, once this image of yours is ready, you can push it to Docker Hub and anybody in the world can download it and can basically use your website on their local system. Great. Now, the next question is explain container orchestration. Okay, so till now we have seen that, we can deploy a container, we can use it, we can probably deploy an application on it, and we can use it on the web browser, right? But it is not that simple. When we talk about a website like Amazon or a website like Google, right? It has a lot of components with it. For example, on Amazon, you would see that you have a comment section. Then on the home page, you see that there are a lot of products which have the prices, the ratings. Now, each and every component, the prices, the ratings, the name of the product, the image of the product, the comment section, each and everything is basically a microservice. It is a small part of an application which is running independently of all the other parts of the website, right? And all of this is possible using containers. So basically what they would have done is they would have ran each and every component inside a container. Now, the problem over here is, now when you have a website like Amazon, you would be dealing like you would be dealing with minimum like 10 or 11 containers for one particular copy of that website or one particular instance of that website, right? Now, when you're dealing with 10, 11 containers, these containers have to be working in conjunction to each other. They should be in sync with each other. They should be able to communicate with each other, right? And they should also be able we should also be able to scale a particular container in case it goes down. For example, the comment section container, it goes down for some reason. Now, if it goes down, we have to keep a watch on it and we have to redeploy it if it goes down. And all of these activities, which I just told you, comes under container orchestration, right? If you were to manually deploy these containers on Docker, you will have to keep a manual check on all these containers. But imagine when you have thousands or 10,000s of containers that you're dealing with. In those kind of scenarios, you need container orchestration. Now, container orchestration can be done using various softwares. So you have a software called Kubernetes, and before that there was a software called Docker Swarm, which basically made our life easier by doing all the manual work for us. That is, it will check the container's health. It could scale them in case they become unhealthy. They could always also notify the administrators by an email in case something happens, right? They can also run a monitoring software for you, which basically gives you a report or the health status of all the containers which are running inside that software. So this is a very small part of what a container orchestration tool can do, right? And basically, if you were to understand what container orchestration is like I said, when you work with multiple containers, you have to take in note a lot of things, and that is possible using the container orchestration tools like Kubernetes and Docker Swarm. Okay, so the next question is, what is the difference between Docker Swarm and Kubernetes? Now, they're both container orchestration tools. We just saw that. But why do we have two? Or if I were to choose between Kubernetes and Docker Swarm, which should I choose? All right, so let's look at the differences between each one of them. So the first difference, which is probably the most important difference, or probably I'll say is the deciding factor whether you should go ahead with this tool given that you have a short deadline and you have to deploy a project. So installing Docker Swarm is very easy. It comes pre-packaged with the Docker software. So if you have installed Docker Swarm is already installed on your system. You don't have to worry about anything. On the other hand, installing Kubernetes is a very tough job, right? There are a lot of dependencies for Kubernetes. You'll have to see the system. You'll have to see the operating system on which it is running and a host of other things, right? It has a lot of dependencies and hence it is very tough to install. But the moment you install it, it becomes very helpful. That is, Kubernetes becomes very helpful because of the features that it offers, which brings us to our second point. Docker Swarm is faster than Kubernetes, reason being that it has less features than Kubernetes and therefore making it a very light software and hence faster than Kubernetes. So if you want to use Docker Swarm, you should be reading about what Docker Swarm does not offer and what Kubernetes offers. And if you feel you do not need all the features that Kubernetes is offering, you can go ahead with Docker Swarm and deploy your application in a faster manner. But like I said, Kubernetes is complex and it has a lot of services and features, because of which its deployments are a little slower when we compare it to Docker Swarm. The third point, which is the most important point, is Docker Swarm does not give you the functionality of auto scaling. Meaning if your containers go down or if your containers are basically performing at their peak capacity, there is no option in Docker Swarm to scale those containers. On the other hand, because of Kubernetes monitoring services and the host of other features, you have that option of providing auto scaling to your containers, which basically means you can automatically scale your containers up and down as and when they are required. And this is an amazing thing that Kubernetes handles for us. All right, guys, so these were the questions around the domain virtualization and containerization. So moving ahead, now our next domain is continuous integration. So let's shed a light on what continuous integration is. So our first question itself is, what is continuous integration? So continuous integration is basically a development practice, or I'll say it's a stage which basically connects all the other stages of the DevOps lifecycle. For example, you push your code to Git, like we took that example. When you push the code to Git, you might have provisions which might allow you that the moment the code is pushed onto the remote repository, it automatically gets deployed on the servers as well. Well, if that is the case, basically that would be possible using integration tools that would integrate your Git repository with your remote server. And that is exactly what Jenkins runs. It's a continuous integration tool which helps us integrate different DevOps lifecycle stages together so that they work like an organism, right? This is what continuous integration means. So, because we discussed about what continuous integration is, our next question says, create a CI/CD pipeline using Git and Jenkins to deploy a website on every commit on the main branch. So on every push that you make to the remote repository, the code should automatically get deployed on a remote server. All right. So this is something that we're going to do just now. All right, but before going ahead, let's see what is the architecture for this kind of a thing. All right, so this is how the whole thing is going to work. Basically, the developer is going to commit the code to his GitHub. GitHub basically, once it sees a change in the branch that we mentioned, it is going to trigger Jenkins, which in turn will integrate or will take the website from the GitHub repository and push it onto the build server on which we want the website to be deployed. All right, sounds awesome. Great. Now let's go ahead and do this demo. So for that, we will have to SSH into our server. So let us do that. Okay, so I'm in now. Let me clear the screen. So first let's check if our Jenkins is running on this server. So let me check the status for Jenkins. So if I do a service Jenkins status, I can see that the Jenkins service is active. Awesome. So I'll just go here and I'll go to the Jenkins website, which is basically available on 8080. All right. So I'll enter my credentials. And this is how the dashboard for Jenkins looks like. Now our question is, or our aim is to create a job which basically will push a website that we are uploading to GitHub on a particular server. All right, so let's create a new job first. So let's call our job as a demo job. Okay, and let's name it as a freestyle project and click OK. So this will create a job in Jenkins for us. All right, so our job has now been created. So what we want to do is I want to take code from my GitHub. So I'll have to specify the GitHub repository over here. Okay. And similarly, I'll have to say that I want to trigger the build the moment anything is pushed on my remote repository. All right, and this should be it. Great. So I mentioned that anything that is pushed onto my master should trigger a build on Jenkins. Okay, and what should this build, or what set of commands do I want to run? once build is triggered. So first I want to remove all the containers which are running inside my system. So I want to clean up, right? So for that, I'll say sudo docker rm-f, then a $. This basically is going to clean all the containers which are running currently in the system. Once this is done, I want to build my website, which is going, or build my container, which is going to have my website. All right, now how can we do that? For that, I'll have to push the code to my GitHub, which will have the Docker file as well. Okay, so we created a Docker file inside. Okay, so here it is. So we have our Docker file created in the DevOps IQ folder, which was there in my home directory. Now what I want to do is I want to push. So what is there inside this Docker file? We saw that we could create a Docker file using if we write something like this in our Docker file, and this would basically create an image with our code which is there on GitHub. All right, so what we'll do, we'll just push this code to our remote repository. And let's add the message that we have ordered a Docker file. Great. And now let's push it to our remote repo. Great. So it has been pushed to my remote repo. And now if I just go here and check if my changes have been done or not, let me just quickly refresh it. So yes, I have a Docker file in my Git repository right now, which was committed 42 seconds ago. Awesome. Great. So now what I'll do is I'll come to my Jenkins and I will say that build sudo docker build the Docker file. Now where is that Docker file? The Docker file will basically be downloaded in the Jenkins workspace. So that is in var lib Jenkins workspace, and then the name of the job, which is demo job, and that is it. So inside this I will have my Docker file, and it will basically build it and name it as, say, Jenkins. It'll name it as Jenkins. In the next step, what I'll do a sudo docker run -it and then -p and say I want to deploy it on 84 or say 87 port. Okay, and what do I want to deploy? I want to deploy Jenkins. Okay, so this should do this should basically do all the stuff. So in the first command, basically we're removing any container which is running on the system. In the second command, what we're going to do is we're going to build the Docker file which is available in this workspace, and this workspace will basically have my GitHub project and the link I have specified over here. So it'll basically just copy, or it'll pull the project and save it in the workspace of demo job. So in this demo job, there's a Docker file. So we are building this Docker file and we're naming this created image as Jenkins. And then we are running this image and exposing it to port 87. Okay, so let's save it. Awesome. Now what we have to do is I'll have to go inside. So if you want to configure a webhook, the way to do that, when I say a webhook, basically you want your GitHub to interact with your Jenkins whenever there is a push to a particular repository. So in your repository, go to settings and then go to webhooks. So this is a webhook that I created for my Jenkins, right? So let me create it again for you. So all you have to do is click on add webhook, right? And enter the URL for your Jenkins over here. So in my case, it is this. I'll just enter it over here, followed by this keyword, which is GitHub hyphen webhook. And that is it. Once you specify that, just go down, click on add webhook. And this should basically send a request to Jenkins. And if everything goes well, it will say last delivery was successful. Okay. So any changes that I make to my GitHub now should trigger a change over here. Now let me delete this job, because I think even this job gets triggered when my GitHub, any changes made to my GitHub, right? So let me delete this project. Okay, great. So I just have this job now. Awesome. Now let us see how it actually works. So what I want to do is I'll come back to my terminal, do an ls, and let me go inside DevOps IQ, and let me do some changes in the code. So let's say I go into nanoindex.html. So the first thing that I do is I change the title of the website. So I call it as Jenkins test website. Okay. And I change the image from 2 to 1.jpg, and that is it. Let us see if I just push, or if I just push this website onto my server, what will happen. So I'll do a git push. Sorry, first I'll have to add these changed files into my repository. Git push origin master, sorry, git commit, and let me label this commit as test push. Okay, done. Now let's push this to our remote repository. Git push origin master, and let's give the credentials. Awesome. Now if you wait here, it should basically start a job. So as you can see, there is a job queued, which is for demo job, and this got automatically triggered by my GitHub. Okay, so let me refresh this. Okay, so the moment it gives you a red, that basically means that your job has been failed. So let's see what had just happened, why our job got failed. So if you go here, you can see the console output just like this. Okay, so basically we forgot to add a sudo here, and that is causing us a problem. Okay, so we can fix this by just going down and adding a sudo here. Save it, and again we'll have to change the code. Let's call it as Jenkins test 2 website. We'll do a control X, Y, and now let's add our files to our local repository. Git add. Now let's commit it. Test push 2, and now let's push this to our master. I'll enter the credentials, and this should be it. Okay, so let's see. So our second job got triggered automatically, and it gives us a blue. Now blue means that your job was executed successfully. So let's check what happened. So we were deploying it on port 85. So let's check if it has been indeed deployed. So it was on port 85, and the folder was DevOps IQ. Okay, so let's check. I'm not sure if it was port 85. Let's check. What are the port that we have specified? So the port is 87. Okay, so let's go to port 87. Okay, so it's giving an error saying unsafe port. So for our troubleshooting, let's check if the container is running. So yes, the container is running on port 87, but it says an unsafe port. So what we can do is, let us change it to say 82. And now let's just try to build the job from here. We'll just click on build now. Job has been completed and the port was 82. Yes, so Apache is working. Now let's try going inside DevOps IQ folder. And there you go. You have your website with this title which you pushed on GitHub. Now for one more time, for testing purposes, let us push our code once more and see what happens. So I'll say that this website is test3 website, and say I'll change the image as well to 2.jpeg. Okay, save it, do a git add, do a commit, and say call it test push 3. And now let's git push origin master, enter the credentials, great. Now let's check what will happen. Okay, so our build has been started and it has been completed. Great. So if I refresh this now, it says Jenkins test 3 website, and the background also has been changed. So congratulations guys, we have successfully completed the demo. So basically if you change anything in your GitHub, the website is automatically getting deployed on your build server, right? And on top of this, just for making it more interesting, what we can do is we can do a git log and we can revert on this commit that we saw earlier. Okay, so let's do a git revert and then paste it, agree to everything, and then push to master, enter the credentials, everything has been pushed, job is getting triggered, job is completed, and if I go here again, my website got reverted to a particular previous version. Awesome guys, so we have completed the demo, which basically asked us to create a CI/CD pipeline using Git and Jenkins to deploy a website on every commit on the main branch. So we have done it successfully. Awesome. Let's move on to our next domain, which talks about configuration management and continuous monitoring. Awesome. So what is configuration management and what is continuous monitoring? Let's understand it. So what is the difference between Ansible, Chef, and Puppet? Now, before understanding the difference between Ansible, Chef, and Puppet, these are basically configuration management tools. What is configuration management? If you have say around 200 servers and you want to install a particular software on each of these servers, what will you do? One way what you can do is you can basically go to each and every of these servers, run a script, and that basically will install software on that on these servers, right? The other way to do it is install a configuration management software using which you can deploy or you can install all these softwares, or you can control the configuration of all these servers from one central place. And that is exactly what configuration management means, right? Now, in configuration management, you have many tools like Ansible, Chef, Puppet, etc. But these are the 3 top tools which are used in the industry. Now, the question is, what is the difference between Ansible, Chef, and Puppet? All right, so let's go ahead and see the differences. All right, so let's first talk about Ansible. So Ansible is very easy to learn because it is based on Python. So you don't have to sweat a lot, or you don't have to sweat much on learning the commands for Ansible because it is based on Python. So if you know Python, Ansible is going to be a cakewalk for you. It is preferred for environments which are designed to scale rapidly. Basically, with Ansible, the thing is that you don't have to install the Ansible client software on the systems on which you want to basically deploy the configuration. Ansible just has to be installed on the master, and that is it. No other configuration required. You can directly control the configuration of the client server given you have the access to it. So it offers simplified orchestration, reason being, like I just told you, that you don't have to worry about installing softwares on the client machines. Ansible can standalone take care of all the complications that come forward when you are dealing with deploying configurations without installing a particular software on the client machines. But this is basically a disadvantage of Ansible, that it has a very underdeveloped GUI. That is, you only get the CLI to work with, right? And it has very limited features when we compare it with Puppet and Chef. Now let's talk about Chef. How is Chef different from Ansible? So it is Ruby based, and hence it's difficult to learn. Now Ruby is a language that not many people are acquainted with, and hence people might find it difficult to get versed with the commands of Chef. The initial setup is complicated. When I compare it with Ansible, the setup was very easy because I just had to install Ansible on the host machine, and on the client machine I didn't have to install any software. So, but with Chef you have to do that, and hence it becomes a little complicated. But once all the setup and everything is done, Chef is very stable, right? It has been, since it's a community product and it has been well contributed to, it's a very stable product and it offers you resiliency. So of course, when you're working on production servers, probably working on Chef would be a better idea than Ansible, because Ansible does not have that great community when you compare it with Chef. And of course, Chef is the most flexible solutions for OS and middleware management. Now, middleware basically means the software management part. Chef offers to be a great choice for configuration management, reason being it is very reliable and is very mature, because it was probably among the first configuration management tools to come out. And because community has contributed a lot to this project, it is very mature in its development stages as well. Now let's talk about Puppet. So Puppet can be tough for people who are beginners in the DevOps world, right? Because it uses its own language called Puppet DSL, right? The setup part is smooth when you compare it with Chef, but it's a little harder than Ansible, because when you're using Puppet, we use a master and an agent as well. So you will have to install Puppet agent on the client machine, and only then Puppet will be able to interact with the client software, right? Now it has a strong support for automation. So if you're planning to do some configuration management that you want to automate, Puppet is very compliant in that part. You can easily do the automation part using Puppet, and it is not suitable for scaling any deployment. So if you have say around 50 or 60 servers and you plan to add more in the future, probably Puppet would not be the right choice for that kind of an architecture. It is good to have when you have a stable infrastructure where you're probably not adding servers now and then. But if you are working on cloud and you do not know the capacity that you would be running, probably Puppet would not be a good idea to manage your configuration on your clients. Okay. Our next question is, what is the difference between asset management and configuration management? So asset management basically deals with resources. It deals with hardware, which we'll have to plan so that our IT workforce can work with maximum efficiency, right? So we'll have to plan the planning of your hardware, of how many resources a particular team might need. Giving the right resources to the right people is what asset management counts in. When we talk about configuration management, it basically employs not the hardware but the software component of what all softwares are required by a particular employee of a team or a particular person in the team, what softwares are required by that person, and for other person what software is required. I mean, rather than taking the radical approach of installing every software in every machine, which should not be done because some softwares are licensed. So configuration management basically means installing the right software on the right system on which a particular person or on which a particular workload is going to run. So our next question is, what are NRPE plugins in Nagios? Okay, so NRPE plugins are basically extensions to Nagios which help you monitor the local resources of the client machines, right? So you don't have to SSH into the client machines to see how much of memory or how much of CPU is being used. Nagios being a monitoring tool, you just have to install the NRPE extension on the client machine and it will give you a real-time data of the resources that are being consumed on that particular client machine. And obviously, when you're working in production environment, you will be monitoring multiple machines, and with NRPE plugins installed on each of those machines, you can easily monitor the resources of them at one central place. And that is exactly what NRPE plugin is. Intellipaat, basically the company that we work for, is an e-learning company. And we basically researched a lot of job descriptions. And what we came up with was this Cloud and DevOps Architect Masters course. Now in this, we have put down all the skills from all the job descriptions that we have got, for cloud related jobs. And also we are in touch with, since we are a training company, all our instructors are basically working professionals. So we have got in touch with top cloud and DevOps professionals and asked them what are the relevant skills that you think are expected from a cloud engineer, person who is basically appearing for an interview. So based on what the feedback that we got from our instructors, based on the feedback we did from our research, we have come up with this course. And these are the things, these are the skills that we teach to a person when we take him basically on board with us in the Cloud and DevOps Architect Masters course. Our next question is, what is the difference between an active check and a passive check in Nagios? Okay, so in Nagios, if the data, the monitoring log that you're getting from your clients, if it's being delivered by a Nagios agent, in that case, it is called an active check. Reason being, Nagios is actively involved in taking all the data or in collecting all the data from your clients. But in case when you're dealing with systems wherein it does not allow you to install any other software, or probably the software itself can generate monitoring logs, in those cases what happens is rather than Nagios, the software component pushes the logs to the Nagios master, where it can take the logs and probably create a graph or create the metric for you in the dashboard. So basically, using those logs which are being published by some other software, Nagios will create a report of the health monitoring part of your client systems, right? And that is why it is called a passive check. Reason being, Nagios is not involved on the client side at all. It is basically the software's own services which are basically pushing the log to Nagios master, and hence it's called a passive check. All right. But if you talk about the architecture or the working or the life cycle of how this actually works, on the master itself, the logs which are published are actually published to a queue, right? And whether it's an active check or a passive check, the logs have to be published to that queue so that the Nagios master can pick them up and create the monitoring metric which is required. All right. So in a passive check and in an active check, the queue is going to be there, but it's the only difference between the agents. That is, in an active check, the Nagios agents are involved, but in a passive check, third-party software tools are involved, which publish the log to the Nagios master. All right. So our next question says, create an Ansible playbook to deploy Apache on a client server. So basically, we have to do configuration management. So as to, without, going inside the client system, we'll have to install a particular piece of software inside it. Okay, so let me quickly do an SSH into my AWS machine. And what I'm gonna do is, I have a slave machine which I have already configured, which can interact with my master. That is, if I do a Ansible ping all, you can see that there is a server 1 that I have configured, which has successfully responded to my master's request. Okay, now let me show you the server, which is basically working. So this is the server which is configured with my master, right? This is my client machine, and on this machine I'll have to install Apache. So if I right now go to the IP address of this machine, it says connection refused. Reason being that there is nothing installed on this server, or there is no Apache software installed on this particular server right now. All right, so let's install Apache. Now to do that, you will have to write a playbook. Now what is a playbook? A playbook looks something like this. So it's basically a YAML file that you'll have to create. So I have created one for me. So where do you want to install the Apache software is the part where you'll have to specify in hosts. So basically my client machine is a part of a group called servers that I've created, right? So the hosts are servers, and where can you actually specify what part is your machine, or which group is your machine a part of? So that you can specify over here. So it's in /etc/ansible and /hosts. Okay, so as you can see over here, this is the group name, that is servers, and inside servers I've specified a server 1 client machine which has the IP address this. So this is the IP address of my slave. So if you can compare, it's 18.223.101.172, and if I compare it with my slave, this is the IP address of my slave, right? And this has been configured over here. So I can refer to my server 1 as servers, or I can refer it to as server 1, right? So if I do, let me do a clear over here, I can say Ansible -m ping, and I can say server 1 as well. It will reach out to my server 1, or I can say servers as well, because it's part of the group servers. Okay, so this is how it works. Now I want to install Apache. So for installing Apache, I'll have to write a playbook which looks like this. Basically it's a YAML file. So you start with the 3 dashed lines, and then you specify hosts. So hosts, I've specified every server, every machine which is inside the servers group should install Apache on it, right? And what is the task? I want to install Apache 2. This is basically a name. You can specify anything over here. Then I've specified APT. Basically, I want to use the APT package to install Apache 2, the latest software. Okay. Now, what I will do, I will type in Ansible -playbook, and I'll type in Apache .yaml. I'll hit enter, and now it has started to install everything. So it is installing on the servers group. It is gathering the facts, and it saw that it is able to communicate with server 1, and now it is accomplishing the task of installing Apache. All right, so it has been done successfully. So if I go to my Chrome browser now, and if I refresh the address, you can see that Apache is installed on this server automatically. So I didn't have to basically SSH into the server. It all happened automatically. And if I had like 5-6 computers which were running on AWS, and if I wanted to install the software on it using Apache, using Ansible, this would have been the same way. It's only that in the server group, I would have specified more IP addresses which my Ansible could talk to. Okay, so this was our task of basically deploying an Ansible playbook on a client server without SSH, doing an SSH into that client server and doing it from a central location. All right, so this is done. Now let's move on to our next domain, which is continuous testing. Now, what is continuous testing? So we talked about continuous development, which is done using GitHub. We talked about continuous integration, which is possible using Jenkins. We talked about continuous configuration management, which can be done using Ansible. And next online is we have continuous testing. So once the code has been deployed, it has been integrated with Jenkins, it has been deployed on a server. The next thing is automated testing that we discussed in the best practices before, right? And it can be done using a tool called Selenium, a software called Selenium WebDriver, right? So the first question is, list out the technical challenges with Selenium. So the Selenium tool is used widely for automatic testing or automated testing, but what are the problems that you get with Selenium? So if you're using Selenium, mobile testing cannot be done. So if you have developed an application for your mobile, you cannot test it using Selenium. The reporting capabilities of Selenium are very limited. If your application or your web application deals with pop-up windows or it gives pop-up windows, Selenium would not be able to recognize those pop-up windows and work on them. And again, Selenium is only limited to web applications. So if you have an application that probably runs on desktop, probably it's a software that you have designed, you cannot test that software using Selenium. Selenium is only for those applications which can run inside a browser. And if you want to check whether there is some image in your web page and that image should have some particular content, it is a little difficult to implement it in Selenium. Although it is not impossible, it is possible. You'll have to import some libraries and other things like that. But natively, Selenium does not support image testing. You'll have to work around. You'll have to work around with Selenium to import some libraries which could do it for you. But like I said, natively Selenium does not support image testing. So our next question is, what is the difference between verify and assert commands? So let us see the differences. So if you're using assert in Selenium, if the command fails, the whole execution comes to a halt. Whereas in verify, it does not come to a halt. It keeps on continuing the rest of the lines which are written in the code. Now, how can it be helpful? How is it helpful to basically put execution at halt whenever there is an error which occurs for a particular line? It is helpful when you're dealing with critical cases. Like for example, if there are 5 cases and say if case 3 fails, case 4 and 5 cannot execute because they have a dependency on case 3. In those cases, I would say that you would have to use assert with the case 3. But in the same example, if you talk about case 1 and case 2, they do not have a dependency or they do not create a dependency for any other test cases that have to run, right? For example, case 3, case 4, case 5 are not dependent on case 1 and case 2. In those cases, we can run the verify command, which will not stop even if the test case fails, right? And this basically is done to basically see what all is working and what all is not in one shot in a testing program. And For those cases, you would use verify. But in the cases where you are testing critical cases and you do not want to waste your time testing other things, if one of your case fails, in those cases, you will use the assert test. So like I said, it is used to validate critical functionality, assert command, and verify is used to validate functionality which is of the normal behavior kind of scenario, which comes into the normal behavior. That is, it does not create a dependency for other things to not work because it stopped working. All right. So our next question is, what is the difference between set speed and sleep methods? So set speed is basically used for executing tasks at a particular interval that we specify. For example, say I want to echo hello world at intervals of 5 seconds. In that case, I can specify it using set speed. But sleep method basically suspends the execution of the whole program for a particular interval. For example, if you're doing a Selenium web test and the web page takes around 3 seconds to load, and you don't want testing to happen just after each line, you can specify a sleep method of say around 3 seconds, where it waits for 3 seconds for the website to load, and only then it will start executing the tests which follow that particular line. All right. So this is the difference between set speed and sleep.